So hello friend, going to start studying. Today I'm going to continue the what's say hands-on machine learning book, chapter number 3, classification. So it's opening now. Okay, this is really taking a lot of time. It's 35-degree here. Very good afternoon, 11th of June. SPG5 is open now. Now I starting the book hands-on machine learning, chapter number 3, classification. Okay, zooming in so you can see properly. Okay, and okay, page number I think it was 130, 131, 131, 131. Yeah. You can zoom in and make a full screen. Okay, now play it.
Select and train a model.
Classification, classification. Okay,
Classification.
chapter number 3.
In Chapter 1, I mentioned that the most common supervised learning tasks are regression
Regression.
and classification. In Chapter 2, we explored a regression task, predicting housing values, using various algorithms such as linear regression, decision trees, and random forests. Now we will turn our attention to classification systems. MNIST. In this chapter, we will be using the MNIST dataset, which is a set of 70,000 small images of digits handwritten by high school students and employees of the U.S. Census Bureau. Each image is labeled with the digit it represents. This set has been studied so much that it is often called the hello world of machine learning. Whenever people come up with a new classification algorithm, they are curious to see how it will perform on MNIST, and anyone who learns machine learning tackles this dataset sooner or later. Provides many helper functions to download popular datasets. MNIST is one of them. The following code fetches the MNIST dataset from open-ml.org. From Scikit-Learn.datasets import fetch OpenML. MNIST equal to fetch OpenML. The Scikit-Learn.datasets package contains mostly 3 types of functions. Fetch
So
functions such as fetch OpenML.
what I can do, I will just open that notebook, Jupyter notebook that I opened yesterday. Just write it hands-on machine learning book. Okay, and side by side I will see the code that is written here in the notebook, and side by side I will read the uh, chapter number 3. Hmm. So going to open it. Classification. Okay, starting it classification, and I think I have to zoom out it. Yeah, yeah. This is good. Now you can see properly. Starting from this.
The Scikit-Learn
So this the first code that I was talking about was here from Sklearn to database import fetch OML open machine learning classification. Okay, fine.
datasets package contains mostly 3 types of functions. Fetch functions such as fetch OpenML to download real-life datasets. Load functions. To load small toy datasets bundled
So
with.
here you can see first you have to set up your system. You can this project requires Python 3.7. You can install it, and then after doing this, you have to import this database MNIST from sklearn.datasets import fetch openml. Now you can the fetch the OpenML data from here and put in MNIST and then print MNIST.decr in. Okay, do this. Okay, fine.
The Scikit-Learn.datasets package contains mostly 3 types of functions. Fetch functions such as fetch OpenML to download real-life datasets. Load functions. to load small toy datasets bundled with Scikit-Learn, and make functions to generate fake datasets useful for tests. Generated datasets are usually returned as in tuple containing the input data and the targets, both as NumPy arrays. Other datasets are returned as sklearn.utils. Bunch objects, which are dictionaries whose entries can also be accessed as attributes. They generally contain the following entries. Deskar. Data, the input data, usually as a 2D NumPy array target.
So you can see here there is DSCR, a description of the data set you can see here is printed here. You can see this is the MNIC database of handwritten digits with 784 features. Okay, raw data available at this website you can visit. You can see here. So now the data you can see here and the target, the labels usually a 1D NumPy array. Okay,
Labels, usually as a 1D
data and the keys you can see.
NumPy array, a description of the dataset. The fetch OpenML function is a bit unusual, since by default it returns the inputs as a pandas data frame, and the labels as a pandas series. But the MNIST dataset contains images, and data frames aren't ideal for that, so it's preferable to set as frame equal to false to get the data as NumPy arrays instead. Let's look at these arrays, x, y equal to MNIST. Data. MNIST, target x array. mis.target x array. MNIST, target x array, type equal to object, and each image has 70,000 images. This is because each image is 28 times 28 pixels, and each feature simply represents 1 pixel's intensity, from 0 to 255. All we need to do is grab an instance's feature vector, reshape it to a 28 times 28 array, and display it using Matplotlib's imshow function. We use cmap equal to binary to get a grayscale color map where 0 is white and 255 is black. Image plt.
So this code you have, you can see here. This code is written here. This is the MNIST dot keys, and you can see the keys, data, target, frame, categories, features, names, target names, and description, details, and URL. You can see here. And XY MNIST data, MNIST dot target X, and you see this. The X dot sep is 7,784. And Y is array, you can see this, and Y dot sep 7,000, 28 into 28, 784. Now you can see the plot digit, import matplotlib dot pile plot as plot, def plot digit, image data dot resep 28 28. Plot imso, image source cmap binary plot dot axis off. Okay, you can see this.
.imshow plt.axis. Some digit equal to x plot digit pltd.
Some digit, plot digit is some digit. Okay, and save figure some digit plot. And this will be figure save. This is extra code for saving the figure as a sum digit plot, and the plot dot show will show the plot. Okay, this is the way that you can see all the things.
I figure 3-1.
Example
of an MNIST image.
This is the first figure x. We have defined here x0. This is the first index figure, 0 index figure.
This looks like a 5, and indeed that's what the label tells us.
Y0.
5. To give you a feel for the complexity of the classification task, figure 3-2 shows a few more images from the MNIST dataset. But wait, you should always create a test set and set it aside before inspecting the data closely. The MNIST dataset returned by fetch open.
Let me check. Is audible? Yeah, fine. But wait.
You should always create a test set and set it aside before inspecting the data closely. The MNIST dataset returned by fetch OpenML is actually already split into a training set and a test set. 2. Xtrain, Xtest, Ytrain, Ytest equal to X, X, Y, Y.
So you can see the training set 16,000 images and test set is 10,000 images. So this you can find out by using this command. This is extra code for finding all the figures. Plot dot figure size 99 for index image data and enumerate X the 200 subplot 1010 idx plus 1 plot digit image data, and then you can see this and all things are plotted and plots of this data. Okay, xtrain, xtest, ytest. This is you can see xtrain test 16,000 and xtest 16,000 starting from this, and ytrain touch 16,000 and ytest starting from 6,000. Okay, you can see this. So this is great.
The training set is already shuffled for us, which is good because this guarantees that all cross-validation folds will be similar. Moreover, Some learning algorithms are sensitive to the order of the training instances, and they perform poorly if they get many similar instances in a row. Shuffling the dataset ensures that this won't happen. 3. Figure 3-2, digits from the MNIST dataset, training a binary classifier.
This is taken
Let's
from here.
simplify the problem for now, and only try to identify one digit, for example, the number 5.
5, yeah.
This 5 detector will be an example of a binary classifier, capable of distinguishing between just two classes, 5 and
5 and not
9-5.
5.
First, we'll create the target vectors for this classification task.
So we are classifying into two classes, either 5 or other is not 5. Okay, this is a binary classifier. So white and 5, white and equal to 5, and white test equal to 5, white test equal to 5. Okay.
5 equal to hashtag true for all 5 seconds, false for all other digits y test 5. Now let's pick a classifier and train it. A good place to start is with a stochastic gradient descent classifier, using Scikit-Learn's SGD classifier class. This classifier is capable of handling very large datasets efficiently. This is in part because SGD deals with training instances independently, one at a time, which also makes SGD well suited for online learning, as you will see later.
Yeah.
Let's create an SGD classifier and train it on the whole training set. SGD CLF, SGD classifier, SGD CLF.fit. Now we can use it to detect images of the number 5. GD CLF predict array. The classifier guesses that this image represents a 5. Looks like it guessed right in this particular case. Now let's evaluate this model's performance. Performance measures. Evaluating a classifier is often significantly trickier than evaluating a regressor, so we will spend a large part of this chapter on this topic. There are many performance measures available, so grab another coffee and get ready to learn a bunch of new concepts and acronyms. Measuring accuracy using cross-validation. A good way to evaluate a model is to use cross-validation, just as you did in Chapter 2.
Yeah, cross-validation.
Let's use the cross-val score function to evaluate our SGD classifier model, using k-fold cross-validation with 3 folds. Remember that k-fold cross-validation means splitting the training set into k-folds, then training the model k times, holding out a different fold each time for evaluation. From Scikit-Learn.model selection, import cross-val score array. Wow! Above 95% accuracy on all cross-validation folds. This looks amazing, doesn't it? Well, before you get too excited, let's look at a dummy classifier that just classifies every single image in the most frequent class, which in this case is the negative class. From Scikit-Learn.dummy import dummy classifier. Dummy CLF dummy classifier dummy CLF.fit. Print #print.
Scikit-Learn.dummy import dummy classifier. You can see this, the dummy classifier. We assign the dummy CLF, which you assign the dummy classifier here, and then fit it from extrend to y trend 5, and print the dummy CL5 to predict extrend. Okay, the 5 is detected or not detected. It's still false because not detected.
It's false. No 5 seconds detected. Can you guess this model's accuracy? Let's find out. Cross-val score array. That's right, it has over 90% accuracy. This is simply because only about 10% of the images are 5 seconds.
Yeah.
So if you always guess that an image is not a 5, you will be right about 90% of the time. Beats Nostradamus. This demonstrates why accuracy is generally not the preferred performance measure for classifiers, especially when you are dealing with skewed datasets. That is when some classes are much more frequent than others. A much better way to evaluate the performance of a classifier is to look at the confusion matrix, implementing cross-validation. Occasionally, you will need more control over the cross-validation process than Scikit-Learn provides off the shelf. In these cases, you can implement cross-validation yourself. The following code does roughly the same thing as Scikit-Learn's cross-val score function, and it prints the same result from Scikit-Learn.model selection. Import stratified k-fold from Scikit-Learn.base. Import clone scfolds equal to stratified k-fold #add shuffle equal to true if the dataset is hashtag not already shuffled for train index, test index, and sk folds. Clone CLF equal to clone xtrain folds equal to xtrain, folds equal to ytrain 5, xtrain y test, clone CLF.fit. We pred equal to clone CLF.predict. And correct equal to sum print, #print 0.9, 5 stratified sampling folds that contain a representative ratio of each class. At each iteration, that creates a clone of the classifier, trains that clone on the training folds, and makes the to produce code predictions on the test fold. Then it counts the number of correct predictions and outputs the ratio of correct predictions. Confusion matrices. The general idea of a confusion matrix is to count the number of times instances of class A are classified as class B for all AB pairs. For example, to know the number of times the classifier confused images of 8 seconds with osmium, you would look at row 8th, column 0th of the confusion matrix. To compute the confusion matrix, you first need to have a set of predictions so that they can be compared to the actual targets. You could make predictions on the test set, but it's best to keep that untouched for now. Instead, you can use the cross-val predict function from Scikit-Learn.model selection. Import cross-val predict. ytrain pred equal to cross-val predict. Just like the cross-val score function, cross-val predict performs k-fold cross-validation, but instead of returning the evaluation scores, it returns the predictions made on each test fold. That you get a clean prediction for each instance in the training set. Now you are ready to get the confusion matrix using the confusion matrix function. Just pass it the target classes and the predicted classes. From Scikit-Learn.metrics import confusion matrix.cm equal to confusion matrix cm array. Each row in a confusion matrix represents an actual class, while each column represents a predicted class. The first row of this matrix considers non-5 images. 53,800 were correctly classified as non-5s, while the remaining 687 were wrongly classified as 5 seconds. The second row considers the images of 5 seconds. 1,891, while the remaining 3,591. A perfect classifier would only have true positives and true negatives, so its confusion matrix would have non-zero values only on its main diagonal. Ytrain perfect predictions equal to ytrain5 hashtag. Pretend we reached perfection confusion matrix. Array. The confusion matrix gives you a lot of information, but sometimes you may prefer a more concise metric. An interesting one to look at is the accuracy of the positive predictions. This is called the precision of the classifier. Equation 3:1. Precision. TP is the number of true positives, and FP is the number of false positives. A trivial way to have perfect precision is to create a classifier that always makes negative predictions, except for one single positive prediction on the instance it's most confident about. If this one prediction is correct, then the classifier has 100% precision. Obviously, such a classifier would not be very useful, since it would ignore all but one positive instance. So precision is typically used along with another metric named recall, also called sensitivity, or the true positive rate. This is the ratio of positive instances that are correctly detected by the classifier.
Yeah.
Equation 3:2. Recall.
So
Fn is
you learned that for the precision, you have to use this formula: the true positive divided by true positive plus false positive. This is the precision. Okay. The number of true positive, and if it's number of false positive, a trivial way to have a perfect precision is to create a classifier that will always make a negative prediction, except for one single positive prediction on the instance it's more confident about. If this one
prediction is correct,
the
then the
classifier
classifier has
has
100% precision.
100% precision.
Obviously, such a classifier would not be very useful, since it would ignore all but one positive instance.
Yeah.
So precision is typically used along with another metric named recall, also called sensitivity, or the true positive rate.
Right.
This is the ratio of positive instances that are correctly detected by the classifier. Equation 3.
This is recall. Recall true positive divided by true positive plus false negative. Recall.
2. Recall. Fn is of course the number of false negatives. If you are confused about the confusion matrix, figure 3-3 may help. Figure 3-3 and illustrate.
You can see here an illustrated confusion matrix showing example of true negative. This is a true negative top left, and false positive. You can see false positive at here top right. Okay. False positive at top right and false negative as lower left, and true positive as lower right. Okay, fine.
Illustrated confusion matrix showing examples of true negatives, false positives, false negatives, and true positives. Precision and recall. Scikit-Learn provides several functions to compute classifier metrics, including precision and recall. From Scikit-Learn.metrics import precision score, recall score. Precision score hashtag equal to 3,530 zeroths. 8,700,879,772,350,012. Recall score hashtag equal to 3,530 zeroths. 6,511,705,958,311. Now our 5 detector does not look as shiny as it did when we looked at its accuracy. When it claims an image represents a 5, it is correct only 83.7% of the time. Moreover, it only detects 65.1% of the 5 seconds. It is often convenient to combine precision and recall into a single metric called the F-score, especially when you need a single metric to compare two classifiers. The F1 score is the harmonic mean of precision and recall. Whereas the regular mean treats all values equally, the harmonic mean gives much more weight to low values. As a result, the classifier will only get a high F score if both recall and precision are high.
Yeah.
Equation 3-3, F score. To compute the F1 score, simply call the F function. From Scikit-Learn.metrics import FF 0.7325171197343846. The F score favors classifiers that have similar precision and recall. This is not always what you want. In some contexts, you mostly care about precision, and in other contexts, you really care about recall. For example, if you trained a classifier to detect videos that are safe for kids, you would probably prefer a classifier that rejects many good videos but keeps only safe ones, rather than a classifier that has a much higher recall, but lets a few really bad videos show up in your product. On the other hand, suppose you train a classifier to detect shoplifters and surveillance images. It is probably fine if your classifier only has 30% precision, as long as it has 99% recall. Unfortunately, you can't have it both ways. Increasing precision reduces recall, and vice versa. This is called the precision recall
Fair enough.
trade-off.
So is enough for today. The precision recall trade-off. Let's. Okay, I will. For tomorrow, I will continue this. Will be better. Precision. What I do? MNIT, MNIST performance measure. Okay, till ROC curve I will do 143. Okay, it will be better. Till ROC curve I will continue it. Okay, fine.
The precision recall trade-off. To understand this trade-off, let's look at how the SGD classifier makes its classification decisions. For each instance, it computes a score based on a decision function.
Cross it. Make it small.
If that score is greater than a threshold, it assigns the instance to the positive class. Otherwise, it assigns it to the
This is
negative.
again
Favors
important.
classifiers that have similar precision and recall. This is not always what you want. In some contexts, you mostly care about precision, and in other contexts, you really care about recall. For example, if you trained a classifier to detect videos that are safe for kids, you would probably prefer a classifier that rejects many good videos but keeps only safe ones,
Yeah.
rather than a classifier that has a much higher recall, but lets a few really bad videos show up in your product. On the other hand, suppose you train a classifier to detect shoplifters and surveillance images. It is probably fine if your classifier only has 30% precision, as long as it has 99% recall. Unfortunately, you can't have it both ways. Increasing precision reduces recall, and vice versa. This is called the precision recall trade-off. The precision recall trade-off. To understand this trade-off, let's look at how the SGD classifier makes its classification decisions. For each instance, it computes a score based on a decision function. If that score is greater than a threshold, it assigns the instance to the positive class. Otherwise, it assigns it to the negative class. Figure 3-4 shows a few digits positioned from the lowest score on the left to the highest score on the right. Suppose the decision threshold is positioned at the central arrow. You will find 4 true positives on the right of that threshold, and 1 false positive. Therefore, with that threshold, the precision is 80%. But out of 6 actual 5 seconds, the classifier only detects 4, so the recall is 67%. If you raise the threshold, the false positive becomes a true negative, thereby increasing the...
So here you can see, here very important. Therefore, the threshold with precision is 80%, 4 out of 5. 80%, okay. But out of 6 actual 5s, the classifier only detect 4. So the recall is 67%, 4 out of 6. Here you can see. You will have find 4 true positive and right of the threshold and 1 on the right, okay, and 1 false positive as 6, okay. So you can calculate the by formula. The precision is 80%. 4 divided by 4 plus 6. Okay. 4 plus 1, 5. 4 by 5, 80%. But out of 6 actual 5, the classifier will take 4. So the recall is 67%. Okay. Nice, nice. Fine, okay.
If you raise the threshold, the false positive becomes a true negative, thereby increasing the precision, but 1 true positive becomes a false negative, decreasing recall down to 50%. Conversely, lowering the threshold increases recall and reduces precision. Figure 3-4. The precision recall trade-off. Images are ranked by their classifier score, and those above the chosen decision threshold are considered positive. The higher the threshold, the lower the recall, but the higher the precision. Scikit-Learn does not let you set the threshold directly, but it does give you access to the decision scores that it uses to make predictions. Instead of calling the classifier's predict method, you can call its decision function method, which returns a score for each instance, and then use any threshold you want to make predictions based on those scores. Y-scores equal to sgdclf.decision function. Y-scores array threshold equal
So here you can see the code written for here. Y scores equal to SCD CLF dot decision function, some digits, okay, and y scores, you have seen this, and threshold 0, y some digit prediction, y score is greater than threshold, and array is 2. Fine.
0y some digit pred equal to array. The SGD classifier uses a threshold equal to 0, so the preceding code returns the same result as the predict method. Let's raise the threshold equal to 3000y some digit pred array.
Yeah.
This confirms that raising the threshold decreases recall. The image actually represents a 5%, and the classifier detects it when the threshold is 0, but it misses it when the threshold is increased to 3000. How do
This
you
is very important. The image actually represents a 5. A classifier when the threshold is 0, but it misses when the threshold is increased to 3000. Just depend on threshold. If it's 0, then the recall is very high. The image will recall very 5. Image actually represents as 5. Okay.
decide which threshold to use? First, use the cross-val predict function to get the scores of all instances in the training set. But this time specify that you want to return decision scores instead of predictions. Y scores equal to cross-val predict. With these scores, use the precision recall curve function to compute precision and recall for all possible thresholds. From Scikit-Learn.metrics import precision recall curve. Precisions, recalls, thresholds equal to precision recall curve. Finally, use matplotlib to plot precision and recall as functions of the threshold value. Let's show the threshold of 3000 we selected. PLT do plot. Label equal to precision. Line width equal to 2. Label equal to precision. Line width equal to. Lines hashtag beautify the figure. Add grid, legend, axis, labels and circles PL show. Precision and recall versus the decision threshold. You may wonder why the precision curve is bumpier than the recall curve in figure 3-5. The reason is that precision may sometimes go down when you raise the threshold. To understand why, look back at figure 3-4 and notice what happens when you start from.
Okay, I'm looking back. The figure 3.4, you can see this. So here you can see the precision recall trade-off images are ranked by the classifier score. Okay, and those above the chosen decision threshold are considered positive, and higher the threshold, lower the recall, but in general higher the precision. So you can see.
To understand why, look back at figure 3-4 and notice what happens when you start from the central threshold and move it just
Move it
one
one
digit to
digit
the
to the
right.
right.
Precision goes from 4/5 down to
Precision become
3/4.
higher.
On the other hand, recall can only go down when the threshold is increased, which explains why its curve looks smooth. At this threshold value, precision is near 90% and recall is around 50%. Another way to select a good precision recall trade-off is to plot precision directly against recall, as shown in figure 3-6. Plot hashtag beautify the figure. Add labels, grid, legend, arrow, and text PLT to show. Figure 3-6. Precision versus recall. You can see that precision really starts to fall sharply at around 80% recall. You will probably want to select a precision recall trade-off just before that drop, for example, at around 60% recall. But of course, the choice depends on your project. Suppose you decide to aim for 90% precision. You could use the first plot to find the threshold you need to use, but that's not very precise. Alternatively, you can search for the lowest threshold that gives you at least 90% precision. For this, you can use the numpy array's argmax method. This returns the first index of the maximum value, which in this case means the first true value. IDX for 90 precision equal to .argmax, IDX for 90 precision, IDX for 90 precision thresholds. IDX for 90 precision? To make predictions, instead of calling the classifier's predict method, you can run this code. Precision score 0.9. 000345901072293 recallet. 90 precision. Equal to recall score recallet. 90 precision. Equal to recall score. 5. To have a 90% precision classifier. As you can see, it is fairly easy to create a classifier with virtually any precision you want. Just set a high enough threshold and you're done. But wait, not so fast. A high precision classifier is not very useful if its recall is too low. For many applications, 48% recall wouldn't be great at all. If someone says, let's reach 99% precision, you should ask, at what recall?
At what recall? You have to ask. So enough for today, and so okay, continuing it. So I will summarize. Yeah, yesterday I was doing something. I was creating the podcast. So I think the podcast is ready now. So going to play the podcast of chapter number 2, complete chapter.
What interesting quirks did this reveal in the housing dataset histograms?
Several. The median income was scaled.
Starting from
Real
this.
estate companies grapple with a seemingly straightforward question: how to accurately price homes. But what if their existing manual methods are consistently off by over 30%? Today, we are exploring the journey of tackling such a complex business problem, transforming it into a machine learning solution, and building it from start to finish. Noah, this sounds like a familiar scenario for many data scientists.
Certainly is. Maggie, Aurélien Geron, in his book Hands-on Machine Learning with Scikit-Learn, Keras, and TensorFlow, dedicates an entire chapter to this end-to-end process. He uses the California housing prices dataset as a case study, imagining we are data scientists tasked with predicting median housing prices based on census data. It is a fantastic way to illustrate the entire workflow.
So, right from the outset, the book emphasizes working with real-world data, which makes sense. What is the very first step in framing a problem like this?
The first step is always to understand the business objective. We are building a model to predict median housing prices in various districts. This output is not an end in itself. It feeds into a larger machine learning system that decides whether an area is a worthwhile investment. Knowing this context shapes every subsequent decision.
And the existing solution, those manual estimations that were so inaccurate, how does understanding that help?
It provides a crucial baseline. The fact that human experts are off by over 30% tells us two things. First, there is significant room for improvement, and second, we cannot expect perfection. It also guides our choice of machine learning task. Given that we are predicting a continuous numeric value, the median housing price, this is clearly a supervised learning regression problem.
And is it univariate or multivariate regression?
It is a multiple regression problem because we are using several features like population and median income. However, it is univariate regression as we are only predicting a single value, the median house price. As for learning type, since there is no continuous data flow and data fits in memory, batch learning is suitable.
What about the performance metric? RMSE is mentioned as typical. Why that over, say, mean absolute error?
The root mean square error, or RMSE, is a common choice because it penalizes larger errors more heavily. This often aligns with business goals, where large prediction errors can be more costly. The book notes that RMSE is akin to the Euclidean norm measuring distance, while mean absolute error, MAE, is like the L1 norm, less sensitive to outliers. The choice depends on the specific problem context and how you want to weigh errors.
Before diving deep into the data, the book stresses checking assumptions. Can you give an example of why this is so critical at an early stage?
Absolutely. Suppose the downstream system only cared if a house was cheap or expensive, not the exact price. Our problem would then shift from regression to classification. Discovering this months into a regression project would be a massive waste of resources. Aeron emphasizes constant communication with stakeholders to avoid such pitfalls.
Once we have framed the problem, it is time to get the data. The book mentions automating data fetching. Why is that important?
Automating data fetching is key for reproducibility and scalability. If data updates regularly, an automated script ensures you always work with the freshest information. It is also invaluable when deploying your system across multiple machines. For our housing dataset, it involves downloading a compressed file and extracting a CSV, handled efficiently by a Python function.
Nice.
And looking at the data structure, what are some of the first things a data scientist should check?
First, use head to preview rows, then info to a summary of total rows, attribute types, and null values. The California housing data, for instance, has about 20,640 entries. We quickly notice total bedrooms has missing values, which will need handling. Also, ocean proximity is an object type, hinting at categorical data, confirmed by value counts revealing distinct categories like inland or 1H ocean.
The describe method shows us statistical summaries. What interesting quirks did this reveal in the housing dataset histograms?
Several. The median income was scaled and capped, not expressed in raw USD. And housing, median age, and median house value were also capped. The median house value being capped is a serious concern as it's our target attribute. If our model learns prices never exceed $500,000, it'll make inaccurate predictions for higher value homes. We would need to either collect more precise data or remove these capped districts. Also, many attributes like population are skewed right, meaning they extend far to the right of the median, which can pose challenges for some machine learning algorithms.
And before any deeper exploration, the book insists on creating a test set. Why is it so critical to do this before gaining further insights?
This is crucial to avoid data snooping bias. Our brains are excellent pattern detectors. If we look at the entire data set, including the test set, we might unconsciously spot patterns that influence our model choices. This leads to an overly optimistic estimate of the generalization error, and our model will not perform as well in the real world. Jaron calls it a hidden trap.
So, how do we create a robust test set, especially if we have continuously updating data?
A simple random split, say 80% for training and 20% for testing, using train test split works. However, if the dataset updates, the test set may change. A more stable approach involves using a hash of each instance's unique identifier to consistently assign it to either the training or test set. This ensures consistency, even with new data. But what if there are important attributes, like median income in our case, that we need to ensure are well represented in both sets?
That sounds like stratified sampling.
Precisely. We create income categories using pd.cut and then use Scikit-Learn's stratified shuffle split. This divides the data into homogeneous subgroups, or strata, and samples proportionately from each, preventing sampling bias. This ensures our test set accurately reflects the income distribution of the overall population.
With the test set safely tucked away, we moved to data exploration. What visualizations proved most insightful for the housing data?
Geographical scatter plots, especially with an alpha blending of 0.2, immediately highlighted high-density areas like the Bay Area and Los Angeles. Color coding by median house value and sizing by population clearly showed that housing prices are highly correlated with location and population density, often near the ocean. This suggests proximity to the ocean might be a valuable feature.
The book then delves into finding correlations. What was the strongest positive correlation with median house value?
The median income had the strongest positive correlation, with a coefficient close to 0.7. Visualizing this with a scatter plot revealed a clear upward trend. It also highlighted those pesky price caps around $500,000 and other horizontal lines indicating less obvious data quirks that might need cleaning.
And what about experimenting with attribute combinations? Did any new features stand out?
Yes, bedrooms ratio, the total number of bedrooms divided by total rooms, showed a strong negative correlation. Houses with a lower bedroom to room ratio tend to be more expensive. Rooms per house was also more informative than raw total rooms. These engineered features often improve model performance significantly.
After exploration, we prepare the data. The book advocates writing functions for all transformations. What is the benefit of this?
Writing functions ensures reproducibility, reusability for future projects, and consistency between training validation and production data. It also allows treating pre-processing choices as hyperparameters, enabling us to easily experiment with different transformation combinations to find the best performing setup.
So, tackling those missing total bedrooms values, what are the options and the recommended approach?
We have three options. Drop the districts with missing values, drop the entire total bedrooms attribute, or impute them. The least destructive approach is imputation. Jaron recommends using Scikit-Learn's simple imputer with a median strategy. This stores the median value, allowing consistent imputation across all datasets, including new live data.
And for categorical attributes like ocean proximity, how do we handle them since machine learning algorithms prefer numerical data?
First, we can use ordinal encoder to convert categories to numbers. But this implies an order that does not exist, like inland being closer to island than near ocean. The better solution is one-hot encoding, creating a binary attribute for each category. Scikit-Learn's one-hot encoder does this, outputting a sparse matrix to save memory, especially for many categories. It also handles unknown categories gracefully, preventing errors in production.
Feature scaling is also critical. Why is it so important for most machine learning algorithms?
Algorithms struggle when numerical attributes have vastly different scales. Imagine total rooms ranging up to 39,000 and median income only up to 15. Without scaling, median income would be practically ignored. The two common methods are min-max scaling, which scales values to a 0-1 range, and standardization, which scales to a 0 mean and unit variance. Standardization is generally preferred as it is less affected by outliers. For heavily skewed or multimodal features, transformations like taking the logarithm or bucketizing can help.
And to streamline all these transformations, especially across different column types, the book introduces pipelines and column transformers.
Yes. Pipeline allows chaining, sequential transformations, ensuring correct order and reusability. For different transformations on different columns, column transformer is invaluable. It applies specific pipelines to designated numerical or categorical attributes, then concatenates the results. It is a powerful way to manage complex pre-processing flows in a structured manner.
No.
With the data prepared, we can finally select and train a model. The chapter starts with simple models like linear regression. What did that reveal?
The linear regression model, despite its simplicity, yielded an RMSE of about $68,600. While better than nothing, it is an example of underfitting. The model is too simple for the complexity of the data. Switching to a decision tree regressor initially showed a training RMSE of 0, which signals extreme overfitting. This highlights why we cannot trust training set performance alone.
And this leads directly into the importance of cross-validation.
K-fold cross-validation provides a more robust estimate of generalization performance. It splits the training data into K-folds, trains the model K times, each time evaluating on a different fold. For the decision tree, cross-validation revealed an RMSE of about $66,800, confirming its high variance and overfitting tendency. Introducing random forest regressor, an ensemble method, drastically improved this to about $47,000, which was much better, but still indicated some overfitting.
So finding a short list of promising models is just the beginning. The next step is fine-tuning. How does the book recommend tackling the vast hyperparameter space?
Manual tweaking is inefficient. Grid Search CV systematically explores all combinations of specified hyperparameter values. However, randomized search CV is often preferable, especially with large search spaces, as it samples a fixed number of random combinations, which can be more efficient in finding good values. Ensemble methods are also key here. Combining strong models often yields even better performance.
And after fine-tuning, the book talks about analyzing the best models and their errors. What insights can be gained here?
Inspecting feature importances from models like random forest regressor helps identify which attributes are most influential. For instance, median income and ocean proximity were very important for housing prices. This can guide further feature engineering or selection. Crucially, analyzing specific errors, especially in subsets of the data like rural versus urban districts, helps uncover biases and improve the model for all categories. Finally, evaluating the system on the untouched test set provides the most honest estimate of generalization error.
And once satisfied, we are ready to launch, monitor, and maintain. How does the book suggest handling this crucial final stage?
Saving the final model using JobLib is essential. Deployment often involves wrapping the model in a web service, possibly using REST or gRPC APIs for scalability and integration. Critically, continuous monitoring for model rot or data drift is needed. Performance can degrade over time due to evolving data. Automating data collection, retraining, and reevaluation is key. If a new version performs better, it is deployed. Otherwise, you roll back. This whole process of continuous integration and deployment in ML is termed ML Ops.
It sounds like a thorough, iterative process. From initial framing to continuous monitoring, every step is vital. This chapter by Aurelian Guérin offers a fantastic roadmap. If you found this discussion insightful, share it with someone interested in understanding the full life cycle of a machine learning project.
Nice, 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 nice. You can share it with your friend. Okay. Now, now it's time for the summary of this third chapter. What I have learned today. Okay, greatness summary. Deep dive. Bullet points. Select chapters. Okay, selecting chapter number 3 till ROC curve. Okay. Performance measure till ROC curve. Okay, ROC curve was also included. Yeah. Then Okay, let it create. The ROC curve I have to complete also today. Okay, multi-class classification, tell this is different. The ROC curve is included in this measure. Okay. Okay, fine.
Classification in machine learning.
Fine,
1.
fine, fine, fine. Press F11, minimize it. Okay. Reading ROC curve. Okay. Okay, currently reading the ROC curve here.
The ROC curve. The receiver operating characteristic curve is another common tool used with binary classifiers. It is very similar to the precision recall curve, but instead of plotting precision versus recall, the ROC curve plots the true positive rate against the false positive rate. The FPR is the ratio of negative instances that are incorrectly classified as positive. It is equal to 1 the true negative rate, which is the ratio of negative instances that are correctly classified as negative. The TNR is also called specificity. Hence, the ROC curve plots sensitivity versus 1, specificity. To plot the ROC curve, you first use the ROC curve function to compute the TPR and FPR for various threshold values. From Scikit-Learn.metrics import ROC curve. FPR TPR thresholds equal to ROC curve. Then you can plot the FPR against the TPR using matplotlib. The following code produces the plot in figure 3-7. To find the point that corresponds to 90% precision, we need to look for the index of the desired threshold. Since thresholds are listed in decreasing order in this case, we use less than equal to instead of on the first line. IDX for threshold at 90.argmax TPR 90, FPR 90 TPR FPR, PLT dot, plot, K, label equal to, random classifiers ROC curve, PLT dot plot, co, label equal to, threshold for 90% precision. Hashtag beautify the figure, add labels, grid, legend, arrow, and text PLT to show. Figure 3-7.
So here you can see the figure that how it generated. You can see the whole code here. In such a nice manner. Okay, figure 6.5. Figure beautifying the figure. Really good. This is false positive rate fallout and true positive rate recall fallout. The ROC curve is this one, and this is the test line is random classifier ROC curve, and threshold for 90% precision is here.
A ROC curve plotting the false positive rate against the true positive rate for all possible thresholds. The black circle highlights the chosen ratio. Once again, there is a trade-off. The higher the recall.
The black circle highlights the chosen ratio. You can see here. Nice. So the ROC curve plotting the false positive rate against the true positive rate for all possible thresholds. You can see.
Once again, there is a trade-off. The higher the recall, the more false positives the classifier produces.
This is very important. The higher the recall, the higher the TPR, the more the false positive FPR. Yeah. You can see the graph. Higher the true positive rate, the more the false positive rate. And the dotted line represents the ROC curve of a purely random classifier. This is the ROC curve for
The dotted line represents the ROC
rectified objective receiver operating characteristic.
curve of a purely random classifier. A good classifier stays as far away from that line as possible. One way to compare classifiers is to measure
Toward the top left corner.
the area under the curve. A perfect classifier will have a ROC AUC equal to 1, whereas a purely random classifier will have a ROC AUC equal to 0.5%.
You can see a perfect classifier have area under curve 1, whereas a purely random classifier will have ROC area under curve 0.5. Yes, 0.5.
The ROC AUC. From Scikit-Learn.metrics import. From Scikit-Learn.metrics import ROC
Area
AUC
under
curve.
since
8616.
it's almost uh, purely random classifier because of that it is 96%, 96.04, 0.9604 means 96.04%. Okay, 49%.
Lithium. You should prefer the PR curve whenever the positive class is rare, or when you care more about the false positives than the false negatives. Otherwise, use the ROS curve. Looking at the previous ROC curve, you may think that the classifier is really good. But this is mostly because there are few positives compared to the negatives. In contrast, the PR curve makes it clear that the classifier has room for improvement. The curve could really be closer to the top right corner. Let's now create a random forest classifier, whose PR curve and F1 score we can compare to those of the SGD classifier. From Scikit-Learn.ensemble import random forest classifier. Forest, CLF, random forest classifier. The precision recall curve function expects labels and scores for each instance, so we need to train the random forest classifier and make it assign a score to each instance. But the random forest classifier class does not have a decision function method, due to the way it works. Luckily, it has a predict proba method that returns class probabilities for each instance, and we can just use the probability of the positive class as a score, so it will work fine. We can call the cross-val predict function to train the random forest classifier using cross-validation and make it predict class probabilities for every image as follows. WeProbas forest equal to cross-val predict. Let's look at the class probabilities for the first two images in the training set. WeProbas forest array. The model predicts that the first image is positive with 89% probability, and it predicts that the second image is negative with 99% probability. Since each image is either positive or negative, the probabilities in each row add up to 100%. These are estimated probabilities, not actual probabilities. For example, if you look at all the images that the model classified as positive, with an estimated probability between 50% and 60%, roughly 94% of them are actually positive. So, the model's estimated probabilities were much too low in this case. But models can be overconfident as well. The Scikit-Learn calibration package contains tools to calibrate the estimated probabilities and make them much closer to actual probabilities. See the extra material section in this chapter's notebook for more details. The second column contains the estimated probabilities for the positive class. So let's pass them to the precision recall curve function. Cores forest equal to YProbas forest precisions forest, recalls forest, thresholds forest, equal to precision recall curve. Now we're ready to plot the PR curve. It is useful to plot the first PR curve as well to see how they compare. plt.plot plt. Plot hashtag beautify the figure, add
Okay, fine. Yeah.
labels grid and legend plt show. Figure 3-8. Comparing PR curves. The random forest classifier is superior to the SGD classifier because its PR curve is much closer to the top right corner, and it has a greater AUC.
The random forest classifier is superior to SDD classifier. That's great. I can see.
As you can see in figure 3-8, the random forest classifier's PR curve looks much better than the SGD classifier's. It comes much closer to the top right corner. Its F-score and ROC AUC score are also significantly better. Ytrain pred forest equal to Yprobas forest greater than equal to 0.5% hashtag positive proba greater than or equal to 50%. Hashtag 0.924227514267131. Try measuring the precision and recall scores. You should find about 99.145. Try measuring the 6 precision. You now know how to train binary classifiers using cross-validation and use several metrics and curves to compare various models. You're ready to try to detect more than Dusty. Multiclass classification.
So I will continue multi-class classification from tomorrow onwards. Till now, I will summarize. I have already summarized the lesson now till I learn. So going to classification in machine learning, I'm going to start this.
Classification in machine learning. 1. Introduction to classification. Core concepts. In the field of supervised learning, classification serves as the task of predicting discrete classes, as opposed to regression, which predicts continuous values. The MNIST dataset, serving as the hello world of machine learning, MNIST contains 70,000 grayscale images of handwritten digits, each measuring 28 times 28 pixels. Data acquisition. Scikit-Learn provides the fetch OpenML function to retrieve datasets like MNIST 784. It is standard practice to set as frame equal to falsetto handle this data as numpy arrays rather than pandas objects. Data structure. Each digit is represented as a feature vector of 784 values, corresponding to pixel intensities ranging from 0 to 255. Preparation steps. The dataset is typically split into a training set and a test set. Shuffling the training set is a critical step to ensure that cross-validation folds remain representative and that learning algorithms are not biased by the order of input instances. 2. Training a binary classifier. Defining the task, a binary classifier distinguishes between two outcomes. By creating a 5 detector, one transforms the target labels into a Boolean array where true indicates a 5 and false represents all other digits. Algorithm selection. The SGD classifier is a robust choice for large datasets because it processes training instances individually, facilitating both efficient computation and online learning capabilities. Model evaluation, While accuracy is a common metric, it can be highly misleading when dealing with skewed datasets where one class significantly outnumbers others. 3. Performance measurement frameworks. Cross-validation using cross-val score. With k-fold cross-validation provides a reliable estimate of model performance by training and testing on different subsets of the data. Implementing custom validation. In scenarios requiring granular control, stratified k-fold allows for manual implementation of cross-validation, ensuring that each fold maintains the same class distribution as the original set. Confusion matrices. This matrix counts instances of class A classified as class B. It explicitly categorizes predictions into true positives, correctly identified positive instances, true negatives, correctly identified negative instances, negative instances incorrectly labeled as positives, positive instances incorrectly labeled as negative. Precision, defined ASTP, $, it measures the accuracy of positive predictions. High precision indicates that when the model predicts a class, it is highly likely to be correct. Recall, defined ASTP, $, it measures the ability of the classifier to find all positive instances. F1 score, this is the harmonic mean of precision and recall. Unlike the standard arithmetic mean, the harmonic mean penalizes low values, requiring both precision and recall to be high for a favorable F1 score. Precision recall trade-off. Increasing the decision threshold improves precision but inevitably lowers recall. Designers must calibrate this threshold based on the specific requirements of the application, such as prioritizing the detection of all shoplifters versus ensuring the safety of kids' content. 5. And model comparison. Receiver operating characteristic. The ROC curve plots the true positive rate against the false positive rate. AUC score, the area under the ROC curve quantifies the classifier's performance. A perfect model scores 1, while a purely random classifier scores 0.5%. Curve selection. As a rule of thumb, the precision recall curve is preferred when the positive class is rare or when false positives are particularly costly. The ROC curve is generally used in other scenarios. Random forest comparison. Unlike SGD classifier, models like random forest classifier lack a decision function, and instead use predict proba. Comparing these models through PR curves often reveals that random forests provide significantly better performance on complex datasets like MNIST. 6. Multiclass classification strategies. Native support. Several algorithms support multiclass classification naturally, including logistic regression and random forests. Binary strategies. For models that do not support multiple classes natively, two strategies are common, one versus the rest, training a dedicated binary classifier for each digit and selecting the class with the highest decision score. 1 versus 1. Training a separate binary classifier for every unique pair of digits. While this requires more classifiers, it is often more efficient for algorithms that scale poorly with large training sets. This overview covers the fundamental workflow for building and evaluating classification systems in Scikit-Learn, emphasizing the necessity of moving beyond simple accuracy metrics to achieve a nuanced understanding of model behavior through precision, recall, and ROC analysis.
Nice. Okay, they're going to listen to the podcast on it, creating podcast, tell what I learned. And chapter number 3. Okay, fine. Till it create what I will do. So going to start it. Okay. The
The
podcast.
simple act of recognizing a handwritten digit, something our brains do effortlessly, is a profoundly complex challenge for machines. In his book, Hands-on Machine Learning with Scikit-Learn, Keras, and TensorFlow, Aurélien Geron introduces us to the MNIST dataset, a collection of 70,000 tiny images of digits. Julian, what makes this particular dataset so foundational in machine learning?
Sophie, the MNIST dataset is often called the hello world of machine learning for good reason. It's a collection of 70,000 small handwritten digit images, each 28 by 28 pixels. Each pixel's intensity is represented from 0 to 255, and crucially, every image comes with a label indicating the digit it represents. It's been studied so extensively that any new classification algorithm is often benchmarked against its performance on MNIST.
That sounds like a lot of data. How do we typically handle such a dataset to ensure we're fairly evaluating a model, particularly regarding the separation of training and testing data?
That's a critical point. The MNIST dataset, as provided by Scikit-Learn's fetch OpenML function, is conveniently pre-split. The first 60,000 images form the training set, and the remaining 10,000 are designated for the test set. This split, along with pre-shuffling the training data, is vital. Shuffling ensures that each cross-validation fold contains a representative mix of digits, and prevents algorithms from performing poorly due to encountering too many similar instances consecutively. It's also a good practice to put your test set aside early and not look at it during development to avoid data snooping bias.
So once the data is ready, how do we begin classifying these digits? Do we try to identify all 10 digits at once? Or is there a simpler starting point?
For our first step, we usually simplify. We can start by building what's called a binary classifier. Imagine a 5 detector whose only job is to distinguish images of 5s from all other digits. We create target vectors that are true for 5s and false for non-5s. For this, a stochastic gradient descent, or SGD classifier from Scikit-Learn is a good starting point because it handles large datasets efficiently and processes instances one at a time, making it suitable for online learning.
And how does this 5 detector perform? I've seen figures like 95% accuracy in similar contexts, which sounds quite impressive.
Indeed, if you evaluate the SGD classifier using k-fold cross-validation, you might see accuracies above 95% on all folds, but that can be misleading. Consider a dummy classifier that simply guesses an image is not a 5 every single time. Since only about 10% of the images are 5s, this dummy classifier would still achieve over 90% accuracy. This highlights why accuracy isn't always a good measure, especially with skewed datasets where some classes are far more frequent than others.
That's a stark reminder that raw accuracy can be deceptive. So if not accuracy, what's a more reliable way to evaluate the performance of a classifier, particularly for these skewed datasets?
A much better approach is to look at the confusion matrix. This matrix counts how many times instances of an actual class A are classified as class B. Each row represents the actual class, and each column represents the predicted class. For a perfect classifier, you'd only see non-zero values along the main diagonal, meaning every instance was classified correctly.
Can you break down the different components of this confusion matrix for us?
Certainly. Let's stick with our 5 detector. The confusion matrix has 4 key parts. True negatives are instances that are actually non-5s and were correctly classified as non-5s. False positives, also known as type 1 errors, are non-5s that were incorrectly classified as 5s. Then you have false negatives, or type 2 errors, which are actual 5s that were incorrectly classified as non-5s. Finally, true positives are actual 5s that were correctly identified as such.
That clarifies the matrix structure. Building on this, 2 other metrics frequently come up: precision and recall. How do these differ from accuracy, and what do they tell us about a classifier's performance?
Precision focuses on the accuracy of positive predictions. It's the ratio of true positives to the sum of true positives and false positives. Essentially, when your model claims something is positive, how often is it right? Recall, also called sensitivity or the true positive rate, measures the classifier's ability to find all the positive instances. It's the ratio of true positives to the sum of true positives and false negatives. So out of all the actual positive instances, how many did your model correctly detect?
I see. So a high precision means few false positives, and high recall means few false negatives. But often it's not possible to have both simultaneously, is it? This leads us to the precision recall trade-off. Can you explain that?
That's right, there's almost always a trade-off. The SGD classifier, for instance, makes classification decisions based on a decision function score. If this score is above a certain threshold, it's classified as positive. If you raise that threshold, you'll generally increase precision because you're being stricter about what you call a positive. However, you'll also likely miss more actual positive instances, thus decreasing recall. Conversely, lowering the threshold increases recall but decreases precision. It's a balancing act driven by the specific needs of your project.
So how do we decide where to set that threshold? How do we find the sweet spot for our specific problem?
We visualize it using a precision recall curve. This plots precision directly against recall for all possible threshold values. You can identify the point where precision starts to fall sharply, and that might be a good area to select your trade-off. For example, if you need 90% precision, you'd find the lowest threshold that achieves at least that precision on the curve. This gives you a clear visual guide to understand the implications of different threshold choices.
Beyond the precision recall curve, the ROC curve is another frequently mentioned tool for evaluating binary classifiers. What does this curve represent, and how does it help in evaluating a model?
The receiver operating characteristic, or ROC curve, plots the true positive rate, which is just another name for recall, against the false positive rate. The false positive rate is the ratio of negative instances incorrectly classified as positive. It's 1 minus the true negative rate, also known as specificity. A perfect classifier would have an ROC curve that goes straight up to the top left corner, covering an area under the curve, or AUC, of 1. A purely random classifier, in contrast, follows a diagonal line from the bottom left to the top right, with an AUC of 0.5.
Given these two powerful tools, the precision recall curve and the ROC curve, when should we use one over the other?
As a rule of thumb, you should prefer the precision recall curve when the positive class is rare or when false positives are more critical than false negatives. For example, in our 5 detector, where 5s are a minority class, the PR curve will give a clearer picture of performance. Otherwise, the ROC curve is generally suitable. The ROC curve can make a classifier look very good if it performs poorly on rare classes, which the PR curve would highlight.
That's a crucial distinction for making informed decisions. Thank you, Jillian, for walking us through the intricacies of binary classification and its evaluation metrics, drawing from Aurelian Geron's insights.
So that's very good. Now it's time to end this and start learning something new today. So doing the Unity game development course today. Opening the Unity game development course now. Learn.unity, yeah, game development, fine. It's opening. So thank you so much for listening to this book. And one thing I can do now is that I will take some break and then I will continue it. So going to start it, the course, game development course of Unity, of logging it. Okay, going to start the lecture now. This is the Unity environment, you can see. This is the Unity. Okay, now I need to make it here. Okay, one minute. Yeah, this book is open. I will study this book after some time and starting by Unity. So I was here till random obstacles. Okay, change the size using high. This was I doing. So what I will do, I will start from the starting because I don't know where I stopped. So now I will play through Speechify. It's a good narrator. Okay, now starting it.
Random obstacle size, direction,
Direction
and
and speed.
speed. Tutorial. Beginner. Plus 10 XP. 5 minutes. 1887. Unity Technologies. In this tutorial, you'll write your first Unity script to control how each obstacle behaves. By assigning random properties like size, direction, and speed, you'll make your game world feel unpredictable and alive. Along
Yeah.
the way, you'll learn key C# scripting concepts, how to edit prefabs directly, and how to test and tune behaviors in real time. 1. Overview. So far, you've added built-in components to your game objects, like the rigid body 2D and collider components, which were created by Unity. These components gave your game objects physics and collision behavior without needing to write any code. 3. Create and attach a new script. 2. A note about learning to code. Now, you're going to create your own component, a custom script that controls how each obstacle behaves when the game starts. A script is like a set of instructions you give to a game object, telling it how to behave when the game runs. The script you're going to create will change the size, direction, speed, and spin of each obstacle. Scripts in Unity are written in C#, a popular programming language used for games, apps, and more. In the project window, right-click the Assets folder and select Create Folder.
Okay. I have already created. I think I have here you can see this is a script folder. Okay, there's a script obstacle. I'm opening it, and you can see the script now. Okay, fine. Play it.
Folder. You'll create the script, name it, and attach it to your obstacle prefab, so every copy of that prefab uses the same behavior. 1. Create a new scripts folder. Name the folder scripts.
Yeah.
2. Create a new C# script. Right-click in the scripts folder and select Create EA Mono Behavior Script. Name the script obstacle. Note, Mono Behavior is the base class that all Unity scripts inherit from. It gives your script access to Unity's built-in features like physics and lifecycle methods. Don't worry about fully understanding it yet. You'll get more comfortable with it over time. Important, Unity requires that the script name exactly matches the class name inside it. If the names don't match,
Here you can see the script name is obstacle, and now you can also see the mono behavior is the best class, and it's the same name obstacle. See, best class is same name as the file name, the script name obstacle.
names don't match, you'll get an error. If you make a mistake on its spelling, delete the script and create it again with the correct name. B.
Yeah.
Attach the script to the prefab. In the project window, select the obstacle prefab. In the inspector window, select Add Component, then search for and add your newly
So you can see this. Let me see the prefab. I will show you the prefab, obstacle prefab, and I already added it in the previous session. You can see the previous session on my YouTube video. Obstacle is added here. This script is added. The script is added here. Okay, fine.
newly created obstacle script component. 4. Confirm the script is attached. The obstacle script will now appear in the obstacle prefabs inspector window. If you select any of the obstacle game objects in the scene, those
you can see here
instances of the prefab will now also have the obstacle script
same
component
obstacle
attached. Any
component
changes you
attached.
make in the script will automatically apply to all prefab instances. You've now created your first custom component, one you'll fully control with your own code. 4. Understand the script structure. 4. Confirm the script is attached. Before you start writing code, it's helpful to understand the structure of a basic Unity script. When you double-click your script file, Unity will open it in your code editor, like Visual Studio or VS Code. The default script comes with two important methods, start and update. These are called lifecycle methods, and Unity calls them automatically at specific times during gameplay. Below that, you'll see a class definition that matches your script's name, public class obstacle, mono behavior. Tip: if nothing happens or you see an error, you might need
The download size is something 45. Yeah, definitely. Thanks. I will update it after some time. Update version. Fine. Let it update. Okay. I read it.
might need to install or set up a code editor. Follow these instructions on how to set up your IDE integration with Unity, or check out the Unity manual page on Visual Studio C# integration. 2. Understand the structure. At the top of the script, you'll see the using statements. These tell the script what code libraries the script can reference. Start runs once when the game object is first created in the scene. Update runs once per frame. It's used to check things like input or movement. Note: your script might look a bit different depending on your version of Unity or which ID you're using, and that's okay. You don't need to fully understand what each part of the code does yet. For now, just focus on recognizing the basic structure. You'll add your own code inside these methods soon. 5. Change the size using a fixed value. Below that, you'll see a class definition that matches your script's name. Public class obstacle. Mono
Over here.
behavior. Let's write your first real line of code. You'll use the start method to change the scale of the obstacle when the game begins. You'll set the obstacle size using a piece of data called a vector3, which holds three values, x, y, and z. In the obstacle script, find the empty start method. You'll set the scale by accessing the game object's transform component, the component Unity uses to store an object's position, rotation.
It's downloading. Okay, fine.
Rotation, and scale. In your code, setting the transform. Local scale affects how big or small the object appears in the scene. Tip: rather than copying and pasting the code below, try typing it out yourself. As you type, you might notice that your code editor suggests autocomplete options, including method names, definitions, and parameters. This is a feature of most modern editors, like Visual Studio or VS Code, and it makes coding faster and less error-prone. If you don't see suggestions as you type, and you're using a macOS, you might need to configure your editor to properly support Unity and C#. Once it's working, autocomplete will save you a lot of time. 1. Add code. Inside the start method, inside the opening and closing curly braces, add the following line of code. Explanation: the x and y values control the width and height. The z value is required, even though it doesn't affect 2D visuals. The equal to sign here doesn't mean is equal to, like in math. It means you're setting the variable on the left to be equal to the value on the right. 2. Save your script. Press Ctrl+, macOS, CMD+, to save the file. Don't close your code editor. You'll be coming back to it. 3. Test in Unity. Switch back to the Unity editor and select the play button. You'll see your obstacles appear at twice the scale they were originally. Exit play mode when you're done testing. You've just written your first line of gameplay code and seen how scripting directly affects your prefab. Next, you'll take this further by giving each obstacle a random size instead of a fixed one.
Okay, fine. Is installing the package. It will take time. So what I will do, I will study my own lesson till it install. Then I will do this thing. Okay. Yeah, nice notes that I am. Okay, fine. Okay, fine.
इस प्रोजेक्ट को मैंने डिजाइन किया है आप लोगों के लिए सच दैट आप लोगों को रियल वर्ल्ड में डेटा एनालिसिस कैसे होता है इसके बारे में पता चले, आप लोगों को एक अच्छा आइडिया लगेगा कि रियल वर्ल्ड कंपनीज में किस तरह से डेटा साइंस का काम होता है। अब फर्स्ट कीजिए कि एक कंपनी है कोड बुक के नाम की, जो कि दिल्ली के कोडर्स का एक सोशल नेटवर्क है। जैसे कि फेसबुक एक सोशल नेटवर्क है, उसी तरह से कोड बुक एक सोशल नेटवर्क है जो कि दिल्ली के कोडर्स का एक सोशल नेटवर्क है। आपके जो मैनेजर है उन्होंने डिसाइड किया इस तरह की कंपनी को फाउंड करेंगे, और इस कंपनी में क्या होगा कि डेटा साइंटिस्ट काम करेंगे ऑब्वियसली, क्योंकि एक सोशल नेटवर्क है, इतना सारा डेटा होगा तो उसको एनालाइज कौन करेगा, उसे इनसाइट्स कौन निकालेगा, कौन एनालाइज करके रिकमेंडेशंस देगा। एक सोशल नेटवर्क को ये सारी चीजें चाहिए होती है। आपका मैनेजर आपके पास आता है, कहता है देखो भाई ऐसा है, तुमको 10 लाख पर एनम की जॉब दूंगा अगर तुमने ये 1 मंथ इंटर्नशिप अच्छे से कर ली, लेकिन यहाँ पर शर्त ये है कि तुम्हें सिर्फ प्योर पाइथन का इस्तेमाल करके डेटा एनालिसिस करना है और तुम्हें डेटा से मीनिंगफुल इनसाइट्स निकालना है। आप इस चैलेंज को एक्सेप्ट करते हैं और आप कहते हैं हाँ मैं पाइथन का इस्तेमाल करके सारी रियल वर्ल्ड प्रॉब्लम्स को सॉल्व करूंगा, एंड इसीलिए इस प्रोजेक्ट का नाम है कोडर्स ऑफ दिल्ली। चलते हैं कंप्यूटर स्क्रीन में और देखते हैं कि आपको इसमें करना क्या है। सो कांग्रेचुलेशन, सबसे पहले यू हैव जस्ट बीन हायर्ड एज अ डेटा साइंटिस्ट इंटर्न एट कोडबुक, द सोशल मीडिया फॉर कोडर्स। दिस दिल्ली बेस्ड कंपनी इज ऑफरिंग यू अ 10 लाख पर एनम। वाओ। और अगर आपने 1 मंथ की इंटर्नशिप अच्छे से कंप्लीट कर ली तो आप जॉब पालेंगे। और यहाँ पर चैलेंज ये है कि सिर्फ पाइथन का इस्तेमाल करके, नो पैंडास, नो नमपाई, नो अदर फैंसी लाइब्रेरी, सिर्फ प्योर पाइथन स्किल्स आप लोगों को अपनी दिखानी है। और आपके मैनेजर पुनीत कुमार वो आपको पहला टास्क साइन करते हैं। वो आपसे कहते हैं भाई देखो तुम्हारा जो पहला टास्क है वो है कि तुम्हें मैं डेटा डंप दूंगा कोड बुक का, और तुम्हें क्या करना है उसको एनालाइज करना है यूजिंग प्योर पाइथन। आप कहते हो लेकिन पुनीत सर आप ये बताइए कि क्या करना है मुझे। पुनीत सर आपसे कहते हैं डेटा साइंटिस्ट तुम हो, मैं तुम्हें डेटा डंप पकड़ा रहा हूँ, उसको समझो। मेरे पास ज़्यादा टाइम नहीं है, मुझे बहुत सारे काम करने हैं, मुझे इन्वेस्टर से बात करनी है, मुझे कंपनी को संभालना है, लीगल टेक्निकल चीजें देखनी है। तुम अभी डेटा एनालिसिस करो। वो आपको पकड़ा देते हैं एक जेसन डंप, और इस जेसन डंप को आपको एक्सप्लोर करना है और उससे मीनिंगफुल इनसाइट्स निकालनी है। क्योंकि जो पुनीत कुमार है ना वो जेसन डेटा को बिल्कुल नहीं समझते हैं, उन्हें नहीं पता जेसन क्या है, वो घबराते हैं इन टर्म से। वो अपने एक फील्ड में बहुत अच्छे हैं, बिजनेस बहुत अच्छा करना जानते हैं, इन्वेस्टर को ऑनबोर्ड करना जानते हैं, बिजनेस चलाना जानते हैं, लेकिन उनको आपकी जरूरत पड़ी क्योंकि आप हैं डेटा साइंटिस्ट जो कि उनके लिए डेटा एनालाइज करेंगे। और ये रहा वो डेटा डंप जो कि आप लोगों को पुनीत सर ने दिया है। आप कहते हो ओके ये एक जेसन फाइल है, इट्स अ वैलिड जेसन फाइल।
What I can do, just open the Jupyter notebook, in a projects, let me open it. I'm not gonna select now. 1 minute.
बहुत अच्छी बात है। यूजर्स में यूजर को आईडी दी हुई है, अच्छी बात है। नेम अमित, ओके। अमित के फ्रेंड्स हैं 2 और 3, यानी कि आईडी 2 और आईडी 3 वाले अमित के दोस्त हैं, क्योंकि आपको तो जेसन रीड करना आती है ना। हमने ऑलरेडी पाइथन रिफ्रेशर में देखा है जेसन को कैसे रीड करना है। तो आपने कहा ओके लाइक पेजेस 101। पुनीत कुमार ने आपको कुछ नहीं बताया लाइक पेजेस क्या है, आईडी क्या है, आपको खुद समझना है। लेकिन आप इतने समझदार हैं कि आपने पता लगा लिया कि ओके लाइक पेजेस में 101 लिखा है और यहाँ पर लिखा है कि पेजेस में 101 क्या है। ओके तो इसका मतलब यह है कि अमित लाइक करता है पाइथन डेवलपर्स पेज को, और प्रिया लाइक करती है डेटा साइंस इंथुसियास्ट वाले पेज को, और राहुल लाइक करता है पाइथन डेवलपर्स को भी और एआई एंड एमएल कम्युनिटी नामक पेज को भी। ओके तो आप अपने दिमाग में तो ये इनसाइट्स निकाल रहे हैं, लेकिन पुनीत सर को कैसे दिखाएंगे ये जेसन? तो आप पुनीत सर को दिखाएंगे नहीं, पुनीत सर डरते हैं जेसन से, और वो शायद खुश भी नहीं होंगे। वो कहेंगे यार जेसन ही रीड करनी होती, मैं खुद नहीं कर लेता, तुम्हें क्यों बुलाता। आपको लिखना होगा एक पाइथन प्रोग्राम, एक ऐसा पाइथन प्रोग्राम जो कि पुनीत सर को बहुत ही क्लियरली बताएगा कि ये डेटा क्या कह रहा है। अब ये डेटा देखकर आपने ये तो पता लगा लिया कि यार इसमें यूजर्स हैं, पेजेस हैं और कनेक्शंस हैं। जो यूजर्स हैं वो एक आईडी से यूनिकली आइडेंटिफाई होते हैं, और उसी के साथ साथ एक लिस्ट ऑफ फ्रेंड्स है जिनकी आईडी दी हुई है सिर्फ 2 और 3, जैसे कि अमित की दोस्त है प्रिया, अमित का दोस्त राहुल भी है। और क्या राहुल भी अमित का दोस्त है? हाँ, ये 2 वे रिलेशनशिप है, ठीक है। मतलब अमित का दोस्त राहुल है तो राहुल भी अमित का दोस्त है। मतलब एक बार फ्रेंड रिक्वेस्ट भेज दी तो फ्रेंड रिक्वेस्ट एक्सेप्ट हो गई, ठीक है बढ़िया। इसके बाद कनेक्शंस हैं जो कि हमने देखा ऑलरेडी, कौन किस पेज को लाइक करता है, कौन किसका दोस्त है, ये सारे कनेक्शंस हैं, बहुत अच्छी बात है। तो जेसन डेटा तो बहुत क्लियरली रीड हो पा रहा है। एज अ प्रोग्रामर मैं इसको बहुत अच्छे से रीड कर पा रहा हूँ, लेकिन एज अ डेटा साइंटिस्ट आपके लिए समझना बहुत जरूरी है कि अगर आप एक जेसन को रीड कर पा रहे हैं, अगर आप एक .py को रीड कर पा रहे हैं, अगर आप एक .cpp को रीड कर पा रहे हैं या IPYNB नोटबुक को रीड कर पा रहे हैं, तो आप कभी भी एक नॉर्मल यूजर को वो सब रीड करना एक्सपेक्ट नहीं कर सकते। आप पाइथन जानते हैं इसलिए आप रीड कर पा रहे हैं। आपको हमेशा क्लियरली इनसाइट्स देनी है। जरा सोचो, आप फेसबुक खोलते हो और आपको जेसन देखने को मिल जाए वहां पर कि भाई ये जेसन से रीड कर लो, क्या मैसेज आया, अच्छा लगेगा आपको? नहीं, अच्छा नहीं लगेगा। इसीलिए ये जो जेसन होता है, पाइथन फाइल्स होती हैं, टेक्निकल चीजें होती हैं, ये सब आपको इंप्लीमेंटेशन तक ही रखना है। रियल यूजर को, आप लोगों को रियल मैं इसको बहुत अच्छे से रीड कर पा रहा हूँ, लेकिन एज अ डेटा साइंटिस्ट आपके लिए समझना बहुत जरूरी है कि अगर आप एक जेसन को रीड कर पा रहे हैं, अगर आप एक .py को रीड कर पा रहे हैं, अगर आप एक .cpp को रीड कर पा रहे हैं या IPYNB नोटबुक को रीड कर पा रहे हैं, तो आप कभी भी एक नॉर्मल यूजर को वो सब रीड करना एक्सपेक्ट नहीं कर सकते। आप पाइथन जानते हैं इसलिए आप रीड कर पा रहे हैं। आपको हमेशा क्लियरली इनसाइट्स देनी है। जरा सोचो, आप फेसबुक खोलते हो और आपको जेसन देखने को मिल जाए वहां पर कि भाई ये जेसन से रीड कर लो, क्या मैसेज आया, अच्छा लगेगा आपको? नहीं, अच्छा नहीं लगेगा। इसीलिए ये जो जेसन होता है, पाइथन फाइल्स होती हैं, टेक्निकल चीजें होती हैं, ये सब आपको इंप्लीमेंटेशन तक ही रखना है। रियल यूजर को, आप लोगों को रियल इनसाइट्स दिखानी है, ऐसी इनसाइट्स जो कि कोई भी समझ ले। तो आ जाओ, हम लोग लिखते हैं प्रोग्राम जो कि इस डेटा को एक्सप्लेन करेगा। तो आज का हमारा टास्क ये है, हमें पुनी सर को इंप्रेस करना है। इस जेसन को ऑटोमेटिकली रीड करके हमें पुनी सर को एक ऐसा डेटा दिखाना है, व्हेन आई से डेटा आई मीन इनसाइट्स, हमें एक ऐसी इनसाइट्स दिखानी है। इस रॉ डेटा से हमें एक ऐसा प्रोसेस डेटा बनाना है, एक ऐसी इनसाइट्स बनानी है जिससे कि पता चले कि क्या हो रहा है इस डेटा में। और चाहे फिर ये 1 लाख लोगों की भी जेसन क्यों ना हो, पुनीत सर अच्छे से समझ जाए कि कौन किसका दोस्त है, कौन किस पेज को लाइक करता है, ये सारी चीजें। तो आ जाओ, हम लोग प्रोग्राम लिखते हैं। तो सबसे पहला काम हम लोग क्या करेंगे, ऑब्वियसली हम लोग इंपोर्ट करेंगे जेसन को।
Okay, first I have to start it. Okay, where is the Jupyter Lab? This is Jupyter Lab. This is notebook. Launch it. अरे ये खुलेगा ही नहीं यार. This is not opening because of some issue. Maybe the server issue, some issues there. Lot of things are going on. No? Because of that, it's taking a lot of time. Okay. ये सब ठीक है.
जेसन मॉड्यूल हमारे लिए इंपोर्ट करना बहुत जरूरी है। इसके बाद हम क्या करेंगे, मैं एक फंक्शन बनाऊंगा जिसका नाम मैं रखूंगा लोड अंडरस्कोर डेटा। ये हमें डेटा लोड करने में हेल्प करेगा। और क्यों ना मैं इसको एक ऐसा फंक्शन बना लूं जो कि क्या करे, कभी भी मुझे डेटा लोड करना है, किसी फाइल को रीड करना है, मैं कभी भी रीड कर पाऊं। फिर इसके बाद मैं क्या करूंगा, ऑब्वियसली मैं कहूंगा विद ओपन फाइल नेम, एंड आई एम बीइंग लिटिल फास्ट है क्योंकि ये बहुत ही सिंपल सी चीज है। हम एक फाइल को रीड कर रहे हैं और मैं यहाँ पर लिख दूंगा एज एफ, और इसके बाद मैं लिख दूंगा यहाँ पर डेटा इज इक्वल टू, कौन सा फंक्शन यूज होगा जेसन का, यस यू आर राइट, जेसन का लोड यूज होगा, क्योंकि यहाँ पर क्या है, फाइल ऑब्जेक्ट हम यूज करें, लोड एस यूज नहीं करेंगे क्योंकि स्ट्रिंग नहीं है, ठीक है। तो हमने यहाँ पर जेसन डॉट लोड किया एंड ऑब्वियसली वी वांट टू रिटर्न द डेटा। तो ये फंक्शन क्या करेगा, ये फंक्शन हमारे लिए डेटा को लोड करेगा। तो मैं यहाँ पर लिख देता हूँ, एक कमेंट लिख देता हूँ, लेट्स राइट अ फंक्शन टू लोड द डेटा, उप्स, लोड द डेटा। तो ये लोड डेटा फंक्शन हमने लिख दिया, बहुत बढ़िया। अब इसके बाद हम क्या करेंगे, इसके बाद हम करेंगे यूजर को डिस्प्ले करने का एक फंक्शन। लेकिन उससे पहले ना मैं इसको चेक करना चाहता हूँ, मैं लिखना चाहता हूँ डेटा इज इक्वल टू,
Not working. Why don't? Oh, and Oh, brother, taking a lot of time. What you can do? Just close all the application. Taking a lot of time. Downloading, install packaging. Okay, installing. Taking a lot of time.
लोड अंडरस्कोर डेटा एंड लेट्स सी कि अगर मैं यहाँ पर डेटा डॉट जेसन लिखूं तो डेटा लोड हो रहा है कि नहीं. ओ वाओ, टाइप ऑफ डेटा देखूं तो क्या होगा, डिक्शनरी होनी चाहिए पाइथन की, स्ट्रिंग नहीं होनी चाहिए. बहुत बढ़िया. तो मतलब मैंने अपना पहला टास्क अकम्प्लिश कर लिया है कि मैं इस डेटा को एज अ डिक्शनरी रीड कर पा रहा हूँ. बहुत अच्छी बात है. तो मैं एक अच्छा डेटा साइंटिस्ट हूँ. कम से कम कुछ तो किया मैंने, कुछ तो किया. एक कॉन्फिडेंस तो आ रहा है मेरे अंदर कि हाँ यार मैंने किया कुछ. अब हमें लिखना है एक फंक्शन जो कि क्या करेगा, जो कि डिस्प्ले राइट अ फंक्शन टू डिस्प्ले यूजर्स एंड देयर कनेक्शंस. कनेक्शंस का मतलब यूजर्स के फ्रेंड्स और उसी के साथ साथ यूजर्स के पेजेस जो उन्होंने लाइक किए. ठीक है, नोटबुक को सेव करूंगा, प्रोग्रेस खोना नहीं चाहता. क्या रखूँ इस फंक्शन का नाम, डिस्प्ले अंडरस्कोर यूजर्स रखता हूँ. ये लेगा डेटा. ठीक है, क्या है डेटा, डेटा एक डिक्शनरी है, तो ये डिक्शनरी लेगा. और इसके बाद हम क्या करेंगे, इसके बाद हम एक एक करके फॉर यूजर इन डेटा यूजर्स लिखेंगे. क्यों कर रहे हैं ऐसा हम ऐसा इसलिए कर रहे हैं क्योंकि डेटा यूजर्स के अंदर हमारे पास यूजर्स का डेटा है. ठीक है, तो हमने लिखा फॉर यूजर इन डेटा यूजर्स. ठीक है, तो यहाँ पर हमने इस तरह से रीड किया इसको. और हम क्या कर रहे हैं, हम कहेंगे कि भाई प्रिंट करो, एक एफ स्ट्रिंग बनाएंगे. हम कहेंगे प्रिंट करो, सारी चीज़ें प्रिंट कर दो भाई, सारी चीज़ें इसके बारे में प्रिंट कर दो. सबसे पहले हम कहेंगे कि यार प्रिंट करो यूजर नेम. ठीक है, यूजर नेम जो उसका नाम है. ठीक है, और हम कुछ इस तरह की स्ट्रिंग बनाएंगे कि अमित इज फ्रेंड्स विद, ऐसे बनाएंगे हम अमित. ये तो अमित प्रिंट कर देगा. ठीक है, ये चीज़ अमित प्रिंट कर देगी, इज फ्रेंड्स विद. और हम यहाँ पर सारे दोस्तों के नाम लिखेंगे. मैं चाहता हूँ सारे दोस्तों के नाम आ जाए. ठीक है, तो दोस्तों के नाम कैसे आएंगे, मैंने यहाँ पर इस फ्रेंड्स विद लिख दिया. और इसके बाद मैं एक लूप चलाऊंगा. वो लूप क्या होगा, वो फ्रेंड्स का लूप होगा. ठीक है, वो फ्रेंड्स का लूप होगा और मैं उसके सारे फ्रेंड्स के नाम लिख दूंगा. लेकिन अभी के लिए मैं सिर्फ पुनीत सर को इंप्रेस करना चाहता हूँ कम टाइम में. मैं नहीं चाहता कि मैं बहुत ज़्यादा दिमाग लगाऊं. आई वांट टू शो समथिंग टू पुनीत सर एज सून एज पॉसिबल. तो क्या करते हैं ना कि डायरेक्टली हम यहाँ पर क्या करेंगे, हम डायरेक्टली यहाँ पर लिख देंगे इस फ्रेंड्स विद. और हम फ्रेंड्स का जो यहाँ पर हमारा लिस्ट है उसको लिख देंगे. तो लेट्स ट्राई टू डू समथिंग लाइक दिस. तो मैंने यहाँ पर लिखा अमित इज फ्रेंड्स विद, और यहाँ पर आ जाएगा 2 और 3. आई नो 2 एंड 3 से पता नहीं चल रहा है किसका दोस्त है, बट अगेन मैं एक चीज़ कर सकता हूँ कि मैं कम से कम कुछ तो बता रहा हूँ. ठीक है, तो मैंने यहाँ पर ये इस तरह से लिख दिया. एंड सेम चीज़ मैं, ऑलमोस्ट सेम चीज़ मैं लिखूंगा पेजेस के लिए. ठीक है, तो मैंने जो चीज़ लिखी है यहाँ पर यूजर्स के लिए, वही चीज़ मैं पेजेस के लिए लिखूंगा. ठीक है, तो मैं यहाँ पर कहूँगा कि फ्रेंड्स जो है अमित के वो ये है, एंड लाइक पेजेस आर, मैं बिल्कुल इसी तरह लिख देता हूँ यूजर पेजेस, बिकॉज आई वांट टू शो समथिंग एज सून एज पॉसिबल टू पुनीत सर. ठीक है, तो मैं अभी इसको लूप नहीं कर रहा हूँ, पर मैंने भी यहाँ पर सिंपली ऐसे लिख दिया. तो यहाँ पर मैं लिखूंगा यूजर्स एंड देयर कनेक्शंस, और यहाँ पर यूजर्स एंड देयर कनेक्शंस लिखकर मैं एक बैकस्लैश एन भी लगा देता हूँ ताकि थोड़ी सी चीज़ें फॉर्मेट हो जाए. ठीक है, अच्छे से अच्छी दिखनी चाहिए भाई चीज़ें. और ये मैंने लिख दिया. और यहाँ पर मैं एक प्रिंट स्टेटमेंट लिखूंगा. मैं यहाँ पर लिखूंगा एक प्रिंट स्टेटमेंट, और यहाँ पर मैं लिख दूंगा लेट्स से पेजेस इन्फॉर्मेशन. ठीक है, देखो आपका जो पैटर्न है वो कुछ भी हो सकता है, पैटर्न कैन बी एनीथिंग. ठीक है, डिपेंड क्या करता है कि आप कैसे डेटा को एनालाइज कर रहे हैं, कैसे आपकी प्रेजेंटेशन है. तो मैंने यहाँ पर पेजेस इन्फॉर्मेशन लिख दिया क्योंकि भाई ये भी पता चलना चाहिए ना कौन सी पेज आईडी क्या है. तो मैं यहाँ पर लिखूंगा फॉर पेज इन डेटा पेजेस, क्योंकि अदरवाइज पुनीत सर बोलेंगे कि भाई कौन सा पेज क्या है, मुझे कैसे पता चलेगा 101 102. मैं चाहता हूँ पुनीत सर डेटा डॉट जेसन को ना खोले, मेरे आउटपुट से काम चला लें. ठीक है, और मैं फाइनली एक रिपोर्ट जनरेट करके दूंगा पुनीत सर को. तो मैं यहाँ पर क्या करूँगा, लिखूंगा प्रिंट और एक लगाऊंगा एफ स्ट्रिंग. और ये करने के बाद मैं क्या करूँगा, लिखूंगा कुछ इस तरह से पेज आईडी. और ये करने के बाद मैं क्या करूँगा, लिखूंगा कि भाई देखो ये पेज की आईडी आ गई. जैसे मान लो 101 आ गया, और यहाँ पर मैं फिर क्या करूँगा, पेज नेम लिख दूंगा. तो यहाँ पर मैं लिखूंगा पेज नेम, एंड मेक श्योर कि डबल कोट के अंदर आप सिंगल कोट लगाएं. डबल कोट लगाएंगे तो कंफ्यूज हो जाएगी स्ट्रिंग आपकी. ठीक है, समझ ना मैं क्या कह रहा हूँ. बाहर डबल कोट लगा हुआ है तो अंदर सिंगल कोट में लिखें सब चीज़ों को. और ये सब चीज़ें आप लोग पाइथन से समझते हैं कि कैसे की जा सकती हैं. टाइम टू टेस्ट आउट द फंक्शन. ठीक है, तो डिस्प्ले यूजर्स को हम लोग यूज़ करेंगे और डेटा पे यूज़ करेंगे. लेट्स गो. तो यहाँ पर लिख कर आया कि एरर पेजेस. लेट मी सी व्हाट द प्रॉब्लम इज. लाइक पेजेस है यहाँ पर. ये देखो मैंने गलती कर दी. ठीक है, तो यहाँ पर क्या है कि लाइक.
Now open it. Open the left. Not launch here. Reopen it. Reopen it.
पेजेस के नाम से, पेजेस नहीं कोट लगाएंगे तो कंफ्यूज हो जाएगी स्ट्रिंग आपकी, ठीक है, समझना मैं क्या कह रहा हूँ। अगर बाहर डबल कोट लगा हुआ है तो अंदर सिंगल कोट में लिखें सब चीज़ों को, और ये सब चीज़ें आप लोग पाइथन से समझते ही हैं कि कैसे की जा सकती हैं। टाइम टू टेस्ट आउट द फंक्शन, ठीक है, तो डिस्प्ले यूजर्स को हम लोग यूज़ करेंगे और डेटा पे यूज़ करेंगे। लेट्स गो। तो यहाँ पर लिख कर आया कि एरर पेजेस, लेट मी सी व्हाट द प्रॉब्लम इज, लाइक पेजेस है यहाँ पर, ये देखो मैंने गलती कर दी, ठीक है, तो यहाँ पर क्या है कि लाइक पेजेस के नाम से, पेजेस नहीं लाइक पेजेस है। लेट्स गिव इट अनदर गो एंड वाओ वाओ, आई एम रियली इंप्रेस्ड, आई एम रियली इंप्रेस्ड गाइस। आप एक चीज़ कर लेना यहाँ पर, एक बैकस्लैश और लगा लेना, क्योंकि थोड़ा सा फॉर्मेटिंग तो करूँगा ना मैं बाद में भी पुनीत सर को भेजने से पहले, ठीक है। तो यहाँ पर आप देख सकते हैं यूजर्स एंड द कनेक्शंस, और यहाँ पर मैं कोलन लगाऊंगा, और उसी के साथ साथ ये आ गया हमारा, और यहाँ पर एक बैकस्लैश लगा भी सकता हूँ, मैं नहीं भी लगा सकता हूँ, नहीं लगाता हूँ बैकस्लैश, और यहाँ पर मैं फ्रेंड्स विद 2 3, अब 2 और 3 क्या है ये कैसे पता चलेगा, तो मैं क्या करूँगा ना कि यहाँ पर ना यूजर की आईडी भी प्रिंट करा दूंगा, ठीक है, मैं यहाँ पर लिख देता हूँ, मैं यहाँ पर यूजर की आईडी भी प्रिंट करा दूंगा, क्योंकि क्या करूँ फिर पुनीत सर को पता चल जाएगा कि आईडी कौन सी है, ठीक है। तो यहाँ पर यूजर आईडी, और यहाँ पर मैं डॉट स्लैश करता हूँ, अब दिखाता हूँ आपको। तो नंबर 1 आईडी यूजर की है अमित, अमित इज फ्रेंड्स विद 2,3, ठीक है, और मैं यहाँ पर ना इस चीज़ को क्लियर कर देता हूँ कि आईडी ऐसे लिख देता हूँ, आईडी, ये मैंने क्या कर दिया, ओके, तो आईडी मुझे बाहर लिखना चाहिए था, मैंने यहाँ पर लिख दिया, माय बैड, हाँ अब ये चल जाएगा। तो मैंने लिखा आईडी 1 अमित इज फ्रेंड्स विद, और मैंने यहाँ पर लिख दिया, ठीक है, ये चीज़ मैंने लिख दिया। मैं यहाँ पर डैश लगा दूँ तो थोड़ा ज़्यादा बेटर लगेगा, मुझे जैसे सही लगेगा मैं वैसे कर लूँगा, और यहाँ पर मेरे हिसाब से ये जो हमारा आउटपुट है वो काफ़ी रीडेबल है। तो मैं क्या करूँगा, यूजर्स इज एंड द कनेक्शन, ठीक है, आईडी 1 अमित इज फ्रेंड्स विद 2 and 3, चेक करते हैं जरा डेटा में कि कुछ गड़बड़ तो नहीं करी हमने, नहीं करी है, 2 and 3 के साथ ही अमित फ्रेंड। लाइक पेजेस कौन से हैं, 101, अब पुनीत सर देख लेंगे, 101 पाइथन डेवलपर्स हैं तो पता चल जाएगा पुनीत सर को, पुनीत सर शायद जेसन इतने अच्छे से नहीं पढ़ पाए, जेसन से डरते हैं एक्चुअली वो, तो यहाँ पर हम कुछ ऐसे कर सकते हैं, ओके, अमित इज फ्रेंड्स विद 2 3 एंड लाइक पेजेस आर ये, ऑल राइट। तो यहाँ पर आप देख सकते हैं कि हमने डेटा से मीनिंगफुल इनसाइट्स निकाल दी हैं। नाइस, दिस इज गुड, वाइल दिस इज गुड, पुनीत सर के पास आप जाते हो वो आपको अप्रिशिएट करते हैं, ही इज हैप्पी विद योर प्रोग्रेस, बट से यार डेटा थोड़ा सा मैसी लग रहा है, ये तुमने जेसन का ही एक तरह से बना दिया टेक्स्ट, मतलब थोड़ा अच्छे से स्ट्रक्चर करके दिखाओ यार, ऐसे मजा नहीं आया, मजा आया बट उतना नहीं आया। तो पुनीत सर की उम्मीदें बढ़ जाती हैं और वो आपसे कहते हैं कि यार यू कैन डू बेटर, और आपकी भी अपने आप से उम्मीदें बढ़ जाती हैं, आप भी कहते हो कि यार आई कैन डू बेटर, तो आ जाओ लेट्स डू बेटर। सो आई होप कि आपको ये प्रोजेक्ट अच्छा लगा, मजा आ रहा है, अगली वीडियो में वी विल डू बेटर, सी यू इन द नेक्स्ट वीडियो।
Yes. Okay, finally, when you start it, I think you can listen to me. Okay, fine. Yeah. So Jupyter, this lab is opening. I've run this command. After this command, it was working. Okay. Jupyter lab icon is there. So let it open. Okay. So before it open, what I will do, I will just put it here. Minimize it. Okay. Minimize this also. Minimize this also. Open this here. Okay. Continue the lecture now. Opening the obstacle file, script file. This is opening. Till it open, what I will do, check it out here. So Jupyter Lab is open now. Okay, it's open. Okay, now you can open a folder from here. Answer is okay. But I think I should file. Folder is not creating. No, the thing is that some issues there, I think. Okay, I think it's this. Title. Okay, open from your open distance. Some issues there. There is issue. I think it's not working properly as I expected. It's working very slowly. Mm-hmm. So okay, working very low. Okay, what I will do, I will stop it. Let's control C. Interrupted. Yeah, shutting down. Shutting down. Okay, fine. That's okay. Okay, this is the file. Okay, this is the code. I have to change the code now. According to this, I have to write this one. Transform.local. Yeah, transform. Okay, save it. And then play the play button here. Simultaneously, what I can do, I'll just open this course here. Close this. Close this. Go here. Go here. Refresh it. Refresh. Refresh. Okay. So it can run properly. Okay, close all the notifications. Any program running, please off it. Any other program that you are running, please off it. There's no need of Chrome also. Off it. Wait, wait. So it can work properly. Now going to start this simultaneously. Paper 1, paper 2, basic numerical ability. Okay, starting this. I have completed only, okay, 332 lesson completed or 340. They have completed by themselves, but I have to complete by myself all the lessons. I think it's run already. Yeah. So we're going to run it, and you can see the changing size. Okay, they are changing size. Fine. Yeah, they were very small and they changed their size. Okay, percentage one, this one, starting from this. Okay.
एग्जाम बैंक पीओ के एग्जाम की बात करिए, आप कोई भी एग्जाम ले लीजिए, परसेंटेजेस जो है बहुत इंपॉर्टेंट टॉपिक है, क्योंकि हो सकता है डायरेक्टली परसेंटेज से क्वेश्चन आए या ना आए, बट अदर टॉपिक्स लाइक प्रॉफिट एंड लॉस रेशियो प्रोपोर्शन या इन जनरल कोई भी एप्टीट्यूड का आप टॉपिक लोगे, वहां पर परसेंटेजेस का रोल बहुत ज्यादा हो जाता है। तो बहुत ही बढ़िया लेवल पे इस टॉपिक को समझना बहुत जरूरी है, और कैसे हम जल्दी परसेंटेजेस को फाइंड आउट कर सकते हैं, उसकी बहुत सारी शॉर्ट ट्रिक्स डिस्कस करेंगे हम, और कैसे हम परसेंटेजेस की प्रॉब्लम्स को सॉल्व कर सकते हैं, उसको भी हम इस वीडियो सीरीज में देखने वाले हैं। राइट, तो जैसा कि आपको पता है यार, आपके यस सर की क्लास बाकी टीचर से थोड़ी डिफरेंट होती है। हमेशा किसी भी नए काम को जो शुरुआत में करता हूँ वो एक पिंच ऑफ मोटिवेशन से करता हूँ। तो वीडियो शुरू करने से पहले थोड़ा सा एक पिंच ऑफ मोटिवेशन ले लेते हैं भाई। आज का जो मोटिवेशन कोट है वो ये है, स्ट्रेंथ लाइज इन द पावर ऑफ योर संकल्पा और इंटेंशन, द माइंड इज फुल ऑफ संकल्पा एंड विकल्पा, ईच वर्क गेट्स डन थ्रू संकल्पा, the act of moving one's arm is preceded by the sankalpa in the mind, the sankalpa of a weak mind is ineffective, we can make our mind strong by knowledge, then the sankalpa will also be very strong। भाई बहुत ही गजब की बात यहाँ पर कही गई है। देखिए, कोई भी काम आप करने जा रहे हो, राइट, तो उसके पीछे इंटेंशन क्या है, आपका कमिटमेंट किस लेवल का है, आपका संकल्प जो बोलते हैं कमिटमेंट, वो किस लेवल का है, वो बहुत इंपॉर्टेंट है। क्योंकि हमारे माइंड में दो ही चीजें होती है, या तो कमिटमेंट हो सकता है, संकल्प हो सकता है, या तो विकल्प हो सकता है, या तो इमेजिनेशन, नेगेटिविटी या फैंसी थिंग्स हो सकती है। राइट, केवल एक ही चीज हो सकती है, या तो संकल्प या विकल्प। अगर संकल्प आपका वीक है तो फिर विकल्पों से भरा रहेगा माइंड, अगर आपका संकल्प स्ट्रॉन्ग है तो विकल्प नहीं रहेंगे माइंड में। कोई भी काम यार, आप अपने आर्म को उठा रहे हो या वेट लिफ्टिंग कर रहे हो, तो पहले अंदर आपने संकल्प लिया, एक कमिटमेंट किया माइंड में कि मुझे ये काम करना है, उसके बाद ही हम कर पा रहे हैं ये काम। आप समझ रहे हो ना? तो देखिए, जैसे मान लीजिए आपको कोई चीज करनी है, किसी भी एग्जाम की तैयारी करनी है, तो सबसे पहले तो आप डिसाइड करते हो कि यार इस एग्जाम की तैयारी करना है, फिर आप एक प्लानिंग बनाते हो कि यार हाँ ऐसे ऐसे इसको करना है, फिर आप डिसाइड करते हो कि यार हाँ, और फाइनली हमने डिसाइड कर लिया कि हमको क्या करना है, कैसे करना है, और फाइनली एक्शन की बारी हम करने जा रहे हैं। अब फाइनली उसी समय अपने माइंड को ट्रेन कर लो, एक बात मन में बैठा लो कि इस काम को करना है, नहीं इस काम को करना ही है। दैट इज द पावर ऑफ योर कमिटमेंट। यार बिना कमिटमेंट के कुछ भी नहीं होगा। नॉलेज को गेन करके ज्यादा पढ़ाई करने वाले, तो दोनों चीजें सक्सेस तो फिर मिलनी ही मिलनी है। राइट, तो इस वीडियो सीरीज को भी जब आप स्टार्ट करोगे कमिटमेंट के साथ, खेल जो है वो आपके एंथुसियाज्म क्रिएट होगा। जो कुछ भी हम पढ़ने वाले हैं, एक आपको ट्रेलर सॉर्ट ऑफ रिवील कर रहे हैं किस कोर्स में क्या क्या कवर करने वाले हैं। तो चलिए इसको देखते हैं एक बार फटाफट से। पार्ट टू पार्ट कनेक्शन बनाने के लिए थोड़ा सा एक आइडिया होना चाहिए आपके टीचर के बारे में। आईटी कंपनीज में प्लेसमेंट लिया है दोस्तों, करने वाला हूं, तो बिल्कुल एक फेथ आप रख सकते हो कि यार आप बिल्कुल सॉल्व कर पाओगे, आपकी यस सर का प्रॉमिस है। राइट, फ्रैक्शन को परसेंटेज में कैसे कन्वर्ट करना है वो देखेंगे, 10 के मल्टीपल्स में परसेंटेज निकालना है तो कैसे निकालेंगे, उसके हम पढ़ने वाले। तो भाई इस चीज का आंसर रुको जरा। उसके बाद अगला जो हम पढ़ने वाले हैं वो है यूज ऑफ वर्टिकल एंड क्रॉस वाइज पैटर्न। बहुत ही बढ़िया मैं आपको पैटर्न बताऊंगा। वर्टिकल एंड क्रॉस वाइज पैटर्न एक शॉर्ट ट्रिक है जिसकी हेल्प से आप बहुत जल्दी परसेंटेजेस फाइंड आउट कर सकते हैं। डेसिमल नंबर की परसेंटेजेस कैसे फाइंड आउट करना है वो भी देखेंगे। सक्सेसिव परसेंटेज भाई बहुत की भी शॉर्ट ट्रिक देखेंगे। अगेन बहुत इंपॉर्टेंट वैरायटी वो भी देखेंगे। कुछ इंपॉर्टेंट कवर करने वाले शाहरुख सर जो है वो शुरू होता है। सबसे इंपॉर्टेंट जो चीजें मैं आपको बता रहा हूँ, देखिए प्रॉब्लम ऑन वोट्स बहुत आता है, बहुत। आप आईटी कंपनीज की अगर स्पेशली बात करूं, बहुत क्वेश्चंस आते हैं। गेट एग्जाम में बहुत क्वेश्चंस आते हैं कि भाई पार्टी ए को इतने परसेंट वोट मिले, पार्टी बी को इतने परसेंट वोट मिले, एंड ऑन दुनिया भर की चीज। उसके अलावा हम 100 के ऊपर परसेंटेज पे अगेन स्टार 15, 125, 195 यानी 5 के मल्टीपल्स के अगर कोई परसेंटेजेस निकालने के लिए पूछे तो कैसे निकाल सकते हैं, मैं आपको बताता हूँ। बाकी यूट्यूब चैनल्स देखेंगे तो बहुत ज्यादा 13th एंड 14th पॉइंट की, क्योंकि भाई हम मैं आपको बताता हूँ किसी भी कॉम्पिटिटिव कोर्स में कवर करने वाले, तो अगेन अपना कमिटमेंट से टॉपिक्स आपको पहले से आना चाहिए। तो उस वीडियो को भी देखिएगा बहुत जल्दी।
So this PDF is already downloaded. No need to download. Just I will what I will do. Okay, 1 second. Go to the next page. This is already downloaded. Percentage is yes sir. 4-page PDF. Next. This is already downloaded. For next. One minute. I can see the PDF simultaneously here. So starting from the basic concept of percentage. For every, what does it count?
Basic concepts of percentages. What does a discount of 25% means? Basic concepts of 25% means.
For every rupees what you are getting, discount of rupees 25. You can see this. Shopping mall discount 20%, 25%,
Shopping mall discounts
50%.
2. Marks.
Marks
3.
80%.
Increase or decrease.
So you can see this. Okay, this is very important. Going to start this, but before starting, what I will do some work here.
सपनों का नॉलेज गेट। नमस्कार दोस्तों, मैं हूं आपका दोस्त यश।
Picture in picture is the option is picture in picture. Let me download picture in picture extension. Oh, it is option. No? Got it. Got it.
स्वागत करता हूं आपकी सीरीज में, जहां पर हम परसेंटेजेस पर डिस्कशन कर रहे हैं। दोस्तों पिछली वीडियो में हमने सबसे इंपॉर्टेंट बात पर डिस्कस किया कि भाई आखिर हम इस कोर्स में क्या-क्या कवर करने वाले हैं। अब दोस्तों कुछ ऐसी चीजें हैं जो आपको बताना बहुत इंपॉर्टेंट है कोर्स एक्चुअली शुरू करने के पहले, भाई प्री रिक्विजिट जिसको बोलते हैं।
So
अगर आप इस कोर्स में
before starting it, what I will do, I will just do this here. Okay, now write the program. Okay, starting this way. Change the size using a fixed value. I have changed the size. Okay, mark the step is complete. Add a randomized size logic. Going to add this in this step.
In this step, you'll use Unity's random range function to give every obstacle a random scale when the game starts. You'll also declare your first variable, a piece of data that can change. In this case, you'll store a random number in a variable and then use it to scale the obstacle. 1. Declare a new variable to store a random size. In the start method above the transform.localScale line, add the following line of code. Explanation. Float is short for floating point number,
So
which means the variable
explanation is later. First, I will add this variable here. .5 and this is going to be 2.0. 2.0, yeah. Okay, fine. Now it's time for explanation. Okay.
variable can store a number with decimals. Float is short for floating point number, which means the variable can store a number with decimals. Random.range, min, max, picks a value between the two numbers you give it, including the minimum, excluding the maximum.
Yeah.
You can name your variable anything, but random size is clear and descriptive. 5 degrees Fahrenheit and 2 degrees Fahrenheit mean that the object can scale anywhere from half its default size, 0.5%, to double its default size, 2. Use the variable to set the scale. Replace your previous hard-coded x and y values with your new random size variable. Now both.
So you can do this. What you can do, just put here the random size here. Yeah. Now save it.
Now both the x and y scale will use your random value, creating a proportional shape
So, this will use the random size variable. This declare here. This will use the same value from here, and this value will vary from 0.5 to till 2, not including 2. This is excluded. The maximum value is excluded. 2.0 f is excluded, and 0.5 the minimum value is included. 0.5 to 2 till 2.0. All the values it will be used here.
shape that changes size with each new instance. 3. Quickly test and retest with a keyboard shortcut in Unity. Press Ctrl plus MacOS CMD plus to save the script. Return to Unity and press Ctrl plus MacOS CMD plus P to quickly enter and exit play mode. Each obstacle will now appear at a slightly different size. Right now, your script uses specific numbers, 0.5 degrees Fahrenheit and 2 degrees Fahrenheit, to set the random size. This works, but what if you wanted to adjust those values later? Rather than editing them directly inside the random range, function somewhere in the middle of your code, it's better to store them as global variables at the top of your script. This makes your code easier to read and modify. Try exiting and entering play mode a few more times to see the obstacles change in size each time. Tip: to decrease loading time each time you enter play mode, you can disable reloading the domain and scene in the editor settings. You've now used a variable and random number generation to make your obstacles more dynamic, a key part of making games feel less repetitive. Create variables for size range. Create variables for size range. In this step, you'll move your size range values into variables and make your code more flexible. 1. Add 2 new variables at the top of your script. In your obstacle script.
1 minute. So I'm going to add 2 variables from the starting this. To first opening curly. After the first opening, edit the following. Okay, this one. Like this. Okay. Now, if it's not no. Now put the minimum size here, the maximum size here. Now you can change globally the values. Okay. Play it. Yeah.
Tip: placing variables outside of methods lets you reuse them in multiple places. You'll learn more about scope and variable placement later. 2. Update your random size line to use the new variables. It can be surprisingly frustrating when your code looks messy. Misaligned brackets and inconsistent spacing can make even simple logic harder to read and debug. Keeping your code nicely indented not only improves its readability, but it also helps you spot structural mistakes faster. Fortunately, most code editors come with shortcuts that let you automatically format your code with proper indentation. In your start method, change the random range line to use your new variables. 4. Save and test. Press Ctrl plus macOS.
Okay, let me do it. Okay, let me do it. I done it. Save it, and then press the play mode here. Now enter the play mode. Now you can see the minimum size and maximum size are increasing. Yeah, it's working fine. Yeah. Auto format your code.
CMD plus to save. Return to Unity and enter play mode. 8. Auto format your code. 8. Auto format your code. 1. Mess up the indentation temporarily. Change the spacing or alignment of some of your code to simulate disorganized formatting. This will help you see the effect of the auto indent clearly. So far, your obstacles can fall and bounce, but they don't move on their own. In this step, you'll apply a force to each one using Unity's physics system so they shoot off in a direction when the game starts. 2. Use the shortcut to auto indent. If you're using Visual Studio Code on macOS, press Shift plus Option plus F. If you're using Visual Studio on Windows, press Ctrl plus, then Ctrl plus D. If you're using another ID, or if the above shortcuts aren't working for some reason, search for the keyboard shortcut to Format Document or Auto Indent. Your code should now snap back into a clean, well-structured format, making it easier to follow and maintain. Use this shortcut as often as you need to keep your code nice and organized. Apply force to the obstacles. Apply force to the obstacles. To do this, you'll first need to access the rigid body 2D component through code using a method called getComponent. Then, you'll use the add force method to push the obstacle in a direction. This step introduces a core Unity concept, getting references to components in code.
So what you can do, a simple thing you have to do. Now you can see the force here. Variable rigid body 2D.
This creates a variable that will hold a reference to the obstacle's rigid body 2D component. It's very common among Unity developers to give rigid body variables the name R&B for short. 2. Get the rigid body 2D component. Inside the start method below your code that scales the obstacle, add the following line of code. Explanation. Get component searches the current game object for a specific type of component. Unity will find the rigid body 2D component so you can use it in your code. The rigid body 2 DNR part tells Unity what type of component to look for. The empty is required syntax. It just means run this method with no extra info. Yes, it looks strange at first, but you'll see this pattern a lot in C# scripts. 3. Apply force in a direction. Still in start, add the following line of code below your other code. Explanation. Right now, your obstacle moves, but gravity is still pulling it downward. Vector2.right means move right along the x-axis. The number 100 is the strength of the force. You can also experiment with vector2.bp, vector2.left, or vector2 down to try other directions. You are just moving all the obstacles in a single specific direction for now. You'll
You will
randomize
learn
this
the
direction in the
coming
coming
steps.
steps. Or save and test. Press Ctrl+, MacOS, CMD+, to save. Return to Unity and enter play mode. The obstacle should now initially move to the right as it's falling down.
Okay, fine. Mark this step is complete and save it. I already saved it and I will run it. Okay. Play it. Don't save this. Now you can see they are moving in left with the force. Yeah. This side they are moving with the force. No, right. They are moving at right. They're moving at right direction. Yeah. See. They're moving at the right direction and with force they are moving. Yeah. You can see. Yeah. Fine. Set gravity scale to 0. Now, right now your obstacle moves, but gravity is still.
Down. Set gravity scale to 0. Set gravity scale to 0. Since the obstacle is a prefab, you'll update. Right now, your obstacle moves, but gravity is still pulling it downward. In your game, you want the obstacles to float and bounce freely without falling over time. To achieve that, you'll set the gravity scale property on the rigid body 2D component to 0. The number 100 is the strength of the force. You can also experiment with vector2.ep.
Okay, see it. Go to obstacle. Go to gravity scale or the gravity scale 0. Set it 0. Save it and then play it. Now you can see the same. The same thing you can see. Yeah. Fine. Select the obstacle prefab. Randomize the speed. Now it's time to randomize the speed.
But in this step, you'll make each obstacle move at a random speed using the same technique you used to randomize the size, define a range, and pick a random value within it. 1.
Okay. Select the obstacle prefab. Yeah, I've selected already. Stop it. Okay. We are setting the to slot. Okay. Random speed is equal to random the range min speed and max speed. Yeah, speed will vary. Save it. But where we use the random speed, here we will use random speed. Okay, fine. Now save it and play it. Mark the step as complete. That's very good. Okay, I think I'm appearing very good. Hello. Oh, we continue the lecture now. For randomized direction, what I'm doing now, randomizing direction. Is to be related to height, direction, random to direction using very helpful random inside unit circle function. You can see here. Like a vector to random direction and random inside unit circle. Okay, and this in random direction. Okay, replace it in random direction. Inside unit circle. Random point inside the circle with radius of 1. Also generating unpredictable motion to this space. Okay. I'm feeling very tired, but it's okay. मेरे से क्या हो गया था? Now save it and run it. And it will move in a circle. The random direction, random inside unit circle, and it will move between -1 and 1, pointing in a random direction within a circular area. Okay, you can see this. Let me show you. Press Ctrl P. Now you can see this is moving in a circle, this is moving in a circle, this is moving in a circle, and they're colliding and then changing the circle a lot different. Okay, but they're moving from circle. Yeah, this is collided again, and now it's moved very perfectly. Yeah, that's good. Good. You're changing the speed as well. Explore variables in the inspector. At this point, your obstacles, you just several speed variables like min size, min speed, max speed. These values are currently hidden inside the script, which means you have to edit code every time you want to treat them. In this step, you will make those variables public. So that they appear in inspector window. There, let's say your experiment it just behave without touching code again. A key workflow when collaborating with designers or fine-tuning gameplay. So what we will do, public, make it public, okay? So they can be used. Also. You can change, then they can change it. Like this, you can change it then. Otherwise, it must become public and this will not be seen. Like you can see, you can't see now here. Click this obstacle, no? Well, you can see the obstacle is not visible here because they are private, they are not public. But when you make the changes here, when you make them public, then this will be here. Okay. Yeah. Now save it, and now you will see that here these will appear, and now you can change them. Wait for a second, and you can see them. Okay. Now you can change them. The minimum size you can change. The minimum maximum size you can change, and the rigid body you can select any rigid body you want to select 50 and 500. Okay, and save. But I think rigid body is not public yet because of that this is not appearing here. Rigid body is not public. Don't make rigid body public. Or no, otherwise. Okay, fine. Okay. Hmm. Make it 150, and save it. Now it's perfect. Now you mark this step complete. Play it as well. Click clear. Control P. Mark this step as complete. You can see now everything is working perfectly. Final script sample. You can see this. I have made my script. You can see this. They are working very good. Okay. Now you can stop this, and you can see the script here. This is totally same single like this. You can see. Yeah. Yeah. Mark this step as complete. Optional more things to try. I will try these more things as well. Easy to create. Okay. But before trying, I will have a no optional more things to try. Try this optional things to challenge yourself, build your skills, and improve your project. Each challenge is tracked as easy, medium, expert difficulty, so that you know what to expect. You can complete one all or none of them. It's totally up to you. If you are not interested in doing this, mark this step as complete. Okay. Yeah, proceed to the next video. Is you create a unique starting layout. Uh, take some time to carefully place the obstacle in strategic location on the screen. Move the copies around the screen to create an interesting pattern or obstacle field. Adjust the rotation for more safety, more variety. Okay. Move the copies around the screen to create an interesting pattern or obstacle field. Adjust the rotation for more variety. Okay, you can do this. See this. Uh, okay, you can do this. We make large obstacle more slow, give your obstacle more weight by adjusting the speed based on the size in your obstacle. Yeah, use in obstacle script before you add speed. what is that? This makes rather free so then you have to want this mean speed max speed divided by random size and randomize. This is very good. You can implement it. Okay. Where the random speed? Progress. Now you have to rotate and put given this one. Maybe. You have to create the following very well before. Work. Random top random minus max spin speed max. Okay, let me run it. Is implementing like this or not? Yeah. Next step. Next tutorial we will create controllable player. Okay. Protect the other things. Okay. Fine. Yeah, you can see this. Yeah, the script as well. And you can also make this also public. Yeah, access page is public already. 150 no. It's 10. Oh, it's not saved yet. Okay, save it no. Controllers. That's why I thought why it's not working. Okay, fine. Now what I will do, this completed. Now you can mark this tutorial and it's expiring project, engaging a clean instruction was there and submit feedback. Now next is steer the player. Okay. Now it's open. Now what I will do, I will just play it. You can see now the smaller have the high speed, the bigger one has the less speed. This will have very less speed. You can see this, but it's okay. But I think it was much better than before. This is good. The talk is okay. Talk is okay. Control that. Talk is okay. This thing is very critical. Move the random size from here. Random speed. Control this. Again, is working away. Control P. Now it's good. At least they are moving, you know. Okay. Okay, fine. Steer the player. Okay. Open this. 10x please. Steer the player overview. Starting from the overview. Okay.
Steer the player. In this tutorial, you'll create a controllable player ship that turns to face your cursor, and along the way, you'll learn how to detect input, convert mouse cursor position into world space, apply directional thrust, and respond to collisions, all using Unity's physics and input systems. 1. Overview. In this tutorial, you'll create a controllable player ship that turns to face your cursor and moves in that direction when you click the left mouse button.
Yeah.
Along the way, you'll learn how to detect input, convert mouse cursor position into world space, apply directional thrust, and respond to collisions, all using Unity's physics and input systems. 2. Set up the player game.
Okay. My step is complete. Feeling very tired. It's okay. So it's going to hours. It's taking a lot of time because I think yeah, it's complete. Yeah.
Game object. Before you can control the player, you need something to control. In this step, you'll create a triangle-shaped player game object, made up of multiple simple 2D shapes. This game object will represent the player's ship and point in the direction it moves. 1. Create an empty parent game object. Right-click in the hierarchy window and select Create Empty.
So you can do this. Right click on the in the hierarchy menu and you're going to create empty, and then rename it player. Okay, this is the player I will play. And in the inspector window, you can see here you have to assign these values 0, -4, and then I can go and save it.
Rename it player. With the player game object selected, in the inspector set the transform component's position property values to x equal to 0, y equal to -4, and z equal to 0.
Okay,
Note,
G equal to 0.
positioning the player game object at a negative y value will move it down on the screen, giving the
Okay.
player a bit more room in front from their starting position. 2. Add a triangle sprite as the main shape. In the hierarchy window, right-click the player game object and select 2D Object Sprites Triangle. Note, the problem with using a simple triangle like the default 2D sprite game object is that it would not be able to convey which direction the ship is facing. You need to add more shapes to make that more clear. 3. Add more shapes to show direction. In the hierarchy window, right-click the player game object again and add another 2D sprite, like a square, capsule, or another triangle. Move, rotate, and scale the additional shape using the Rect tool. T. Adding another shape helps visually indicate the ship's forward direction, which will become important when you apply thrust.
Okay. What I will do? Create another shape like sprites like rectangle. Okay. Suppose rectangle is square. Okay. Oh, move, rotate, and scale the addition shape using the Rect tool. Move here. Or make it small. Okay. Fine. So
Thrust. 4. Scale and position as needed. Use the Move tool, W, the Rotate tool, E, and the Scale tool, R, to adjust the shape so the player game object looks like a small ship and the pointer clearly shows which way it's facing. Tip: you can also scale the entire multi-part ship up or down by adjusting the scale property values of the parent player game object. 5. Optional: edit the player's sprite colors. Select all of the player game object's child game objects, select the color swatch in their sprite renderer component, and change their color. You now have
Green is better. Green is better. Because green will be different totally. So green is better. Okay. Or green is a little like this. So orange. What about orange? What about yellow? What about orange? Orange will be, green will be much better. Green is much better. Okay. Okay, fine.
Now have a visible player ship made from grouped sprites that's ready for physics and input control in the next steps. ADD
Okay.
required physics components. Now that your player ship is built, it needs physical properties so it can move and collide with other game objects. In this step, you'll add a rigid body 2D component and collider components to allow the player game object to interact with the physics system. Because your ship is made of multiple parts, you'll use compound colliders, separate colliders attached to each child game object. Unity treats the combined colliders as one when physics is applied to the parent.
1 minute. This somewhere else. Okay. Somewhere else you have to. Okay. Omit the duplicates as much as you can. You're fine. Control D. And no, 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 no. No. Okay. Okay, fine. Now what I will do?
Parent. 1 times 1. Add a rigid body 2D component to the player game object. Select the player game object. In the inspector window, select AD component and select.
So what I will do? And the rigid body. We have to scale to 0. 0. Okay. Child game object. And collateral will have all control. Okay, working perfectly. This collider, no? Because of that is working.
Select rigid body 2D. Set the gravity scale property to 0. This ship will fly, not fall. 2. Add colliders to all child game objects. Hold CTRL, MacOS, CMD, and select all the child game objects of the player game object. In the inspector window, select Add Component DIT Polygon Collider 2D or any other collider shape that fits. Tip: the Polygon Collider 2D component is a flexible option that fits most sprite shapes closely. 3. Enter play mode to test. The player won't move yet, but it should now respond to physics. See what happens when one of the flying obstacles collides with the player game object. Exit play mode when you're done. You've now given your player a physical presence in the world using rigid body and compound collider components. Next, you'll start scripting input so the ship can detect mouse clicks and respond. 4. Create the player controller script. In this step, you'll create a new C# script called Player Controller and attach it to the player game object. This script will handle all of the player's input, movement, and collision logic. In this step, you'll create a new C# script called Player Controller and attach it to the player game object. This script will handle all of the player's input, movement, and collision logic. This script is a custom component, a set of instructions you write that Unity will run during the game. Right-click in the Scripts folder and select Create EAEA Mono Behavior Script. Name the script Player Controller. Important, make sure the file name is spelled correctly when you rename the script Player Controller. Unity requires that the script name exactly matches the class name inside it. If the names don't match, you'll get an error.
Yeah.
If you make a mistake on its spelling, delete the script and create it
Execute
again
it
with the
again.
correct
Correct.
name.
Yeah.
2. Attach the script to the player game object.
It's
In
already
the hierarchy
attached.
window, select the player game object. Drag the player controller script onto an empty space in the inspector window, or select Add Component and search for player controller. Confirm it's attached. 3. Confirm it's attached. You will now see the player controller script listed as a component on the player. 5. Detect mouse clicks. You'll edit this script over the next several steps to handle input and movement. In this step, you'll write your first input detection code, specifically when the mouse is clicked. To do that, you'll use the Unity input system, which requires adding a special using statement like importing a library at the top of your script. In this step, you'll write your first input detection code. Specifically, you'll also be working inside the update method for the first time. Update is one of Unity's lifecycle methods, and it runs once per frame, making it ideal for checking input, which can change at any time. You'll use the console window to print a message every time the mouse is clicked, so you can test that the mouse clicks are being detected correctly. 1. Open the player controller script. In the scripts folder, double-click player-controller.cs to open it in your code editor. 2. Add code to detect clicks. Inside update, inside your script, locate the update method. Then, add the following lines of code inside the braces. Explanation. This checks if the left mouse button is currently being pressed down. Debug.log sends a message to Unity's console window, which you can use for testing. 3. If you see an error under mouse, you might get a red underline or error in the console window that says mouse doesn't exist. That's expected. To fix this error, add the following line of code at the very top of your
You
script.
can see here.
Tip. If you're using a modern code editor like Visual Studio or VS Code, you might be able to hover over the error and select a quick fix to automatically add this line. If you don't see an error under mouse, it likely means your editor already added the correct using directive automatically for you as you were typing. 4. Save and test. Press Ctrl plus, MacOS, CMD plus to save your script. Return to the editor and enter play mode. While the game is playing, click in the game view, then open the console window by selecting the debug message that appears underneath the game view. 6. Log the mouse position. Look for the message. Mouse was pressed.
Awesome.
You've now detected real-time input using Unity's input system. Next, we have to actually do something with that input. Now that your script can detect mouse clicks,
Now this step is complete. Lock the mouse position. Okay, fine. Now you can run it. I'm trying to implement it. You can see. Right click on right. You have to play. Yeah. Make it last so you can see it. Where is the message? I don't able to see message here anywhere. Then open the. Okay. Open the console window. Where is the console window? Oh, brother, where is the console window? window layout panels. Oh, where is the console window? Oh, you can see here. Now put this console somewhere here. I have to put here inside. If I'm not able to do it, why I don't know. Console कहाँ है यार? मिल नहीं रहा. Okay, I think I should stop here. Enough for today. It's really very crazy. Okay, playing this. Okay.
एनरोल कर रहे हो तो ऐसी कौन सी चीजें हैं जिनका आपको ध्यान रखना है, ऐसे कौन से टॉपिक्स हैं जो आपको पहले से पता होना चाहिए, नहीं तो आपको इस टॉपिक में डिफिकल्टी फेस हो सकती है अगर वो टॉपिक्स आपको पहले से नहीं आते. तो प्री रिक्विजिट जानना बहुत इंपॉर्टेंट है, जैसे कि थोड़ा सा आप अपना समय ले सकें और उन टॉपिक्स को स्ट्रॉन्ग करके आ सकें, फिर परसेंटेज पर ध्यान दे सके. भाई सबसे पहले जो सबसे पहला प्री रिक्विजिट है वो है आपकी स्क्रीन के सामने भाई मैथमेटिक्स और एप्टीट्यूड का जीरो नॉलेज चाहिए. मुझे बिल्कुल भी नहीं चाहिए कि आपको कोई टॉपिक पहले से आता है या नहीं आता है, डजंट मैटर. बिल्कुल जीरो से, स्क्रैच से, नर्सरी लेवल से बिल्कुल हम शुरू करेंगे. जीरो से हीरो बनने का सफर हम तय करेंगे यहाँ पर. तो हैशटैग जीरो से हीरो हमको यूज करना है बिल्कुल. और आपको कोई भी बेसिक नॉलेज की जरूरत नहीं है. बिल्कुल एकदम, अगर आप बिल्कुल एकदम गधे भी हो, अगर ऐसा नहीं बोलना चाहिए, अगर एकदम गधे भी हो ना, तो भी आप एकदम राजा बन सकते हो. कोई टेंशन लेने वाली बात नहीं. अब सर आपने जीरो नॉलेज बोल दिया, लेकिन सर मुझे पता है आपके बारे में, अगर आपने प्री रिक्विजिट्स करके एक वीडियो बनाई है तो सिर्फ जीरो नॉलेज अगर होता तो कुछ प्री रिक्विजिट अगर इतना ही होता तो इसलिए आप सेपरेटली वीडियो नहीं बनाते. बिल्कुल समझदार आप लोग, मुझे समझने लगे, बोला था ना वो हार्ट टू हार्ट कनेक्शन, राइट. तो कुछ और प्री रिक्विजिट्स हैं. जब भी आप यस सर की क्लास करने बैठे तो बगल में यार एक कटोरे में बादाम रख करके जरूर से बैठिएगा दोस्तों. ऐसा मैं इसलिए बोल रहा हूँ क्योंकि यार मेरा स्पून फीडिंग का काम नहीं है बाकी टीचर्स की तरह कि मैंने क्वेश्चन दे दिया उसका सॉल्यूशन दे दिया. नहीं भाई, क्वेश्चन दूंगा फिर आपको समय दूंगा क्वेश्चन सॉल्व करने के लिए. तो पहले आपसे मैं क्वेश्चन सॉल्व करूंगा, उसके बाद प्यार से मैं आपको सॉल्यूशन बता दूंगा. ऐसा इसलिए कि दोस्तों भाई एक्चुअली एग्जाम में तो आपको ही क्वेश्चन सॉल्व करना है, वहां तो यस सर नहीं आएंगे क्वेश्चन सॉल्व कराने के लिए. और मुझे पता है आप लोग एक नंबर के नमूने हो, आप लोग मन में बैठा लोगे कि यार नहीं हम बाद में खुद से सॉल्व कर लेंगे, अभी पर देख लेते. नहीं भाई, अभी सबसे पहले बिल्कुल तुरंत यहीं बैठा करके आपसे क्वेश्चन सॉल्व कराऊंगा तो हो जाएंगे, वरना आपने बाद के लिए जितने भी काम डाले मुझे पता है वो कभी पूरे ही नहीं हुए,
हाँ.
राइट. तो आपको अपना खुद का दिमाग थोड़ा सा यहाँ पर यूज करना पड़ेगा. और बादाम जो है दिमाग बढ़ाने के लिए बहुत काम करते हैं, तो बिल्कुल बादाम को रखिएगा. कोई क्वेश्चन नहीं बन रहा हो तो एक दो बादाम खाइएगा, दिमाग चलेगा और आराम से क्वेश्चन बन जाएगा. तो भाई जो एक्चुअल पहली प्री रिक्विजिट है वो बादाम है. उसके बाद अगली प्री रिक्विजिट है हाजमोला. कुछ टॉपिक्स ऐसे होंगे जो थोड़े से डिफिकल्ट है, देखिए बाकी टीचर्स की तरह मैं आपको इजी पढ़ा करके बाकी टीचर्स क्या करते हैं इजी पढ़ाते तो आपको लगता है यार टीचर बहुत अच्छा पढ़ा रहा है. भाई अपना वो स्टाइल नहीं. जो एक्चुअल प्रीवियस ईयर क्वेश्चन आए होंगे वो कराऊंगा, भले डिफिकल्ट हो चाहे इजी, राइट. कुछ चीजें डिफिकल्ट हो सकती हैं तो उनको थोड़ा पचाना जरूरी है ना. आप पचा पाओ अच्छी तरीके से उन कॉन्सेप्ट को डाइजेस्ट कर पाओ, उसके लिए बगल में हाजमोला रखना. तो कोई भी कॉन्सेप्ट ऐसा है जो आपको नहीं समझ आ रहा है तो बढ़िया से हाजमोला खाना, आराम से कॉन्सेप्ट को आप पचा सकते हो, राइट. और एक और बात मैं बता रहा हूँ, कुछ चीजें हो सकता है फॉर एग्जांपल वीडियो नंबर 12 में मैं कुछ समझा रहा हूँ, हो सकता है आपको इमीडिएटली वहां ना समझ आए, बट थ्रू आउट द एंड ऑफ द कोर्स, जब कोर्स खत्म होगा ना तो आपको पता चल जाएगा अरे यार सर ने वीडियो नंबर 12 में ऐसा इसलिए कराया था क्योंकि, राइट. तो पूरा जब आप कंप्लीशन करोगे ना कोर्स का तो आप पुरानी चीजों को बेहतर तरीके से एप्रिशिएट कर पाओगे, यार अच्छा इसलिए ऐसा हुआ, राइट. आप समझ रहे हो ना, तो इस बात को समझना बहुत जरूरी है. तो भाई हाजमोला होगी. उसके बाद भाई चौथा पॉइंट ये है भाई, ये क्या एक आदमी है उनके ऊपर बहुत सारी टोपियां रखी हुई हैं. देखिए अगर आपको इस कोर्स से 100% लेकर जाना है, मेरे ख्याल से शायद ही कोई होगा जिसको 99% गेन करना होगा लाइफ में, सबको 100% ही गेन करना होता है. इस कोर्स से भी आपको 100% गेन करना है अगर, तो आपको भी अपना 100% देना पड़ेगा. तो सर जैसा बोल रहे हैं वैसा करते जाओ तो बहुत ज्यादा मजा आएगा कोर्स में, फिर लगेगा यार हमने कुछ किया है, राइट. तो अभी आपको एक टास्क दे रहा हूँ, इमीडिएटली आपको टास्क करना है, मैं भी आपके साथ करूंगा. जस्ट हमको इमेजिन करना है कि हमने एक कैप पहन रखा है, राइट. एक हैट या एक कैप पहन रखा है, तो उस कैप की जो निब होती है, जो टॉप होती है, उसको आप पकड़ो. कैप पहने हुए आप पकड़ो इस कैप को, राइट. और इस कैप को धीरे से रिमूव करो, कैप को निकालो और जोर से कैप को फेंको. जोर से जू जाना चाहिए, जोर से कैप को फेंक दो. सर जी आपने टोपी पहना के फेंकवा दी, ऐसा क्यों? देखिए ये जो कैप था जो हमने फेंक दिया वो रिसेंबल कर रहा था आपकी एग्जिस्टिंग नॉलेज को, है ना. तो आपने अभी तक जितना भी पढ़ रखा है, मैं ये नहीं बोल रहा आपने बुरा कि आपने बहुत अच्छा करा अगर आप पहले से पढ़कर आए उस टॉपिक को, बट आपकी एग्जिस्टिंग नॉलेज जो है वो थोड़ी सी ट्रबलसम हो सकती है ना, थोड़ा सा ट्रबल क्रिएट कर सकती है क्योंकि कॉन्सेप्ट क्लैश होंगे. तो मेरा ओवरऑल पर्पस है कि आप जब भी मेरी क्लास को अटेंड कर रहे हो तो फ्री माइंड से अटेंड करना है क्लास को, राइट. कि हमको पहले से कुछ नहीं आता, जो सर सिखा रहे हैं उसको एकदम फ्रेश माइंड से मैं समझूंगा. आप यकीन मानिए आप बहुत अच्छी तरीके से चीजों को समझ जाएंगे और रिटेन करने में आपको बहुत हेल्प रहेगा, नहीं तो कॉन्सेप्ट आप भूल जाएंगे, राइट. बिल्कुल एकदम फ्रेश माइंड से, ऐसे माइंड से बैठना कि मुझे पहले से कुछ नहीं आता, जो सर सिखा रहे हैं वो मैं पहली बार सीख रहा हूँ. आपको बहुत मजा आएगा। मैं आपको बता रहा हूँ, एक पॉइंट जो मैं बताने वाला हूँ बहुत इंपॉर्टेंट है इस कोर्स में। अगला प्री रिक्विजिट पे चलते हैं। सर ये क्या है? ये तो आपको दिख रहा है खिचड़ी है सर। अरे सर भूख लगा, ये तो देख के चलिए ये खिचड़ी है, ठीक है। अगला देखते हैं सर ये क्या है? ये तो एक लड़का लड़की है, आपस में गले मिले हुए, निब्बा निब्बी का प्रेम है, ये गर्लफ्रेंड बॉयफ्रेंड सॉर्ट ऑफ हम बोल सकते हैं, राइट। चलिए सर आपने गर्लफ्रेंड बॉयफ्रेंड बुला लिया। अच्छा सर अभी आप बोलना क्या चाह रहे हैं भाई? थोड़ा सा सस्पेंस रखिए, आपको मजा आएगा जो मैं बोलना चाह रहा हूँ वो आप समझ पाएंगे। जस्ट थोड़ा सा वेट कीजिए। अभी मैं आपके सामने एक ऑडियो चलाने वाला हूँ, एक वेब सीरीज की ऑडियो है। इस ऑडियो को सुनकर के आपको गेस करना है कि हम किस वेब सीरीज की बात कर रहे हैं, ठीक है। चलिए। मेरे ख्याल से इतना लंबा समय तो लेने की जरूरत थी ही नहीं। मैं बात कर रहा हूँ अगेन, नहीं भी समझ आ रहा तो कोई बात नहीं, शायद इस इमेज को देखने के बाद एंगल से देखता हूँ तो वो मैं आपको समझाऊंगा। इज नॉट वेरी क्लियर है ना, सब कुछ मिला मिलू के आप खिचड़ी बना देते हो, राइट। रिलेशनशिप निब्बा निब्बी का प्यार अगेन एक कॉम्प्लिकेटेड चीज को डिनोट करता है, राइट। रिलेशनशिप आजकल बिल्कुल सिंपल नहीं होते, बहुत कॉम्प्लिकेटेड होते हैं, आपको पता है, राइट। उसके अलावा मिर्जापुर में भी आप देखिए यार, सब कुछ एकदम भसड़ मची हुई थी मिर्जापुर पानी के लिए। मैं अपनी मोरल ऑफ द स्टोरी क्या बताना चाह रहा हूँ कि यहाँ पर मुन्ना भैया को अपनी चलानी थी, ठीक है। उन्होंने बिना कालीन भैया से पूछे, सॉरी मुन्ना भैया को अपनी चलानी थी, गुड्डू भैया ने कालीन भैया से पूछे बिना रविशंकर जी को ठोक दिए। तो अगेन सबको अपनी अपनी चलानी थी, राइट। मेरा ऐसा मानना था शायद अगर सच में कालीन भैया को सब लोग फॉलो करते तो मिर्जापुर की बेटर कंडीशन हो सकती थी और सबका प्रॉफिट होता है इसमें। तो पॉइंट जो मैं एस्टैब्लिश करना चाह रहा हूँ यहाँ पर वो है नीड ऑफ मेंटोर भी, है ना। मेंटोर की नीड सबको है। तो अगर आपकी लाइफ में ना एक मेंटोर है तो अच्छा है ना। लेकिन अगर आपकी लाइफ में एक से ज्यादा मेंटोर है तो अगेन प्रॉब्लम हो जाती है ना। देखो शक्कर आप खा रहे हो मिठास के लिए अच्छा है, लेकिन ज्यादा शक्कर खाओगे तो वो भी नुकसानदायक है। तो ओवरऑल पॉइंट है कि अगर आप परसेंटेजेस या इन जनरल पूरे एप्टीट्यूड की बात करूं, मैं ये नहीं कह रहा कि आप यस सर से पढ़िए, आप जिस भी टीचर से पढ़ रहे हो मेक श्योर आप उसी टीचर को फॉलो करें, राइट। अगर आप किसी यूट्यूब चैनल, किसी कोचिंग इंस्टीट्यूट या किसी बुक को फॉलो कर रहे हो तो मेक श्योर आप उसी को फॉलो करें। कुछ टॉपिक एक जगह से पढ़ ली, कुछ टॉपिक दो जगह से पढ़ ली, मल्टीपल जगह से आप पढ़ रहे हो, बिना बात के आपके दिमाग में भसड़ मचेगी और आपको कुछ भी गेन नहीं होगा। मैं हमेशा बोलता हूँ जिस व्यक्ति को जीरो नॉलेज है ना उसको एग्जाम में जीरो मार्क्स मिलेंगे, जिसको फुल नॉलेज है ना उसको एग्जाम में फुल मार्क्स मिलेंगे, बट जिसको आधी अधूरी नॉलेज है ना उसको एग्जाम में हमेशा नेगेटिव मार्किंग मिलती है। क्योंकि आधी अधूरी नॉलेज वाले ना कभी भी क्वेश्चन छोड़ के नहीं आएंगे, करके जरूर आएंगे और गलत करके आएंगे। तो जीरो नॉलेज वाले बेटर होते हैं एज कम्पेयर टू जिनकी आधी अधूरी नॉलेज, राइट। तो इससे अच्छा फुल नॉलेज हमको गेन करना है तो किसी भी एक मेंटर को आप चूज कीजिए, उसी को फॉलो करिए। देखिए बाकी लोगों के बारे में मैं नहीं बता सकता, बट मुझे पता है मेरा पढ़ाने का स्टाइल बेस्ट है, बच्चे सिलेक्ट हुए हैं, 90% से ऊपर बच्चों का सक्सेस रेट हमने अचीव किया है। तो मैं इतना आपको इंश्योर कर सकता हूँ कि जो मैं पढ़ाने वाला हूँ दुनिया का कोई टीचर नहीं पढ़ा सकता वो, और आगे आने वाली फ्यूचर में भी कोई ऐसा टीचर नहीं बन सकता जो आपको इस लेवल पे इतने प्यार से इतने अच्छे से एप्टीट्यूड पढ़ा सकता है। बाकी चॉइस बिल्कुल कंप्लीटली आपकी है, जिस किसी को भी फॉलो करना है सिर्फ उसी को फॉलो करिए। वो यस सर भी हो सकते हैं, कोई और मेंटर भी हो सकता है, बट 10 लोगों को फॉलो करने से ना कुछ भी नहीं मिलेगा, आपको मैं आपको बता रहा हूँ, राइट। तो मेक श्योर चीजों को कॉम्प्लिकेटेड आप खुद करते हो, होती नहीं है कॉम्प्लिकेटेड चीज, हम खुद बनाते हैं बिना बात की बुद्धि चला करके। तो एकदम इनोसेंस से फेथ रखती हो किसी एक टीचर को फॉलो करेंगे जरूर सक्सेसफुल आप बनेंगे, इस बात का आप ध्यान रखिएगा, ठीक है। तो अगेन अगर आप एक मेंटर को फॉलो करते हैं, है ना, और अगर मैं पर्टिकुलरली बोलूं तो अगर आप यस सर अकेले को फॉलो करते हैं तो आपकी हालत कुछ इन भैया की तरह हो जाएगी, है ना। तो आप इस तरीके से प्रो बन सकते हो। लेकिन अगर आप मल्टीपल मेंटर्स को फॉलो कर रहे हो या यस सर को फॉलो नहीं कर रहे हो तो आपकी हालत कुछ ऐसी भी हो सकती है।
दोस्तों में से कभी फिसलने वालों को आता है मजा तो साथ में देखने वालों को मिलती है सजा। ये मिली इसको, इनकी फिसलन पट्टी पर साबुन ज्यादा डाला, पर बेटे शरीर साफ होना हो तेरी हड्डियां जरूर साफ हो। ठीक है। तो भाई अगेन कुछ इस तरीके की हालत हो सकती है। तो मैं नहीं चाहता कि आपकी हालत इन लोगों जैसी हो, मैं चाहता हूँ आपकी हालत इन प्रो भाई साहब की तरह जिन्होंने बास्केट डाला था। तो मेक श्योर आप एक ही मेंटर को फॉलो करिएगा। उसके अलावा अगली प्री रिक्विजिट क्या है सर? अगली प्री रिक्विजिट ये है, अच्छा पहले ये बताइए कि ये महानुभाव कौन है जो आपकी स्क्रीन पर दिख रहा है? बिल्कुल भाई पहले ही मन में आपके थॉट में आ गया भाई ये संदीप सर की मैं बात कर रहा हूँ, संदीप महेश्वरी सर की मैं बात कर रहा हूँ। अगर आप इनको पहचान पाए तो इसका मतलब आपकी जिंदगी में मोटिवेशन को आप कुछ वैल्यू तो देते हो। और मेरा भी ऐसा मानना है मोटिवेशन बहुत जरूरी है। हम दिमाग चलाने वाले हैं, हम अपने दिल और दिमाग का यूज करने वाले हैं, तो उसको वो फ्यूल मिलना चाहिए, वो एंथुसियाज्म, वो मोटिवेशन मिलना चाहिए जिससे कि अच्छी तरीके से वो चले। तो बीच बीच में मैं मोटिवेशनल कंटेंट का यूज करूंगा, कुछ अपना ज्ञान होगा, कुछ कहीं से लिया हुआ ज्ञान होगा, तो कुछ मोटिवेशन भी आपको मिलेगा। तो मोटिवेशन, फन और नॉलेज तीनों एक साथ मिलेगी। ऐसा करना बहुत जरूरी है क्योंकि भाई बाकी टीचर्स पढ़ा सकते हैं, नॉलेज दे सकते हैं, बट फन और मोटिवेशन जब नॉलेज में मिल जाएगा ना तो यकीन मानिए आप कॉन्सेप्ट को कभी नहीं भूलेंगे। अभी 3-3 4-4 महीने पहले जो मैंने कॉन्सेप्ट पढ़ाए होते हैं ना बच्चों को कंठस्थ याद रहते हैं क्योंकि मैं मीम्स एसोसिएट कर देता हूं, कुछ फनी इवेंट एसोसिएट कर देता हूं उस क्वेश्चन से, तो बच्चे रिटेन कर पाते हैं, राइट। तो क्लास में भी मजा बना रहेगा, क्लास बोरिंग नहीं लगेगी और साथ ही साथ में सीख जाएंगे। तो क्या क्या प्री रिक्विजिट है? एप्टीट्यूड नहीं भी आता चलेगा, कोई दिक्कत नहीं, मैथ्स नहीं भी आती चलेगा, कोई दिक्कत नहीं है, बिल्कुल जीरो से हम इस कोर्स को पढ़ने वाले हैं। पहला पॉइंट। दूसरा पॉइंट बादाम रखना है क्योंकि दिमाग चलाना है, हाजमोला रखना है क्योंकि टफ कॉन्सेप्ट को हम बता पाएं। उसके अलावा पहले से जो कुछ भी आता है सब जाने दो साइड में, एकदम फ्रेश स्टार्ट कर रहे हैं परसेंटेज की यहाँ से, किसी एक मेंटर को फॉलो करना है और मोटिवेशन, फन और नॉलेज सब कुछ एक साथ इस कोर्स में रहने वाला है। तो मैं बहुत एक्साइटेड हूँ। इस वीडियो में सिर्फ प्री रिक्विजिट्स डिस्कस करना था क्योंकि बहुत जरूरी थे। अगली वीडियो से स्ट्रेट अवे हम परसेंटेजेस और उसके बेसिक कॉन्सेप्ट से स्टार्ट करते हैं। थोड़ा सा मुझे बस समय दीजिएगा। लव यू ऑल, टेक केयर, बाय बाय, सी
When the PDF is completed already, you can select PDF.
30% marks in exam was still by 30 marks. It's by 30 marks. 60%. Easy. Hundred marks. So 30. 30 होगा ना, तो 30 होगा तो 14. What losses increased by 40. Losses increased by 40%. Now the cost price 1000. यार मुझे जगह नहीं था. How much is 30% of 80 greater than 25%? 30, 240, 75. Oh. 24, 20, 40, and 25% हो जाएगा. 1 minute, you have to be careful. Okay, okay. Tired. Yes, yes. Oh, why these questions are coming? I don't know. Twenty. 88.8. Uh, then what was the review? Where is that? One second. I think something is issue here. Something is issue. Just one minute. Yeah, this is the practice session. So you have to complete it. Now basic percentage. Okay, fine. Feeling very tired. Very tired. Oh.
Today I am going to start my research paper reading in this AR/VR device. You can see the environment. There is Earth, I'm currently in space station. Okay, you can see there moon and a lot of seeds are there. Plants are also there here. Here. So let's start reading the recipe paper. Okay. One second. What I can do? I will just wear this earphone. Okay. Now it's great. So starting from this recipe paper, design virtual model of an exoskeleton for lower limb rehabilitation. The author name is A. Petio D. Tarinath, D.N. Tarinath, Faculty of Mechanics, University of Craiova, Romania, University of Medicine and Pharmacy, Craiova. Abstract. In this paper, the design and virtual model of an exoskeleton for human lower limb rehabilitation is developed. The purpose exoskeleton is anthropomorphic. What is anthropomorphic? I can search it out on Copilot. Okay. Now you can see the Copilot screen is coming. It's searching it out. So you can see explain following text primarily based on the surrounding passage content anthropomorphic. Now see the text you highlighted anthropomorphic is explained in the surrounding page as a part of the design of rehabilitation exoskeleton. Here's the breakdown based on the document, meaning and context. Anthropomorphic, that here means that the exoskeleton is designed to closely resemble the human body's lower limbs in both structure and movement. The device mimics the mechanical model. Okay, this is important. Human body lower limbs in both structure and movement. This exoskeleton is designed to closely resemble human body lower limbs in both structure and movement. The device mimics the mechanical model drive system, size, shape, and overall appearance of human legs, making it easier to adapt to patients during rehabilitation. Why it matters? By being anthropomorphic, the exoskeleton will reproduce natural human gait patterns more accurately. This design allows for flexion extension movement at the hip, knee, and ankle that match experimentally measured parameters from real human subjects. It improves rehabilitation outcome because the patient's body experiences motion that feel natural rather than robotic or artificial. Supporting details from the paper. The exoskeleton uses rotational joints, 6 in total, 2 hips, 2 knees, and 2 ankles. Okay, these 6 joints are there, rotational joints. 2 hips are 2 for knees and 2 for ankles to replicate human walking. A simple electric motor with chain transmission drives the system, making it low cost and energy efficient. The anthropomorphic design is paired with experimental gait data collection from human subjects, ensuring exoskeleton movements align with real biomechanics. In short, anthropomorphic emphasizes that the exoskeleton is a human-like in form and function, which is crucial for effective lower limb rehabilitation. Would you like? Okay, this is asking me. Okay, fine. Okay, I will do. Close it. Now continue the paper. Low cost and easy to adapt on the human subject. The design aspect concerns the exoskeleton mechatronic. Okay, mechanics and electronics together means mechatronic structure achieved in SolidWorks environment, virtual environment. Okay, in order to realize the multi-body model, the virtual spatial model of a human. This is mannequin. So I can search out again the meaning of mannequin. Okay, you can see what I am seeing on your screen. Okay, and you can see the time is 11:22 now. So okay, meaning of mannequin, let's search it out. The mannequin means is that Mannequin is not a human, is not a soft dummy, but a computer-generated human figure that replicates the kinematic structure and mass properties of human locomotor system. Like there you can see a person sitting, but it's not a person there. It's a computer-generated human figure sitting there that replicates the kinematic structure. How he's moving his hands, the same virtual hand is moving there. You can see that. And mass properties of human locomotor system. It was built using anthropometric data, height, leg length, hip, knees, ligament length, etc. collected from real subjects. This mannequin serves as a test bed for simulating human walking and for evaluating how exoskeleton interacts with body. Role in the exoskeleton design. What the role that is play in this exoskeleton design? The mannequin play. So the mannequin lower limb are modeled with 3 segments. I can also see the pronunciation. You can search it here. So mannequin is also a film, but I want its pronunciation, not film. Okay. Yes. Okay. So pronunciation. How to say? Let me see. Let me see. Okay, here is mannequin. Okay, mannequin. It's not mannequin. This is mannequin. Okay, and another pronunciation that I can say is that and mannequin. Okay, this is not mannequin. Okay, anthropomorphic. Okay, this is, you can search it out. You can see the whole environment. Currently I am in a space shuttle. There's a moon there, and keyboard mouse is there, water bottle is there. I can drink water from it. Okay. Anthropomorphic. Anthropomorphic. Okay, it's fine. Okay, you can check it out here. So it's okay. Now it's time to continue the research paper. So I was reading this that the multi-body model, the virtual spatial model of a human mannequin developed in SolidWorks was transferred to the Adams data. Okay. The movement laws experimentally collected are introduced in each of the 6 rotational joints. What the 6 rotational joints? I already told. 2 for hips, 2 for the knees, and 2 for that knee. Okay, 6 rotational joints of the both lower limbs. Similarly, simulation of mannequin walking is performed. Okay. Introduction. More and more studies are dealing with the analysis of normal pathological human gait in order to design bio-inspired robotic structure as virtual design based on the specific tool of computer-aided design, CAD. Okay, in short you can say CAD, or in physical prototype used in the industry in the form of humanoid robots and collaborative robots. In biomechanics or clinical medicine or Orthotic systems. So what are orthotic system? I can check it out on Copilot again. It's searching out. So orthotic refers that to a supportive device designed to assist, line, or improve the function of the musculoskeletal system. In this paper, orthotic devices are discussed as external aids that help patients with impaired mobility regain or improve walking ability. So role in rehabilitation is that. So you understood what are orthotic system. Orthotic system are supportive systems that are designed to assist or align with or improve the function of musculoskeletal system. Musculoskeletal system. So in this paper, orthotic devices are discussed as external aids that help patients with impaired mobility regain or improve walking ability. So, what a role in rehabilitation? Orthotics are contrast with prosthetics. Orthotic devices support or enhance existing limbs, or prosthetic devices replace missing limbs. Okay. Orthotic devices support or enhance existing limbs, those are existing, and prosthetic devices replace missing limbs. Okay. The exoskeleton described in the study is considered an orthotic system because it attaches to the patient's legs, assist natural movement rather than replacing the limb. That is prosthetic. Is replace the limb. While this is an exoskeleton that we are described here in the study is orthotic system because it support, not replace that missing limbs. It support and enhance the existing limbs that the patient have. The patient have by being anthropomorphic human-like in design. The orthotic exoskeleton can reproduce natural gait patterns, making therapy more effective. The paper emphasizes that orthotic systems must be lightweight, low cost, and energy efficient to be practical for clinical use. In short, orthotic here means a supportive external device that aids human movement, and exoskeleton described is an advanced orthotic tool for lower limb rehabilitation. So, exoskeletons and mechanical robots used in the field of rehabilitation and rehabilitation therapy. The main goal is to sustain the mobility functional or disabled patients. This produce requiring a repetitive motion performed by the patient. In the last time, rehabilitation techniques use more and more mechanical systems like exoskeletons and robots to assist the lower limb in their movement. Rehabilitation, many review studies which evaluate the technology progress and future direction and rehabilitation were published in recent years. Among the benefits of robotic rehabilitation are reducing treatment according to patient's requirement, allowing control of joint movement, helping ensure controlled repetitive preparation at a reasonable cost, not that much cost, at a reasonable cost. Exoskeleton for industrial applications are presented in these things you can try out. Powered exoskeleton in post-stroke rehabilitation are studied in this section 24. Simple recovery devices and multi-joint exoskeleton are described by 21-22 this year, where most of the devices are based on the principle of predefined gait trajectory control. This principle is based on the implementation in the device control system of a data package acquired from a healthy person, and the exoskeleton replicates the desired joint trajectory. The aspect of control system of active exoskeleton is studied in while aspect of exoskeleton design. These two aspects are studied in different sections. You can see. While aspect of exoskeleton design, path planning, modeling, and simulation, experimental tests are studied by these. In this paper, the design and virtual model of an anthropomorphic exoskeleton, low cost and easy to adapt on the human subjects used for lower limb rehabilitation will be represented. In order to realize the multimodal body, multi-body model, the virtual spatial model of a human mannequin developed in SolidWorks are transferred to the Adams databases. The movement lows the movement lows from here experimentally collected are introduced in each of the 6 rotational joints of both lower limbs. Simulation of the mannequin walking is performed. You can study this experimental study. The human experimental study is performed using the biometrics limited data acquisition system based on variable electrogoniometers. You can search it out on Copilot again. Electrogoniometers, what are? So, electrogoniometers are, let me see the pronunciation as well. Electrogoniometers, okay. Okay, fine. You can see that pronunciation, okay. Okay, you can see this. Electrogoniometry or meters, okay, fine. Electrogoniometry. Electrogoniometers is explained as a part of the experimental setup used to collect human guide data for designing the rehabilitation exoskeleton. Here's a background meaning in context. Electrogoniometers are electronic instruments that measure joint angles in the real time. In this study, they were attached to the hip, knee, and ankles. Okay, of a human subject to record the flexion, extension, moment, flexion. Role in research: the data from electrogoniometers provided precise angular trajectory of each joint across the gait cycle. These measurements were essential for building virtual mannequin in SolidWorks and for programming the exoskeleton movement. By using electrogoniometers, the research ensured that exoskeleton's joint motions matched natural human biomechanics. Why it matters? Accurate joint angle data is critical for rehabilitation devices. It allows the exoskeleton to replicate normal working patterns. Okay. Without electrogoniometers, the design would rely on approximations, reducing the effectiveness of therapy. Combined with force-led measurements for ground reaction forces, electrogoniometers help create a complete biomechanical model of human gait. In short, electrogoniometers here are specialized sensors used to measure joint angles during walking, providing the experimental data that makes exoskeleton's anthropomorphic design possible. So you can see this. Okay. The variable biometric system allow capturing, once again, what is this going on? Okay, allows capturing information during human gait and analyzing biomechanical data outside laboratory. For data acquisition, where we use three edge channels, data log devices at a frequency of 500 Hz, two for connecting electrogoniometer, and one device used for 6 plate forces used for collecting the data of ground reaction forces. In figure 1, you can see the figure that your the figure 1, the block diagram of the data acquisition process. You can see this is a data acquisition diagram. This is a process, complete process in a diagram. Okay, so in this diagram you can see the subject with mounted electrogynometers, 4 plates, and the data log device shown as devices are shown. Using biometric systems, the experimental measurements are performed for 5 trials of 20 consecutive walking, 5 trials of 20 consecutive walking cycles of a male subject. Yes, the subject was pain-free and had no evidence or non-history of motor skeletal disorders or a record of surgery to the lower limbs. The anthropometric data of the human subject are shown in the table. This is the table. Values of once again, let me increase it, the size of it. Okay, now you can see the data is there. The experimental data were acquired for all 6 joints lower limb for our ground walking cycles on 6 force platform. In figure 2, you can see the next figure. One second. Okay, you can see the next figure. In figure 2 are presented the diagrams of flexion, extension, angles of the ankle, knee and hip collected for both legs, left and right. Okay, first is right and then is left. This is for right one and this is for left one. Okay, fine. For both legs. Okay, the acquisition data system, and in figure 3 the diagrams of ground reaction forces corresponding to trial 1 are presented. Okay, you can see here figure 2 the diagrams of consecutive cycle of variation of flexion, extension angle in a sagittal plane and rotation in the front plane represented by the software based on experimental data collected for both hips, both knees and both ankles. And figure 3 you can see the experimental ground reactions forces variation on the 6 force platform, different 6 different force platforms. For each, the experimental ground reaction forces are given. You can see the first one, second one, third one, fourth, fifth, sixth, and the variation model. Okay, the virtual model of the exoskeleton is the development of the new device has started from the idea of reproducing the movement of the lower limbs as close as possible to human one, and possibility of varying the flexion extension angles for each joint. The proposed exoskeleton aims to recover and improve walking in people with lower limb disorders like knee osteoarthritis or hip osteoarthritis. Therefore, the proposed device can be used in rehabilitation therapy and can be adapted to a recovery of the joint motion of both lower limbs as well as single lower limb. The virtual model of the exoskeleton is shown in figure 4a. This can be used in the Unity environment, VRV environment to see and experience in virtual reality. So I will do it after some time. Okay. This virtual model of the exoskeleton is shown in figure 4a. The virtual model of the exoskeleton is there. The virtual model of the lower limb of the exoskeleton is here in the B. The virtual model of the exoskeleton, the virtual model of the lower limb of the exoskeleton, and a detailed power transmission system to which power will be transferred and this will work. The solution presented in one of the low energy consumption for the actuation of the wall device. A single rotary motor being used which drives using chain transmission. The device features 8 elements and 10 rotation spindles in its structure. The metal frame is designed to meet several features: simple construction, modularity, and ergonomics, safety. Okay. Now next, the exoskeleton was designed in a similar way to the human lower limb. both in terms of mechanical model and the drive system. Both in both system type, it was manufactured in terms of both systems, the mechanical model systems and the drive system, as well as in terms of size, shape, and overall appearance also. It was designed in such a similar way. The dimensional and characteristic of lower limb have been studied for the purpose of imposing them as an input data in the design of exoskeleton. The virtual model of the inferior limb of the exoskeleton is shown in figure 4b. As you can see upper, this is the you can see this is the virtual model of the lower limb of the exoskeleton. Okay, so the elements in figure 4 see the following meaning. First is starting from number 10, bar type of element corresponding to figure to the femur. 11, bar type element corresponding to the tibia, some part of the body of that. 12, bar type of element that helps to achieve the flexion extension angle of the knee. Okay. 13, bar type element that helps to achieve flexion extension angle of the ankle. 14, bar, one second, let me. 14, bar type element for the foot. Okay. And 15 and 16, for 15 and 16, the upper side, bar type element by which the amplitude of the flexion extension angle of the three joints is adjusted. 17, you can see 17, number 17, 12, 13, 14, 15, 16. Where is 17? This is 17. Okay. So 17, a chain tooth wheel that converts the rotational motion of electric motor into a pivotal motion of the elements. 10 and 13. 10 and 13. Okay. 10 and 13 are that for that. Okay. And 18, 19, 20. 18, 91. And 20, where is 20? 18, 19, this is 20, okay. Chain gears that are the parts of the power transmission system. 21, this is 21, 21 and 22. Okay, chains through which power is transmitted. And 23 is the electric engine. You can see the electric engine there. The entire movement of acceleration is generated by a single electric motor. The transmission of power from engine to both lower limb of the acceleration is achieved by mechanical transmission composed of the gears 18, 19, 20 and the chains 21 and 22. So this is the process. The entire movement of acceleration is generated by single electric motor. The transmission of power from the engine to both lower limb of the exoskeleton is achieved by mechanical transmission composed of by the gears. We are the gears 18, 19 and 20. Okay. And chains are there 21 and 22. Okay, fine. The principle of the hip joint functioning movement is inspired by the human hip movement. The device being designed to provide a flexion extension movement that meets the experimentally measured parameters on subjects. The main component of hip joint is the element 10 similar to the human femur. Okay, search it out. This search femur. Okay, Copilot search femur is there. Femur. This is the femur. Let me see. Sorry for this ad is the part of that. Okay, so few more, 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 few more. Okay, few more. The actuator rotates the chain gas 17 fixed on the frame in joint A and transfer the motion to link 16. This 16 being connected by joint B to chain gear and by joint C to female segment. The female segment represented by link 10 and is fixed on the frame by joint D. Okay, takes over the moment from link 16 by joint C and convert it into pendulum moment, which represent the flexion extension moment. In figure 5a, you can see the virtual model of the hip joint of exoskeleton. So now then 5b, the principle of the hip joint functioning is presented. Okay, so next, the movement of the exoskeleton knee mechanics is designed to perform a flexion extension movement that meets experimentally measured parameters on subject. The knee joint is composed by two main elements, link 10 and link 11. Link 10 femur and link 11 tibia fixed by joint F and secondary element. Okay, I think how much battery is there? 41%. I think I should charge it as well. Okay, now it's okay. What I can do, fine. I think it's charging now. On the switch. On, but oh, fine. Check it out. It's charging now. It's charging now. Thank God it's charging now. Here I can continue my study. Okay. So next, start it. So I was there. The movement of this exoskeleton knee joint mechanism designed to perform a flexion extension movement that meets experimentally measured parameters. Increase the speed. The knee joint is composed by 12 fixed with link 11 by joint H. The chain gear transfer the motion to link 15 by joint A. The secondary element, link 12, takes over the motion from link 15 by joint T and transfer into link 11 by joint H. So this is the whole setup. The movement of exoskeleton knee joint mechanism is designed to perform this extension movement and that meets experimentally measured parameters on subject. The knee joint is composed by two main characters, the link you can see the link 10 here, femur and link 11. Link 11, where is the link 11? The link 11 tibia fixed by joint F, and secondary element link 12 fixed with link 11 by joint H. The chain gets transfer the motion to link 15, okay, by joint A. The secondary element link 12 take over the motion from link 15 by joint E and transfer it to link 11 by joint H. In figure 6 are presented the principle of knee joint operation, virtual knee joint model, and movement system to the knee joint. Okay, the movement of adjacent ankle joint is the result of action of two main elements, the link 12, link 11 and the element 14 representing the foot. Okay, you can see here, yeah, now here you can see here virtual knee joint model. So the link 11, the moment of exertion ankle joint is result of the action of two main elements, the link 11, this is the link 11, and the element 14, where the element 14 is, yeah, this is element 14, okay, representing the foot, as well as secondary element 13. You can see the number 13 here. This is secondary element. The moment of the ankle joint, unlike the other two joints, is not driven by the electric motor, but is the result of the combination of the moment of the three elements mentioned above, 11, 13 and 14. The flexion extension angle of the ankle joint is performed by the movement of the knee joint, to which the moment of the element 13 is added. Okay, in the figure 7, you can see the figure 7 here is presented the principle of the knee joint operation and the ankle joint, this is ankle operation principle. Now next, virtual model of the mannequin. The virtual model of the mannequin developed in SolidWorks, presented in this figure, you can see in 22, and used in these simulations respects the kinematic structure and mass properties of the locomotive system. The virtual model of the elaborated mannequin respects the kinematic structure and mass properties of the locomotive system. The virtual model of the human mannequin was developed in SolidWorks using the anthropomorphic data of the subjects in the table 1. The mannequin data obtained in SolidWorks can be easily modified in case of research done on different human subjects due to parameterized design. In figure 8, you can see the virtual model of the mannequin that make up of 13 component parts connected by kinematic rotational couplings is presented. In order to realize the multi-body model, the virtual spatial model of the mannequin developed in SolidWorks was transferred to the Adams database. So this thing was done in order to realize the multi-body model. The virtual spatial model of a mannequin developed in SolidWorks was transferred to the Adams database. The mannequin was modeled so that the lower limb consisted of three elements, femur, tibia and foot, and three joints, the hip, knee and ankle joint. The three joints were simplified in the form of rotational joint. Okay, the three joints were simplified in the form of rotational joints. What are the three joints? These three joints, the hip, knee and ankle joint. They were simplified in the form of rotational joints to allow the flexion extension movement to be reproduced. The definition of three kinematic joints corresponding to the lower right limb is presented in figure 9 to 11. Okay, first is definition of the kinematic joint corresponding to the hip. This is the kinematic joint corresponding to the hip, or this is the kinematic joint corresponding to the knee. This is corresponding to the hip, and this is corresponding to the knee, and this is corresponding to the ankle. This is all the kinematic joints corresponding to each respective rotational joint. For hip, for knee, for knee and for ankle. The next step of the modeling was introduce the moment low experimentally collected in each of the 6 rotational joints of the lower right and left limbs. The experimental data in tabular form were introduced in Adams, were interpolated as spline function. Using the Akima method in figure 12 to 14, the graphs of the variation of spline function of the right hip, knee and ankle joints are presented. You can see here the figure 12 to 14, the graphs of the variation of spline function according to this hip, the right hip, the function of time second. This is the function of time, how it varying with time in the variation of the angle, flexion extension angle in radiation. Okay, in the this is in the radius. Spline function of variation of flexion extension angle rate of the right knee function of time. Spline function of variation of flexion extension for this is function of time in the right angle. Okay, this is in right knee, this is in right hip. Okay, similarly the experimental data were entered for 3 joints of the lower left limb and the corresponding spline function were determined. An important aspect of the construction of the multi-body model is the definition of the contact model between sole and the floor. Okay, the virtual simulation environment Adams has the possibility to perform calculation on rigid elastic model in which the contact bodies are considered rigid and contact surfaces are considered deformable. So this thing is very important. The virtual simulation environment and Adams has the possibility to perform calculation on rigid elastic model in which the contact bodies are considered rigid. They are not considered flexible. They are considered rigid and the contact surfaces are considered deformable. Contact bodies are considered rigid and contact surfaces are considered deformable, and contact modeling is based on the impact method, not some other method. It's based on impact method. In Adams, it is possible to use the impact method for defining the contact by introducing a cubic function of the form. This is the cubic function f in the function of x and v. This is the linear constant k and this is x. So plus c x by d whole square multiplied by 3 minus 2x dv. X is linear constant model of a linear arc, c is damping coefficient and d is the penetration depth. The damping force is 0 when the depth of penetration of two bodies is 0. So when the damping force is 0, when the depth of penetration of two bodies is 0 and reaches maximum value when the depth of penetration is reached d. Okay, so the approximate value of the constant coefficient introduced in Adams by the impact method are k equal to 46.58 Newton per millimeter, and for C the damping coefficient is 97.19. So K is 46.58 and C is 97.19 Newton per millimeter per second, and the penetration depth 16 millimeter. Okay, taking into account the above consideration, the contact between the sole and ground are considered according to figure 15. So we will insert contact parameters here, taking into account the above consideration. That value of K is 46.58 and value of C, the damping coefficient is 97.19 and the penetration depth D is 16 millimeter. Okay, so we will get the details here. Okay, the solution of the dynamic model was realized by using the WSTIFF solver and SI2 integration algorithm. The results obtained by Adams simulation consists of graphical results representing the trajectory of the joints. The trajectory performed by the centers of the three joints obtained from the numerical simulation in Adams are shown in figure 16 to 17. The walking stages performed by the mannequin during the simulation are presented in 16b. This is the successive position of the mannequin on the ground, or the trajectories of the centers of the three joints of the mannequin. You can see here. Conclusion: the design, the virtual model, the constructive and functional principle of an exoskeleton for human level rehabilitation are presented. Definitely, the proposed exoskeleton is anthropomorphic, low cost, easy to adapt on the human subject. The design and exoskeleton mechatronic structure is realized in SolidWorks virtual environment. This is released in SolidWorks virtual environment. The virtual spatial model of a human mannequin developed in SolidWorks was transferred to the Adams database in order to develop the multi-body robotic structure. The movement laws experimentally collected by using biometric systems are introduced as tabular data in each of the 6 rotational joints of both lower limb, 2 hips, 2 knees and 2 ankles. Simulation of the mannequin walking is performed. A future work, we intend to continue the numerical simulation in order to obtain the ground reaction forces and the reaction forces in every joint, as well as the optimization of the mechatronic structure of the exoskeleton. So these are the references. You can read all the references. So now the paper is ended. The complete paper is I have read all the paper. Now it's time to make some questions from this and make a summary of this, make all the important points in one note. Okay, and then this paper will finally over. So I'm going to have a break. Okay, I will stop it here. So I'm summarizing my whole research paper in few words. So this research paper that I read on design and virtual modeling of lower limb rehabilitation exoskeleton. So this research paper details the design and virtual modeling of a low-cost anthropomorphic exoskeleton intended for lower limb rehabilitation. The author utilizes SolidWorks to create a mechatronic structure and a human mannequin. And once again, I'm going to tell what is mannequin, so you can understand more better. So search it out. So mannequin is used to describe a virtual human model. Okay, it's a virtual human model created in SolidWorks for simulating and testing the rehabilitation exoskeleton design. This is mannequin. Mannequin means a virtual human model that we have created in SolidWorks for simulating and testing the rehabilitation exoskeleton design. And mannequin is a computer generated representation of, I already told you that it was built using anthropomorphic data like leg length, what the leg length of the user, hip, knee, segment length, and overall body proportions collected from real subjects. This mannequin is not a soft dummy but a biomechanical simulation tool. This is a biomechanical simulation tool. This is not a soft dummy that we purchase some device from shop and we are using. No, it's a biomechanical simulation tool. And role in exoskeleton project is that the mannequin legs are modeled with 3 segments: femur, tibia, and foot. And 3 joints. 3 segments are there and 3 joints are there. These are important. The mannequin legs are modeled with 3 segments: femur, tibia, and foot, and 3 joints: hip, knee, and ankle. Okay, each joint is simulated as a rotational joint, allowing flexion and extension movements that match human gait. Experimental data from electroconiometer. Once again, what I can do, let me place this screen somewhere far from here so I can. Okay, so each joint is simplified as a rotational joint, allowing flexion extension movement that match human gait. experimental data from electroganometer of joint angles and force plus ground reaction forces were fed into mannequin to simulate realistic walking. This is the experimental data from each electroganometers for each joint angles. What are joint angles? I already told hip, knee, and ankle. Okay, and force plates, ground related forces were fed into the mannequin to simulate realistic walking. This is the thing that they earned very expertly, that they collected data from electroganometer, joint angles, and force plates, ground relative forces were fed into mannequin to simulate realistic walking. Okay, why it is matters? The mannequin provide a virtual test bed for simulating how exoskeleton interacts with human body. Okay, it ensures that the exoskeleton movement are anthropomorphic, human-like, and aligned with natural biomechanics. This reduces design error and improves rehabilitation outcome before building physical prototypes. In short, mannequin here means a virtual human body used for biomechanical simulation, essential for testing, refining exoskeleton design. It's okay, fine. So you can see this. So the author. So to ensure realistic movement, research uses a variable data acquisition system. Once again, the final device features a single motor drive system that efficiently powers the hip, knee, and ankle movement through a series of chains and gears. Ultimately, study demonstrated functional virtual simulation of the exoskeleton assisted mannequin. Walking, laying groundwork for future physical prototypes and clinical application. So, the primary purpose of the proposed exoskeleton, the device is designed as the anthropomorphic low-cost exoskeleton, especially intended for rehabilitation of human lower limb. What specific medical condition is this device intended to treat? The exoskeleton aims to improve walking in individuals with a lower limb disorder, such as knee osteoporosis or hip osteo. Two things are there: knee osteoarthritis. Let me see the pronunciation of this. Okay, fine. So what I can do? Osteoarthritis is the most common form of arthritis affecting millions of people worldwide. It occurs when protective cartilage that cushions the ends of the bones wears down over time, leading to pain, stiffness, reduced mobility. I want meaning of it. Okay. Okay, osteoporotic symptom can usually managed through the damage to joint can be reversed. Staying active, maintaining a healthy weight, receiving certain treatments might slow progress of the disease, help improve pain and joint function. One second. Is 1 hour. Discard the activity. So you can see here. of the authority. Osteoarthritis is pronounced as, I want the pronunciation. Where is that mic? Okay, here is the. Osteoarthritis. Okay, once again. Osteoarthritis. 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 Okay, fine. So the exercise aims to recover and improve walking in individuals with a lower limb. This, one second. The exercise aims to recover and improve walking in individuals with lower limb disorder, such as knee osteoarthritis or hip osteoarthritis. Oh, so the software tools that were used for design and virtual modeling are the magnetronic structure was designing SolidWorks. Okay. While multi-body model and GAD simulation were performed using these two things are important. Okay, the magnetronic structure was designed in SolidWorks, as you seen there in the research paper, while the multi-body model that you see in that GAD simulation or that were performed using the Adams database. So how many motor power the entire acceleration device? To ensure low energy consumption, the design utilizes single rotary motor, no multiple motor. Only a single rotary motor was there to actuate the entire device. So it's very low energy consumption because only a single rotary motor was there. So what was the source of CAD data used for the simulation? The movement laws were experimentally collected from the healthy human subject using a variable data acquisition system and describe the anthropometric profile of human subject used in experimental study. The measurement taken from 70 kg male, 176 centimeter tall, with leg length of 84 centimeter. So this is the profile of human subject used in the experimental study. A 70 kg male subject, which was 176 centimeter tall and which has a leg length of 84 centimeter. You can see in the research paper. I will show you. Okay. So you can see this is the person whose the device is attached. This exoskeleton is attached, and you can see the weight is 70 kg, height is 176 centimeter, length of the leg is 84 centimeter, and length of the hip knee. This hip knee was 43 centimeter, and length of the knee ankle segment was 41 centimeter. So you can see all these things. So once again, let's see all the questions. What kind of transmission system is used in the exoskeleton? The device employs a mechanical chain transmission composed of various gears. Okay, the device employs a mechanical chain transmission composed of various gears and chains to transfer power from the single motor to the lower limbs. How is the ankle joint? 1 second, 40%. Okay. So how is the ankle joint movement generated in this design? Unlike the hip and knee joints, the ankle joint is not directly driven by the motor. Its flexion extension moment is the result of the combined motion of the leg, foot, and secondary linkage element. How many segments the joint comprise the lower limb of the virtual mannequin. The lower limbs are modeled with 3 segments: femur, femur, tibia and foot. Femur, tibia and foot, these are 3 segments in which the lower limb model, okay, and the 3 rotational joints, hip, knee and ankle, to allow for flexion extension movement. However, the experimental movement laws introduced into the Adams simulation. The experimental data was entered into Adams in tabular form and then interpolated as spline function, as you seen in the that research paper. I will show you again. Okay, tabular data, Adams is tabular data, tabular form, and interpolated spline function. You can see this. These are tables. Okay, the data acquisition process tables. You can see here, and 1 second. Okay, corresponding to these are tables for each data. Spline function. This is spline function. This is a spline function for each different segments. Okay, not segment, for each part: hip, knee, and ankle. Okay. So, what interpolation method was used for the get data in the simulation? The researchers utilized the Ekima method to interpolate the experimental data into the spline function used for the joints. Describe the contact model used between the mannequin sole and the floor. The contact is a rigid elastic model based on the impact method, where contact bodies are considered rigid while the contact surfaces are deformable. What integration algorithm and solver were used for dynamic model solution? The solution of dynamic model were achieved using the WST solver and SI2 integration algorithm. What are the key design features of the exoskeleton metal frame? The frame is designed for simple construction, modularity, ergonomics, and safety. What are the main benefits of robotic rehabilitation mentioned in the study? Benefits included reducing dependency on the clinical staff, providing adequate movements, adjusting treatment to patients' needs, and ensuring control repetitive movement or at a reasonable cost. Because the cost used for other movements, for other things were very large, so we have to make it reasonable according. So, name the components that make up the virtual knee joint in the exoskeleton. The knee joint consists of 2 main elements. First was link 10 femur, and second was link 11 tibia. These are the 2 main elements the knee joint consists of: femur and tibia. Femur and tibia, link number 10 femur, and link number 11 tibia, joint connected by a joint. Okay, and a secondary element, link 12, that helps achieve the flexion extension angle. Now, how is the amplitude of flexion extension angle adjusted in the joints? The amplitude is adjusted through by bar type elements level 15 and 16 within the joint mechanism. With what data acquisition system was used for experimental measurement? The study used the biometrics limited data log device with variable electrogoniometers operating at frequency of 500 Hz. What specific joints of lower limb were monitored during the experimental study? Experimental measurements were performed by the flexion, extension, inversion, and various valgus angles of the hip, knee, and ankle joints for both legs. What are the planned future direction for this research? Future will include continuing simulation to obtain ground reaction forces and joint reaction forces, as well as optimizing the mechatronic structure of the exoskeleton. So it's time to use this virtual reality, this virtual model of this exoskeleton in my project and make some great things. Okay, so let's start working on it. So what I will do, I will ask it that provide the virtual model of the lower limb okay, consulting your sources, defining the exoskeleton model, defining okay, analyze the which model rolling develop a two-stage approach, the mathematics design, structure of component design. Fine. So what I will do, parallelly I will open some learn Unity, okay? Learn unity.com, okay? Pathway game development, okay, fine. So if you want to make your own games, then you can follow this pathway, but this is not only for game. You can also create your great environment also using this course, okay? So continuing the pathway. So create a new 2D project. Now that you have reviewed the final game, it's time to start building it yourself. In this step, you will create. Okay, I created it already. I have created it. I mark it complete. Okay. Okay, fine. Now set up your layout. Unity's layout is customizable. Okay, and organizing your windows early helps you work more efficiently. So it's very important to organize it. Okay, also setting your layout so that it matches the instructions and screenshot in this course. Okay, in this step you will arrange your workspace so that you can see the scene view. As you can see, this is a scene view. Okay, 2D scene view. So the game view, here you can see the game view. Okay, fine. And next is the hierarchy. Where is the hierarchy? This is the hierarchy. You can see the hierarchy here. And then project. Where is the project? Okay, here's the project. Fine. And inspector windows. This is the project window, and this is inspector window. Okay, fine. Now select 2x3 layout pass. So you can change your layout here by 2x3. Okay. Move the project window below the hierarchy window. So what I will do? So move the project window below hierarchy window. Okay. Move the project window below the hierarchy window. Fine. So it sits below the hierarchy window. Okay. Drag the upper edge of the project window up. Drag the project window so it's in the upper right corner of the Unity editor. Open the layout. Drag the project window so it's below the okay. Drag the upper edge of the project window up so that it aligns with the top of the game view. Game view, where is the game view? Where is the game view? Okay, fine. You have to put here. Fine. I think this is it once. Okay, fine. Okay, I understood. You have to do one thing, that you have to 1 minute. Now is great. Okay, now is great. Now you do your work. It's fine. Tidy the project window. View. In the project window, select the more. Where is the project window? Here. More window. And ensure the one column layout. Okay, is enable. Okay, your layout is not configured so that you can comfortably access all the tools you will need according to during development and more easily follow along with. Okay, fine. So navigate around a new 2D scene, creating a new scene. Ensure a clean, organized starting point for your game. In this step, you will set up and save the dedicated scene. Okay, scene, create scene, and then scene. Once again, let me do it. Okay, close this one, close this one, close this one. Okay, scene, create, then scene, then scene. Okay, fine. It's now already created. Now rename the scene as a game. Open the game scene, double click the game scene to open to a new scene. A dialog static scene has been modified. Okay, fine. Dialog is there already, huh? Now tell. Okay, fine. Now what I will do, double click the game scene to open. My scene is now open. Okay, fine. Now scene has been modified. Might appear the resulting sample scene when promoted as don't save. So you have created a new scene and so no longer needed. You will now see the name of your scene game. Okay. Now next, I will practice navigating 2D. Use your scroll wheel, or two finger swipe. Okay, fine. Or on trackpad or to zoom in and zoom out. Ensure the view tool. Hand. Where is the hand? This is the hand. You can now move your scene wherever you would like to move. Okay. Then hold the right click and drag it. Okay. Navigating the scene view for this is that helps me quickly lesson. Okay, fine. Now you have understand how to navigate. Okay, fine. Add an obstacle sprite. Okay, to build your game world, you will start by adding a simple hexagon shape obstacle to your scene. Okay, so what I will do, I will create a 2D object. Okay, go here, 2D object, sprites. Then what I want to hexagon flat surface. Set of obstacle. Okay, obstacle one. Now I will create obstacle. Okay, F2. Then I will rename it obstacle. Is plural or singular? Okay, only obstacle. Okay, fine. Then I will position it at 0, 0. Okay. Okay, hello friends. So today I'm making some Unity environment in this AR/VR headset. You can see. So in this my Unity environment, I'm going to add obstacle. Okay, sprite. Once again, let me. Where is the? Come here. So to build my game, first is that the axis is written left to right. Okay, zero. A 2D hexagon sprite. Right click in the hierarchy window. Okay. 2D object, sprites, hexagon, flat top. Okay, hexagon flat top is now. Just create a new uh, hexagon step. Rename the position. Rename the obstacle. It's already done. Choose it already done. Change the color. Optional. Select the color swatch. Sprite render. Okay, fine. Select the obstacle and select the color swatch. Sprite render component. Okay. Select a new color. So the color swatch. Where is the color swatch? Sprite render component. Where is the render component? Okay, fine. Next. What I can do? Make a prefab and then assign it. Maybe this will work. Okay, make a new prefab of obstacle. Go to scene, not scene, go to asset, create folder, name it prefab, only prefab. Open it. Now create material, name it obstacle. You can give any color that you want. Okay. What color I can give, I don't know. I think there will be no obstacle like this. Only you can give from here only. Select the color, sprite render, and select color. Any color you can give. You can give yellow color. Okay, fine. Yellow color is assigned. Okay, you can see my this yellow color. Okay. You now place a static obstacle in the wall centered at the origin. Okay, you will later give it physics property so it can move and bounce, but for now it's a visual reference point in your 2D space. Okay, change the size and background of the camera. In 2D games, the default camera uses an orthographic projection. Orthographic projection meaning it shows the world without perspective. Objects don't get smaller as they move away. Instead of zooming in or out with camera, you control how much of the scene is in view by changing the size property. Right now the area in view is a little too small. In this step, you will adjust orthographic size of main camera to zoom out a bit, and if you want, you can also change the background color. Okay. Suppose like this. Go to main camera. Okay. Size. Okay. You can increase the degree size by this. Okay, fine. How much I want to increase? 7.5. Okay, I will increase to 7.5. where is 7.5. Okay, now you can see the size is increased to 7.5. Okay, now what I will select that environment, then sky, solid color. Okay, select solid color. Okay, and from color you can select any color that you want. Any color that you want you can select. Suppose I am going to select this color. Okay, one second. Black color he selected. 100. Okay, he selected black color. Okay, fine. I will also select black color. Okay, now it's okay. Yeah, perfectly okay. In the hierarchy window, select the main camera. Okay. Then all things that are written, that are given in the video, are written in the description form. You can just read it and do it as it is, or you can follow the video also. That will be very interactive. A skybox is a 3D wrapper used in 3D games. Since you are making a 2D game, solid background color is simpler and more appropriate. After this step, your camera shows a larger area of the game world, and the background color is adjusted to your liking. Okay, fine. Now create the first scene border. Your player and obstacle need to stay within visible bounds. So it's time to build a screen boundary. You will create a 2D sprite. Okay, one second. So you can see you will create a 2D sprite to act as a bottom wall, and use Unity's React to position and size it. This tool lets you directly manipulate and shape and size a 2D game object in the scene view. So we will go and create 2D object and square. 2D object, sprite and square. Then we give border bottom name. Rename it to border bottom. Okay. I press F2 for renaming it and write the name border bottom. Okay. Now next step is that I will resize it. Okay, I will resize it like this. You can, without recycling, what I can do, I write the values that given here. 1 minute. Stop, brother. Okay, I will write all the values that are given here. -0, 1, 0/1. Okay, fine. Now next is that -7.268 and something. Okay, something I don't know, but this will be approximately that much. And 32.482 and 1.18720. Okay, fine. Now you can see what he had done. You can see as it is. Okay, but I think it's very last time before boundary. Yeah, it's last. -0.74. Yeah, it's larger. Total object sprite square minus -2 है, it's not. Obstacle, border bottom. I'm not able to see the border here. It's okay. Continue it. It's a square spread to act as bottom border. Switch to react to with a bow. So either react to from the tool or you can also press T with it faster. You can handle string or join or join. Resize the position. React tool to stand. You can use all number of them. You can whole bound. So some boundary. Duplicate it. What I can do, select it. It's okay. It's okay. Don't worry about it. It's okay. Border top. Duplicate it and write it border top. Press Ctrl D. 1 minute. Write it name. Okay. Border top. Okay. Now what I can do, I just see the coordinates and go ahead up to 7.56. 7.56. Okay. 7.3. Okay. 7.3. Now you can see the boundary is now at the upper side. 32.482 at 1.1. Border left and again what you can do, make another. Okay, rename it border left. Okay. Minus 15 point 15.692. Okay. Okay. Next 0.08 0.0836. Next then is 15. Now you can see the left side border is there. You can see nice. The border left is there. It's really very accurate, or it can be more accurate by doing this thing. 0.505. 0.505 and y-axis. Now you can see it is more accurate than before, and you can make it to 12.993 is okay. and 15.686. Okay, fine. Now border right, make it a border right. Okay, so it is and then F2 and make it border right, and then what you can do, okay, select the coordinates 15.62, or you can make odd 7 positive. Now it's good, now it's good. Now it's okay. Next, log the aspect ratio and adjust boundary to make sure your game always fits the screen the way you intend. You can set your game view to a fixed aspect ratio. By default, your Unity's game view uses a flexible free aspect mode, which can stretch or crop your game depending on window size. In this step, you will set a fixed 16:9 aspect ratio, which is common screen format used on phones and monitors. You then might need to adjust your screen borders to make sure that align correctly with the new display set. So what you can do, you will select the, instead of free aspect, we will select the 16:9 aspect ratio. Okay, now you can see your mobile like screen 16:9, mobile monitor like screen. Fine, no? Fine. Okay, you can adjust it according to it, because 16:9 is not adjustable. So what I done, look it carefully what I have done. 1 second. Minus 13.3, the border left, minus what's again, minus 13.3. Okay, now it's here. What is again? Okay, 13.3 again. Okay, on this also you have to adjust. Okay, I'm adjusting this also. What the top 0.0356. Okay, top side. Seven point three zero 27.560. Now it's okay. 1 point is okay. Same for this, but only coordinates are different. Okay. You can do what? You can do Control D and make it just minus. Just thing you have to do. Now it's fine. This is a third life. Okay. So you can see the whole screen now. Oh brother. It's bottom, border bottom. Okay, now it's over. Tell me next what to do. So you can mark step as complete. Okay. Now organize the hierarchy window and assets folder. As your project grows, good organization will save time and reduce confusion. So in this step, you will grow braided game object inside an empty parent game object and tied up your project window by moving assets into folders. Okay. So what you will do? Create empty game object name as border. So step by step, first I will do create a empty game object and name it to borders. And then select button to right and just make them child of the borders parent. Okay, now fine. Now you can see borders is the main parent and all these are childs. So next, default volume and universal, I'll put them in setting. Okay, what I will do, just close this once again. Default volume and universal render pipeline I put into setting, not here. Control Z, put into setting, put into setting. Okay. This also put into setting. Okay, fine. Group the borders in empty. Okay. Mark step as complete. Okay. Now optional. More things to try. Try these optional activities to challenge yourself, build your skills, and improve your project. Each challenge is tagged as easy, medium, or expert difficulty so that you can know what to expect. You can complete one, all, or none of them. It's totally up to you. If you are not interested in doing this challenge, mark this step as complete and proceed to the next tutorial. Save a custom layout. 2D game layout. So where is the 2D game layout? Okay, it's 2D game layout. Fine. Okay, if you have arranged your Unity in a way that you can save the layout of future use in your project. नहीं होगा ठीक है I think some issues there. What I will do, I will just okay fine. Finally, I'm out of that thing. Sit anywhere else, okay? Sit here. So finally, I'm here. Closing the prices, okay. So if you arrange your Unity windows in a way you like, you can save the layout for future use. In the upper right corner of the editor, open the layout drop down. Okay. Okay. You can save this. Save layout. Okay, you can save this layout. And suppose I want a name to be game layout. Here. Okay. In the upper right corner of the editor, open the layout. Open the layout. Save layout. 2D game layout. Medium. Change the colors of your obstacle and borders. Make your game feel more unique by customizing the color of your game object. In hierarchy window, select the obstacle. You can select the obstacle here. Or any other one of the border game object. In the inspector window, locate the sprite render component. Select the color swatch and select a new color in the. Okay, you can select a new color. Suppose I'm in blue city, so I will color. Okay, this is blue color. Now you can see the blue color. So fine. Repeat for each game object you want to order. So suppose I want for the this one. Obstacle skybox. Where the skybox? Skybox. You can select for skybox also. Suppose I want some different color. Fine, this is good. This is cool. Now you can select the border colors also. Sprite and I know that. You can select all color from here. But I don't think it will matter. Okay, remove this component. You can select all these together and then select color here and here. Okay, fine. So this is the color. If your camera background still uses the default color, try additional tools. Okay, fine. This is over now. The next step is that you have built the foundation of your 2D game world by adding in obstacles, setting up camera, adding screen boundaries, and organizing your color. In the next tutorial, you will bring out your first obstacle to life by adding physics and colliders and turning it into flying fish. Yeah, this is good. So 10 XP for today. Engaging. Clear instructions. Continue to next. Okay, fine. In this tutorial, you will add physics to your obstacle so it falls, bounces, and interacts with the screen borders. Then you will turn into a prefab and reuse template that lets you quickly create more obstacles later. So the overview is that in this tutorial you will add physics to your obstacle so it falls, bounces, and interacts with screen borders. Then you will turn into a prefab and a reusable template that lets you quickly create more obstacles later. Okay, fine. So you can see here how they are bouncing and nice. So Marks, this step is complete. I understood what we are going to do in here. So add a rigid body 2D component. Right now your obstacle just sits in a place. There's no way that you are bouncing or making some movement. So to make it respond to gravity, physics forces, you will add the rigid body 2D component. So what I will do, to this tell Unity to treat the game object as physical body, so it can fall, bounce and interact with other game object. Unity, it's important to test changes often in play mode, where you test your game's current functionality, but be sure to exit play mode before making edits. Change made during play mode won't be safe. Okay, 1 second. It's 4 p.m. 58% battery is there. Fine. So what I will do, I will drink water first. Okay. For this step I will do. Go to obstacle, then add a rigid body component 2D. Okay, do the simple step. Rigid body. 1 second. What is happening? You can do one thing. What you can do? Just okay here. Now it's falling. Okay, play it. Okay, now it's falling. Save it first and then try to. Okay, where is the mouse? I don't know where the mouse is. Okay, fine. Save it and then run it. Now you can see. Now in the game environment you see what happening there, and here you can also see. It's take time, but it will work. Okay, you have to wait. Thing is that, and parallelly you can do what one more thing. So it's falling. Okay, see, with gravity it's falling down. But thing is that we don't want to fall that much till border. We have to fall. We have to fall that obstacle. Enter play mode to see what happens when without physics. Select the play button at the top of the Unity editor. Notice that obstacle game object does not move. It just floats in space. Press stop to exit. Okay, stop it. Important, Unity does not have save changes. Add a rigid body 2D component to the obstacles. Select the obstacle game with its component. Okay, at the bottom. Okay, fine. It is done. This done. Okay, this done. Okay, fine. Okay, I will mark it complete because we have a no collider component. Because of that is falling downward forever and forever. Because there is no collider there. No. We will add collider component now. Okay, with having some break. Okay, water break. Hello friends, so continuing it, now adding collider components. Now that my obstacle has physical body, it's have a rigid body 2D. So you can see here the obstacle. Okay, so but still falls through the screen border because nothing is stopping it. So fix this, you will add collider component which define the steps that game object used to detect and respond to collision in Unity. So I will use a polygon collider 2D for the obstacle since it's an unusual step. So I will use box collider for the border walls. These colliders let the rigid body know where to bounce and stop. Okay, so what I will do, go in these obstacles and add component and then polygon collider 2D. Okay, polygon collider 2D. Okay, fine. Fine. Now what for this? Selecting all together, add component, box collider 2D. Fine. I read for all. Box collider 2D. Next, I will play it. Okay, now you can see. Stop there. But it didn't bounce. It just stopped. So bouncing I will do next. It stopped there. It didn't bounce. So what I can do. So continuing it. So what I will do. I had a collider component to the obstacle. I have already done. Okay. I had a box collider already done. Test the scene. Okay, I already done. So I marked this step as complete. Okay. The obstacle should fall and hit the bottom and then stop, like dropping a bag of sand on the floor. So add a physical material. Right now your obstacle drops and stops, but that's not very funny. In this step you will create 2D physics material and apply it to the obstacle to give it some bounce. This material tells Unity how a given object should react when it hits something, like whether it's sound, whether it's slide, stick or rebound. Was setting bounciness property to its maximum value, you will make the obstacle bounce off the walls with energy, turning it from a dead weight into a hazard. So what I will do, I will first stop it. Okay, stop it and play this video. Select the asset folder. Okay, select the asset folder, then create a new folder, materials. Okay, and create a 2D physics material. Okay, material, and name is materials, but I don't want to create a material. I know. Okay, so I will delete it. 1 second. Create folder. Two days, then physics material 2D. Okay, fine. Now select the one. Okay, bounciness to 1. Okay, now apply this obstacle. Okay, select the obstacle and put this physics here. Physics mat bouncy. And put here. Now play it. Okay. Controllers and then play. Now I think it will bounce. Yeah, it's bounced. 1 second, it will bounce. Then it again bounce. So it will bounce forever and forever. But in real, it doesn't happen. It bounce for some time only. Okay, so I will stop. So I have done this. Test zero gravity. So far gravity has been pulling your obstacle downward, but what happens if there is no gravity at all? In this step, your actual experiment with changing the gravity scale property during play mode to see how it affects. The gravity scale setting in rigid body 2D component controls how strongly gravity affects a game object. Value 1 is normal, Earth-like gravity, and 0 disables gravity entirely. This hands-on test helps you understand how gravity works and sets up behavior we will use in the final game. The obstacle float freely. So you can do what? Just play it and then pause it and then change the gravity. 1 minute, what are you doing? Let me see, what are you doing? Pause it. Pause it and change the gravity scale to 0 and then play it. Okay. Okay, fine. Play the scene, pause while obstacle pass. Select the play button to start the game. Okay, I will select it. Select gravity is 0. The obstacle game is select. Go to rigid body and set the gravity scale properties to 0 and pause again to resume the simulation. Okay, fine. Okay, go to obstacle and then set it to 0. Oh, then select pause and again. Okay, then again pause it and where is the scale? Where is the scale? Okay, select it again and then again do it. Nice. Observe the new behavior. The obstacle now floats and rebounds around the screen with no downfall. Full select stop. Now notice the gravity scale reset to 1. Okay. Okay. You need to reset any changes during play mode. Once you stop, this lets you safely experiment without changing your real project setting. You've now seen how gravity affects physics in Unity and how disabling it creates fun and chaotic motion. Like suppose again you want to see, just select the 0, pause and play it, and you see the chaotic moment. You will use 0 gravity behavior in the fire game. Okay, you can mark step this complete. Now turn the obstacle into a prefab. Now that your obstacle behaves the way you want, it's time to turn it into a prefab. A prefab is a reusable template asset that stores all the components, setting, and hierarchy of a game object. Once you have make a prefab, you can drag out as many copies as you like and update them all at once just by changing the original. This step introduces a major Unity workflow, designing in the scene, saving as prefab, and then reusing the prefab throughout the game. Okay. Now so what I will do for I will stop it. Right click the asset folder. Okay, and create folder. Drag the obstacle game object from the hierarchy window into the new prefab. Okay, you can do what? Select and put it here. Okay, fine. But it's not inside this. I put an obstacle. Now it's fine. Okay, drag the hierarchy window to new prefab. Notice obstacle game object icon in the hierarchy windows turn blue. This means that it's now an instance of the prefab. Okay. Test with few more prefabs from the project, drag few times. Spread the obstacle prefab out and rotate some of them for variety using the rotate tool. Select the play button, watch them bounce around independently. Okay, so now I created all this prefab and just put it in the prefab folder. Okay, marks this step is complete. Now organize the hierarchy window. As As your scene gets more complex, it's important to stay organized. In this step, you will group all of your obstacle game objects under a single empty parent game object called obstacles. Okay, this makes it easier to manage, move, or disable all obstacles at once, and helps keep your hierarchy window clean. Okay, you can see here. If I can make multiple obstacles. Okay, suppose I have made this type of obstacle, or that I move here, one obstacle here, one obstacle here. Okay, so I move every obstacle at different sides. Okay. Okay, you can move anywhere you want. Okay, at obstacles. Okay. Game object, and you can put all these obstacles under obstacles folder. Okay. Obstacles. Okay. In the hierarchy window, use shift select, click control select, control click to select this obstacle, including the original one. Okay, fine. For the borders also you can do the same. Okay. Let's see the same order. Okay. All of your obstacle game objects are now grouped under a single parent game object. Obstacles, making the hierarchy window easier to manage. Okay, fine. Optional, more things to try. Try this thing, these optional activities to challenge yourself, build your skills, and improve your project. Each challenge is tagged as easy, medium, and expert difficulty, so that you know what to expect. You can complete one, all, or none of them. It's totally up to you. If you are interested in doing these challenges, mark this step as completed. Proceed to the next tutorial. Okay. So the first thing is that this is a medium challenge. Edit play mode tint. Okay, what you can do, by default the editor window around the game view becomes slightly darker when you enter play mode. Okay, however this change is subtle and can be hard to notice. If you are unaware that you are in play mode, you might accidentally make changes that won't be saved. To prevent this and avoid losing work, you can adjust the play mode tint. Okay, play mode tint to make it more obvious when play mode is active. Okay, from the main menu, select edit preferences, go and edit, and then select preferences. Where the preferences, this is the preferences. Okay, and then in the leftmost menu, select colors. You can see here colors. Okay, then under general section, where the general section is, this is the general section. This is general section. Change the play mode tint property color to a subtle color instead of gray. Okay, change the subtle color of gray. Color. What color I can select? Color preferences. A subtract is had a soft, muted understand. Never over bright or intense, it creates a calm, sophisticated effect, often uses in design, fashion, and art to convey elegance and tranquility. Characteristic of subtle color, soft muted tones, gentle hues that don't overwhelm the eye. Example: pastels, pale pink, sky blue, this type of color used in different contexts. Example of subtle colors are earth tones, pale pink or sky blue color you can select, or dusty rose or soft. Okay, fine. This color is okay. Now just play. Wow. Wow, it's okay. Now game modes, the color tint has become different. It's become totally different. The simple step you have to do: go and edit. You go in preferences. You go color. Okay, then it will become different. Go edit, and then preferences, and then go colors, and then you can change the play mode tint here, and you can select. Suppose I want to select different color, orange. I want to select. Okay, then I will select orange color, and then save it, and then play the play mode. Okay, now you can see a different color. Fine. Okay, fine. So this I have done. The color should be very noticeable, but still allow you to read the text in the editor. This is the thing you have to keep in mind. Now speed up play mode with editor setting. How can speed up play mode with editor setting? Reducing waiting time and testing your game by changing how Unity reloads upon entering play mode. Okay, what you can do, from the top menu, go to edit. Okay, then project setting. Okay, and then go editor. Where is the editor? Go to editor. Under enter play mode setting. When entering play mode, property go to not reload domain OC. Under enter play mode setting. Play mode setting. Do not reload domain OC. ठीक है, under play mode setting set the when entering play mode property to do not reload domain of scene. Normally Unity resets reloads the entire project every time you select the play button, which takes few seconds. By disabling domain scene reloads, Unity skips that reset so that your game enters play mode almost instantly. It is a huge time saver during early development. Okay, fine. Now I will close it and save it, and then I will run it. Okay, fine. Now see. without any reloadation. It's instantly running. This thing is very good thing that I did. So next step is that you brought your obstacle to life by adding physics colliders and bounce, and then you turn it into a reusable prefab. In that next tutorial, you will start scripting, giving each obstacle a random size, direction, speed, spin to create a more fun and unpredictable game environment that we required. A 3D. Okay. So I'm marking this step as complete. 1 second. What I can do? Put it here. Okay. Mark this step as complete. And now 10 XP for this to a Unity essential. Okay. Now I will engaging instructor. Not engaging. It's clear instructions. Okay. Submitting feedback. Okay. It's gone. Now it's time for moving for random obstacle size, direction, and speed. Before going it, what I can do, continue to next and have a water. Okay, so 45 minutes, 10 XP will be there. And skills, in this tutorial you will write your first Unity script to control how each obstacle behaves. By assigning random properties like size, direction, speed, you will make your program, make your game world feel unpredictable and alive. Along the way, you will learn C# scripting concept, how to edit prefabs directly, and how to test and tune behavior in real time. That's very important. So skills you will gain: scene building essentials, cultivate a code style that is efficient and easy to read, employ basic physics for game objects, manage game object with prefabs, create a game object component with a script. Level 1 application scripting, cultivate a code style that is efficient, easy to read, employ basic physics for game objects, manage game objects with prefabs, create a game object component with a script. Then cultivate a code style that is efficient and easy to read, and employ basic physics for game objects, manage game objects with prefabs, create a game object component with a script. That's very important. Overview. In this tutorial, you will write a simple script that gives each obstacle a random size, direction, and speed. You will learn the basic concepts of basics of Unity scripting, including how to use variables, random number generation, vector math, and more to make your game world feel dynamic and unpredictable. Okay, like you can see here, it's dynamic and unpredictable. Okay, mask step is complete. And not about learning to code. If you have never done any programming before, here something important to keep in mind. Coding can feel confusing at first, and that's completely normal. It might feel like everything is happening in another language. That's because in many ways programming is a new way of thinking. It takes time to get your words used to the words structure and logic behind it. Don't accept to understand everything right way. Instead, think of these tutorials as an introduction to key ideas or planting a seed. The goal is not to memorize or totally understand it immediately. Instead, the goal is to start recognizing patterns that will make more sense to you each time you see them. Just like learning to read or learning controls in a new game, learning to code takes practice and repetition. You are not falling behind, you are just beginning. Okay. Create and attach a new script. So far you have added built-in component to your game object like the rigid body, 2D, collider components, which were created by Unity. This component gave you game objects physics, collision behavior without needing to write any code. Now you are going to create your own component, a custom script that controls how each obstacle behaves when game starts. A script is like a set of instructions you give to game object, then it is how to behave when game runs. The script you are going to create will change size, direction, speed, spin of each obstacle. Scripts in Unity are written in C#, a popular programming language used for games, apps, and more. You will create script, name it, and attach it to your obstacle prefab. So every copy of prefab uses the same behavior. Okay. Now what you will do, create a new script folder in the project window. Right click asset and select create folder and name the folder script. ठीक है. Create folder and name it scripts. Okay, fine. Okay, create a new C# script. Right click the script folder, select create mono behavior script and name the script obstacle. What I will do, I will right click it, create and then mono behavior script and then rename it to obstacle. Okay, so I now open it. Microsoft Visual Studio 2026 is open. Okay, I will log in through GitHub. GitHub is good platform. Okay. Continue. Yes, open. I will choose general theme and dark theme. Yes, Visual C# script. Development setting, Visual C general. Wow. Start Visual Studio. Okay. Let it open. Right click in the script folder and select create for monoscript. Okay, now it's open now. Hello. Okay, fine. Well, what I will do, just close it and okay. I have to update it. Okay, so minimize it. Where is the video? Okay. Mono behavior is the best class that all Unity scripts inherit from. It gives you your script access to Unity built-in feature. Okay, minimize. Like physics, life scale method, don't worry about fully understanding it yet. You will get comfortable with it over time. Unity requires that the script names exactly matches the class name inside it, like Java did. Okay. If the name don't match, you will get an error. If you make mistake on its spelling, read the script and create it again with the correct name. Attach the script to prefab. In the project window, select the obstacle prefab. In the inspector window, select add component and search for and add your newly created obstacle script component. Okay. What I will do. In the project, select obstacle prefab. In project window, not here. Obstacle prefab. Add component and search for script. Okay, I read it. Okay. If you select any of the obstacle game object in the sim, those instance of prefab will be now also have the obstacle script component. Anything you make in the script will automatically apply to all the prefab instances. You have now created your first custom component, one you will fully control with your own code. Okay. Now you can see here, if I select any obstacle, I will have that script inside that obstacle script. Any changes I will make in this prefab will be go to all the prefab. This is very good. Okay, fine. Under the script structure, before start writing code, it's helpful to understand the structure of a basic Unity script When you double click the script file, Unity will open it into your code editor like Visual Studio or VS Code. Suppose I click this script, okay, double tap it, you can see it is open in VS Code, Visual Studio Code. So the default scripts come with two important methods, start and update, and these are the life cycles methods, and in Unity cast them automatically at specific times during gameplay. If nothing happens or you see an error, you might need to install or set up code editor. Follow you can do. Understand the structure. At the top of the script, you will see the using statement. These tells the using statement will be the using Unity engine. That's all. So these tell the script what code libraries the script can reference. Below that, you will see a class definition that matches your script's name, the public class obstacle, mono behavior. Start runs once when the game logic is first created in the scene. Update runs once per frame, that used to check things like input or movement. Your script might look a bit different depending on your version or Unity or which IDE you are using, then that's okay. You don't need to fully understand what each part of the code does yet. For now, just focus on recognizing the basic structure. You will add your own code inside these methods soon. Okay. Change the size using fixed value. Just write your first line of code. You will use the start method to change the scale of the obstacle when the game begins. Okay, you will set the obstacle size using a piece of data called vector3, which holds three values x, y, z. You will set the scale by accessing the game objects transform component, and the component Unity uses to store an object's position, rotation, and scale. In your code, setting the transform.local scale affects how small, big or small the object appears in the scene. Rather than copying and pasting the code below, trying it out yourself. As you type, you might notice that your code editor suggests autocomplete options, including method names, definitions, and parameters. This is a feature of most modern editors like Visual Studio Code, VS Code, and it makes coding faster and less error prone. If you don't see suggestions as you type, you are using a macOS, you might need to configure your editor to proper support Unity and Caesar. Once it's working, autocomplete will save you a lot of time. I done already. So what I will do, write this script here.
Hello friends, so now going to start very important book, this machine learning, hands-on machine learning. Now I'm continuing where I stopped earlier. You can watch the earlier video of this book in my previous videos that I uploaded on YouTube. Okay, now going to start this. So starting from the multi-class classification. Okay, reading it. Okay, starting the 25-minute timer. So already started now. Now starting.
Multiclass classification. Whereas binary classifiers distinguish between two classes, multiclass classifiers can distinguish between more than two classes. Some Scikit-Learn classifiers are capable of handling multiple classes natively, others are strictly binary classifiers. However, there are various strategies that you can use to perform multiclass classification with multiple binary classifiers. One way to create a system that can classify the digit images into 10 classes is to train 10 binary classifiers, one for each digit. Then when you want to classify an image, you get the decision score from each classifier for that image, and you select the class whose classifier outputs the highest score. This is called the one versus the rest strategy, or sometimes one versus all. Another strategy is to train a binary classifier for every pair of digits, one to distinguish 0 seconds and 1 second, another to distinguish 0 seconds and 2 seconds, another for 1 second and 2 seconds, and so on. This is called the one versus one strategy. If there are n classes, you need to train n times 2 classifiers. For the MNIST problem, this means training 45 binary classifiers. When you want to classify an image, you have to run the image through all 45 classifiers and see which class wins the most duels.
This is very important. Like there is another strategy for binary classifier that for every pair of digits, one to distinguish 0 and 1s, another to distinguish 0 and 2s, and another for 1 and 2s, and so on. This is called 1 versus 1, OVO strategy. 1 versus 1 strategy. And if there are n classes, you need to train n cross n minus 1 divided by 2 classifiers. Okay. For the data set that we have, MNIST data set. So this means the training 45 binary classifier. When you want to classify an image, you have to run image through all 45 classifiers and see which class wins the most joules. The main advantage of OVO is that each classifier only needs to be trained on the part of the training set, obtaining the two classes that it must distinguish. You can see here.
The main advantage of OVO is that each classifier only needs to be trained on the part of the training set containing the two classes that it must distinguish. Some algorithms scale poorly with the size of the training set.
Here it is. Here's the some algorithm that some examples such as support vector machine classifier. To scale poorly with size of training set. The training set is perform very poorly. The support vector machine. For these algorithms, 1 versus 1 is preferred because it is faster to train. Okay.
Algorithms OVO is preferred because it is faster to train many classifiers on small training sets than to train few classifiers on large training sets. For most binary
so this is important. This line is important. So we prefer OVO because it's faster to train many classifiers on a small training set than to train few classifiers on large training set. So this is very important. To train many classifiers in one small training set, we use OVO. And then to train few classifiers on large training set. For most binary classification algorithm, however, OVR is preferred. Classification algorithm we prefer OVR. And for support vector some algorithm like support vector machine classifiers, we use OVO.
Algorithms, however, OVR is preferred. Scikit-Learn detects when you try to use a binary classification algorithm for a multi-class classification task, and it automatically runs OVR or OVO, depending on the algorithm.
Yeah.
Let's try this with a support vector machine classifier using the Scikit-Learn.svm.
So for SVM, it will run OVO. Okay.
C class will only train on the first 2,000 images, or else it will take a very long time. From Scikit-Learn.svm import SVC. SVM CLF.
Okay, let me see the code now. It's time to see the code. What I can do, just make it small. Now make a new window and just open the book. Which book is name? The book name is Hands-on. Okay. And this is opening. Just make it slightly like this. Okay. Zoom out. Now I think you can see. Okay, you can see now. It's perfect. So here you can see the code. I'm just opening the code now. The same code I will display here in the left side, and in the right side I will read the book. Okay, you understood? Okay, fine. Opening this chapter number 2, end-to-end machine learning project. Okay, it's opening now. Google Colab is opening now. It's loading. Okay, you can see here. This is the code. I will search it out where it is now. SVC, Control F, SVM, CLF. Understood, no? Yeah. I think this code is totally what is right for you. Or write something like Okay, 2000 to range from 2000 20,000. I think this will not count. You can do what you can do. Just copy this and search it out. Search as the whole code. You will definitely find out it out. After fine. Okay, fine. You're not finding out what I want. There is some issue, and I think I can't resolve. Okay, this is solution. Multiclass classifier, right? Multi-class. Chapter number 2 or chapter number 3? Chapter number 3 now. Okay. Open the chapter number 3. You understood? I'm searching chapter number. Now you can see. I was searching in the wrong chapter. Otherwise, I thought another will find. That's okay. Multi-class classification, you can see here.
To SVC, SVM, CLF.fit, ytrain, #ytrain, not ytrain5. That was easy. We trained the SVC using the original target classes from 0 to 9 instead of the 5 versus the rest target classes. Since there are 10 classes, Scikit-Learn used the OVO strategy and trained 45 binary classifiers. Now let's make a prediction on an image. AE, SVM, CLF.predict. Array, dtype equal to object. That's correct. This code actually made 45 predictions, one per pair of classes, and it selected the class that won the most duels. If you call the decision function, method, you will see that it returns 10 scores per instance, one per class. Each class gets a score equal to the number of 1 duels, plus or minus a small tweak to break ties, based on the classifier scores. DA some digit scores equal to SVM CLF.decision function. DE some digit scores.round. Array 3.79, 0.73, 6.06, 8.3, 0.29, 9.3.
The same output you can see here.
0.77 point score, and it's indeed the one corresponding to class 5. TA class ID equal to some digit scores.argmax. DA class ID 5. When a classifier is trained, it stores the list of target classes in its class C attribute, ordered by value. In the case of MNIST, the index of each class in the class C array conveniently matches the class itself, but in general, you won't be so lucky. You will need to look up the class label, like this. At ESVM CLF.classC, array dtype equal to object, at VM CLF.classC. 5 feet. If you want to force Scikit-Learn to use 1 versus 1 or 1 versus the rest, you can use the 1 versus 1 classifier or 1 versus rest classifier classes. Simply create an instance and pass a classifier to its constructor. For example, this code creates a multi-class classifier using the OVR strategy based on an SVC. From scikit-learn.multiclass, import 1 versus rest classifier. OVR CLF equal to 1 vs rest classifier. OVR CLF.fit. Ytrain. Let's make a prediction and check the number of trained classifiers. GA OVR CLF.predict. Array dtype equal to RU1. Thalen 10. Training an SGD classifier on a multi-class dataset and using it to make predictions is just as easy. DESGDCLF equal to SGD classifier, AESGDCLF.fit, exotrain, ytrain, AESGDCLF.predict, array dtype equal to IU1. Oops, that's incorrect. Prediction errors do happen. This time Scikit-Learn used the OVR strategy under the hood. Since there are 10 classes, it trained 10 binary classifiers. The decision function method now returns one value per class. Let's look at the scores that the SGD classifier assigned to each class. DESGDCLF, decision function, .round. Array, 31,893. Array, 893. Minus 34,893. 1824. Minus 26,000. Minus 26,186. Not very confident about its prediction. Almost all scores are very negative, while Class 3 has a score of plus 1,824, and Class 5 is 138 at 1,386. Of course, 3, why evaluate this classifier on more than one image? Since there are roughly the same number of images in each class, the accuracy metric is fine. As usual, you can use the cross-val score function to evaluate the model, DE cross-val score array. It gets over 85.8% on all test folds. If you used a random classifier, you would get 10% accuracy, so this is not such a bad score, but you can still do much better. Simply scaling the inputs increases accuracy above 89.1%. E from Scikit-Learn.preprocessing import standard scalar, beat scalar equal to standard scalar, xy train scaled equal to scalar.fit transform, DE cross score array. Error analysis. If this were a real project, you would now follow the steps in your machine learning project checklist. You'd explore data preparation options, try out multiple models, shortlist the best ones, fine-tune their hyperparameters using grid search CV, and automate as much as possible. Here, we will assume that you have found a promising model and you want to find ways to improve it. One way to do this is to analyze the types of errors it makes. First, the confusion matrix. For this, you first need to make predictions using the cross-val predict function, then you can pass the labels and predictions to the confusion matrix function, just like you did earlier. However, since there are now 10 classes instead of 2, the confusion matrix will contain quite a lot of numbers, and it may be hard to read. A colored diagram of the confusion matrix is much easier to analyze. To plot such a diagram, use the confusion
So here you can see the color diagram of the confusion matrix. You can see here, it's much easier to analyze. To plot such a diagram using the confusion matrix display form prediction function like this.
Display on predictions function like this. From Scikit-Learn.metrics import confusion matrix display. Ytrain pred equal to cross-val predict confusion matrix display. From predictions ytrain pred plt.show. This produces the left diagram in figure 3-9. This confusion matrix looks pretty good. Most images are on the main diagonal, which means that they were classified correctly. Notice that the cell on the diagonal in row DO5 and column 5 looks slightly darker than the other digits. This could be because the model made more errors on 5 seconds, or because there are fewer 5 seconds in the dataset than the other digits. That's why it's important to normalize the confusion matrix by dividing each value by the total number of images in the corresponding class. This can be done simply by setting normalize equal to true. We can also specify the val UEC argument to show percentages with no decimals. The following code produces the diagram on the right in figure 3-9. Confusion matrix display from predictions ytrain pred normalize equal to true values at plt.show. Now we can easily see that only 82% of the images of 5 seconds were classified correctly. The most common error the model made with images of 5 seconds was to misclassify them as 8 seconds. This happened for 10% of all 5 seconds, but only 2% of 8 seconds got misclassified as 5 seconds. Confusion matrices are generally not symmetrical. If you look carefully, you will notice that many digits have been misclassified as 8 seconds, but this is not immediately obvious from this diagram. If you want to make the errors stand out more, you can try putting 0 weight on the correct predictions. The following code does just that and produces the diagram on the left in figure 3-10, sample weight equal to confusion matrix display from predictions ytrain pred sample weight equal to sample weight normalize equal to true values at plt.show. Figure 3-9, confusion matrix and the same CM normalized by row. Figure 3-10, confusion matrix with errors only normalized by row and by column. Now you can see much more clearly the kinds of errors the classifier makes. The column for class 8 is now really bright, which confirms that many images got misclassified as 8 seconds. In fact, this is the most common misclassification for almost all classes. But be careful how you interpret the percentages in this diagram. Remember that we've excluded the correct predictions. For example, the 36% in row 7th, column 9th does not mean that 36% of all images of 7 seconds were misclassified as 9 seconds. It means that 36% of the errors the model made on images of 7 seconds were misclassifications as 9 seconds. In reality, only 3% of images of 7 seconds were misclassified as 9 seconds, as you can see in the diagram on the right in figure 3-9. It is also possible to normalize the confusion matrix by column rather than by row. If you set normal is equal to pred, you get the diagram on the right in figure 3-10. For example, you can see that 56% of misclassified 7 seconds are actually 9 seconds. Analyzing the confusion matrix often gives you insights into ways to improve your classifier. Looking at these plots, it seems that your efforts should be spent on reducing the false 8s. For example, you could try to gather more training data for digits that look like 8 seconds so that the classifier can learn to distinguish them from real 8s. Or you could engineer new features that would help the classifier. For example, writing an algorithm to count the number of closed loops. Or you could pre-process the images to make some patterns, such as closed loops, stand out more. Analyzing individual errors can also be a good way to gain insights into what your classifier is doing and why it is failing. For example, let's plot examples of 3 seconds and 5 seconds in a confusion matrix style. CLA, CLB, equal to 3 feet, 5 feet, XLAAA, equal to XLTrain XAB, equal to XLTrain XOEB, equal to XLTrain XTABB, equal to XLTrain. Hashtag plot all images in XOAA, XUAB, XOAPA, XLALBB, in a confusion matrix style. Figure 3-11. Some images of 3 seconds and 5 seconds organized like a confusion matrix. As you can see, some of the digits that the classifier gets wrong are so badly written that even a human would have trouble classifying them.
Yeah.
However, most misclassified images seem like obvious errors to us. It may be hard to understand why the classifier made the mistakes it did, but remember that the human brain is a fantastic pattern recognition system, and our visual system does a lot of complex pre-processing before any information even reaches our consciousness. So, the fact that this task feels simple does not mean that it is. Recall that we used a simple SGD classifier, which is just a linear model. All it does is assign a weight per class to each pixel, and when it sees a new image, it just sums up the weighted pixel intensities to get a score for each class. Since 3 seconds and 5 seconds differ by only a few pixels, this model will easily confuse them. The main difference between 3 seconds and 5 seconds is the position of the small line that joins the top line to the bottom arc. If you draw a 3 with the junction slightly shifted to the left, the classifier might classify it as a 5 and vice versa. In other words, this classifier is quite sensitive to image shifting and rotation. One way to reduce the 3/5 confusion is to pre-process the images to ensure that they are well-centered and not too rotated. However, this may not be easy since it requires predicting the correct rotation of each image. A much simpler approach consists of augmenting the training set with slightly shifted and rotated variants of the training images. This will force the model to learn to be more tolerant to such variations. This is called data augmentation. Multilabel classification. Until now, each instance has always been assigned to just one class. But in some cases, you may want your classifier to output multiple classes for each instance. Consider a face recognition classifier. What should it do if it recognizes several people in the same picture? It should attach one tag per person it recognizes. Say the classifier has been trained to recognize 3 faces, Alice, Bob, and Charlie. Then when the classifier is shown a picture of Alice and Charlie, it should output. Such a classification system that outputs multiple binary tags is called a multilabel classification system.
Yeah.
We won't go into face recognition just yet, but let's look at a simpler example, just for illustration purposes. Import numpy as np from Scikit-Learn.neighbors import neighbors classifier. ytrain large equal to ytrain odd equal to %2 equal to 1, y multilabel equal to np.chschi, ytrain large, ytrain odd. knnCLF equal to neighbors classifier, knnCLF.fit, xtrain, y multilabel. This code creates a y multilabel array containing 2 target labels for each digit image. The first indicates whether or not the digit is large, and the second indicates whether or not it is odd. Then the code creates a neighbors classifier instance, which supports multilabel classification, and trains this model using the multiple targets array. Now you can make a prediction and notice that it outputs 2 labels, knCLF.predict, array, and it gets it right. The digit 5 is indeed not large and odd. There are many ways to evaluate a multilabel classifier, and selecting the right metric really depends on your project. One approach is to measure the F1 score for each individual label, then simply compute the average score. The following code computes the average F1 score across all labels. TAY-train KNN pred equal to cross VL predict, TUF. 0.9764106 Theo cell. This approach is C's. This approach is a valley. You may want to give more weight to the classifier's score on pictures of Alice. One simple option is to give each label a weight equal to its support. To do this, simply set average equal to weighted when calling the F function. If you wish to use a classifier that does not natively support multilabel classification, such as SVC, one possible strategy is to train one model per label.
Yeah.
However, this strategy may have a hard time capturing the dependencies between the labels. For example, a large digit is twice more likely to be odd than even, but the classifier for the odd label does not know what the classifier for the large label predicted. To solve this issue, the models can be organized in a chain. When a model makes a prediction, it uses the input features plus all the predictions of the models that come before it in the chain. The good news is that Scikit-Learn has a class called Chain Classifier that does just that. By default, it will use the true labels for training, feeding each model the appropriate labels depending on their position in the chain. But if you set the CV, Scikit-Learn offers a few other averaging options and multi-label classifier metrics. See the documentation for more details. Hyperparameter, it will use cross-validation to get clean predictions from each trained model for every instance in the training set, and these predictions will then be used to train all the models later in the chain. Here's an example showing how to create and train a chain classifier using the cross-validation strategy. As earlier, we'll just use the first 2,000 images in the training set to speed things up. From Scikit-Learn.multi-output import classifier chain. Chain CLF equal to classifier chain, CV equal TO3, random state equal 242, chain CLF.fit, Y multilabel. Now we can use this chain classifier to make predictions. TA chain CLF.predict. Array, multi-output classification. The last type of classification task we'll discuss here is called multi-output multiclass classification. It is a generalization of multilabel classification where each label can be multiclass. To illustrate this, let's build a system that removes noise from images. It will take as input a noisy digit image, and it will output a clean digit image, represented as an array of pixel intensities, just like the MNIST images. Notice that the classifier's output is multilabel, and each label can have multiple values. This is thus an example of a multi-output classification system. The line between classification and regression is sometimes blurry, such as in this example. Arguably, predicting pixel intensity is more akin to regression than to classification. Moreover, multi-output systems are not limited to classification tasks. You could even have a system that outputs multiple labels per instance, including both class labels and value labels. Let's start by creating the training and test sets by taking the MNIST images and adding noise to their pixel intensities with numpyWise_randint function. The target images will be the original images, np.random.seed, hashtag to make this code example reproducible. Noise equal to np.random_randint 0, 100, 784, exotrain emod equal to exotrain plus noise equal to np.random.randint 0, 100, 784, xtest mod equal to xtest plus noise, ytrain mod equal to xotrain, ytest mod equal to xtest. Let's take a peek at the first image from the test set. Yes, we're snooping on the test data, so you should be frowning right now. Figure 3-12. A noisy image, and the target clean image on the left is the noisy input image, and on the right is the clean target image. Now let's train the classifier and make it clean up this image. KNN-CLF equal to neighbors classifier, KNN-CLF.fit, exotrain mod d, ytrain mod, clean digit equal to KNN-CLF.predict, plot digit plt.show, figure 3-13. The cleaned up image looks close enough to the target. This concludes our tour of classification. You now know how to select good metrics for classification tasks, pick the appropriate precision recall trade-off, compare classifiers, and more generally build good classification systems for a variety of tasks. In the next chapters, you'll learn how all these machine learning models you've been using actually work. Exercises. 1. Try to build a classifier for the MNIST dataset that achieves over 97% accuracy. On the test set, hint, the neighbors classifier works quite well for this task. You just need to find good hyperparameter values. 2. Write a function that can shift an MNIST image in any direction, left.
Oh, that's good. We have done this. Yeah. Just now we see command store extra like this. Extra right hand now. Okay, fine. Okay, it's time up. So I will do the exercise by myself, and I will try it out by myself, and then I will see the solution also. You can see the whole code is given. Solution is for each question of text value is given here, and so setting out how it is done. So it's time to summarize this lesson. Okay. That's good. Okay. Summarizing this lesson now. This summary. Select chapters. Chapter number 2. Okay. Now exercise. Okay, continue. Deep dive, bullet points, and take summary.
End-to-end machine learning projects. 1. The machine learning project lifecycle. Project scope and definition. Every machine learning project begins with a clear business objective. In the fictitious scenario of the Machine Learning Housing Corporation, the goal is to predict median housing prices based on census data. This objective determines the problem framing, in this case, a multiple regression task using supervised batch learning, and the selection of performance metrics such as RMSE or MAE to evaluate model accuracy. Data acquisition and initial exploration, using real-world data, like the StatLib California housing prices dataset, is essential for skill acquisition.
One minute. I think the summary is even for chapter number 2, not 3. Again, I'm going to summarize it with that 12 points and select chapters. Chapter number 3. This is chapter number 3, not chapter number 2. This 3. Classification, yeah. Continue. Now create summary. That's why I think how such a fast summary is made. Because takes time. You can see the time. I don't know.
Introduction to classification. Definition of classification. Unlike regression, which predicts continuous values, classification tasks involve predicting discrete class labels. This chapter utilizes the MNIST dataset, a collection of 70,000 handwritten digits, often regarded as the hello world of machine learning for benchmarking algorithms. Dataset management. Scikit-Learn provides fetch OpenML to download datasets. For image data like MNIST, setting as from equal to false is essential to retrieve the data as NumPy arrays rather than pandas data frames. Each image consists of 784 features, corresponding to the pixel intensities of a 28 times grid. Data preparation. It is critical to set aside a test set before analysis. The MNIST dataset is pre-split into 60,000 training images and 10,000 test images. Shuffling the training set is a best practice to ensure cross-validation folds are representative and to prevent bias in algorithms sensitive to the order of input data. 2. Training a binary classifier. Binary classification task. The chapter introduces a 5 detector as a binary classifier, which categorizes instances as either 5 or non-5. Model selection. The SGD classifier is chosen for its efficiency, particularly for large data sets, as it handles training instances independently. This makes it suitable for online learning scenarios. Performance evaluation, cross-validation accuracy. While high accuracy is common, it can be deceptive, especially in skewed datasets where the majority class dominates. A dummy classifier that simply predicts the most frequent class can yield misleadingly high accuracy, highlighting the need for more nuanced metrics. Confusion matrix, a more informative tool. The confusion matrix counts the occurrences of true positives, true negatives, false positives, and false negatives, allowing for a detailed breakdown of classification errors. Precision and recall. Precision measures the accuracy of positive predictions, whereas recall measures the model's ability to identify all positive instances. These metrics are linked by the precision recall trade-off. Increasing the decision threshold improves precision but typically degrades recall. F1 score. As the harmonic mean of precision and recall, the F1 score provides a single metric that rewards balanced models, penalizing those that sacrifice one metric for the other. ROC curve. The receiver operating characteristic curve plots the true positive rate against the false positive rate. The area under the ROC curve serves as a robust metric for comparing model performance, where a score of 0.5 represents a random classifier and 1 indicates perfection. 3. Multiclass classification strategies. Native support. While some algorithms handle multiclass tasks natively, others, like the support vector machine, are inherently binary. Classification tactics, one versus the rest, involves training one binary classifier per class, selecting the class with the highest decision score. This is generally preferred for most binary algorithms. 1 versus 1 involves training a binary classifier for every unique pair of classes. This strategy is more efficient for algorithms that scale poorly with dataset size, such as SVM, as each individual model is trained on a smaller subset of data. 4. Error analysis and model improvement. Visualizing errors, right, up. Analyzing a normalized confusion matrix allows developers to identify specific patterns. Classification tactics, one versus the rest, involves training one binary classifier per class, selecting the class with the highest decision score. This is generally preferred for most binary algorithms. 1 versus 1 involves training a binary classifier for every unique pair of classes. This strategy is more efficient for algorithms that scale poorly with dataset size, such as SVMs, as each individual model is trained on a smaller subset of data. 4. Error analysis and model improvement. Visualizing errors, analyzing a normalized confusion matrix allows developers to identify specific patterns of misclassification, such as the frequent confusion between the digits 5 and 8. Refinement techniques. To reduce common errors, practitioners can collect more representative training data, engineer new features, or apply data augmentation to improve robustness against variations like rotation and shifting. 5. Multilabel and multi-output classification. Multilabel classification, this system allows an instance to be tagged with multiple binary labels simultaneously. Evaluation is performed by averaging metrics like the F1 score across all labels. Advanced techniques, such as the classifier chain, can be used to model dependencies between different labels. Multi-output classification, this is a generalization where each output label is multi-class. An example provided is an image denoising system, where the classifier predicts the correct intensity for every individual pixel in a noisy image. This bridges the gap between classification and regression, as the model essentially predicts continuous pixel values via classification-like structure. Summary conclusion. This overview of Chapter 3 emphasizes that effective classification requires a shift beyond simple accuracy. By mastering performance metrics such as precision, recall, and the F1 score, and understanding how to navigate the precision-recall trade-off, practitioners can build reliable systems. Furthermore, the ability to extend these concepts to multi-class, multi-label, and multi-output scenarios, combined with rigorous error analysis and data augmentation, provides a comprehensive framework for tackling diverse machine learning challenges in real-world applications.
So somebody is now over. Now it's time for podcast.
Repeat. As it is. Repeat.
Okay, I'm creating it. And I will start. Starting the screen now. Starting the podcast now. You can see me. Okay. Well, finally.
70,000 small images of handwritten digits. Sounds mundane, yet this MNIST dataset is often called the hello world of machine learning, a benchmark for new classification algorithms. But classifying these digits is trickier than it seems, especially when we talk about measuring performance. How do we move beyond simple accuracy to truly understand if our model is doing a good job, Eloise?
That's a fantastic starting point, Thomas. The MINST dataset is iconic. It's a collection of 28 by 28 pixel grayscale images, each labeled with the digit it represents. For machine learning, these images are typically flattened into 784 feature vectors. And you're right, simply aiming for high accuracy can be misleading, particularly in classification tasks.
Right. We're not just predicting a value like a house price. We're putting things into categories. Let's start simple, as the book does. Imagine we only want to identify the digit 5. This creates a binary classifier, a 5 detector. How does a basic classifier like Scikit-Learn's SGD classifier perform on this? And what does its accuracy really tell us?
For a 5 detector, we'd train it to distinguish 5s from non-5s. An SGD classifier can achieve surprisingly high accuracy, sometimes over 95%. But that figure can be deceptive. If only about 10% of the images are 5s, a classifier that always guesses not a 5 would still be correct 90% of the time. This highlights why accuracy alone isn't suitable for skewed datasets where some classes are far more frequent than others.
So, a model that does almost nothing can look good on paper. That's a critical nuance. What then is a more informative way to evaluate a classifier's performance, especially when dealing with such imbalanced classes?
That's where the confusion matrix comes in. It helps us understand exactly where our classifier is succeeding and failing. It's a table where each row represents the actual class and each column represents the predicted class. For our 5 detector, it tells us how many non-5s were correctly classified as non-5s, how many non-5s were wrongly classified. It's a table that helps us understand exactly where our classifier is succeeding and failing. It's a table where each row represents the actual class and each column represents the predicted class. For our 5 detector, it tells us how many non-5s were correctly classified as non-5s, how many non-5s were wrongly classified as 5s, these are our false positives, and similarly for actual 5s, how many were correctly identified and how many were missed, our false negatives.
So, true positives, false positives, true negatives, false negatives. This sounds much more detailed. From this matrix, we can then derive metrics like precision and recall, correct?
Precisely. Precision tells us the accuracy of the positive predictions. If our classifier says an image is a 5, how often is it actually a 5? Recall, on the other hand, tells us the ratio of positive instances that our classifier correctly detected. Out of all the actual 5s in the dataset, how many did our model find? These two metrics often have an inverse relationship, known as the precision-recall trade-off.
That trade-off is fascinating. Can you give us a real-world example where we might prioritize one over the other? Because it sounds like a delicate balancing act.
Absolutely. Imagine a system classifying videos as kid-safe. You'd want extremely high precision, meaning almost no inappropriate videos slip through, even if it means some perfectly good videos are mistakenly rejected. Low recall is acceptable here for the sake of safety. Conversely, for a system detecting shoplifters, high recall is crucial. You want to catch nearly all shoplifters, even if it leads to some false alarms that security guards can quickly verify. The cost of a false positive is lower than missing a real shoplifter.
Those examples make it very clear. So, if we need a single metric to compare classifiers, what do we use when both precision and recall are important?
That's when the F1 score becomes useful. It's the harmonic mean of precision and recall. Because it gives much more weight to lower values, a classifier only gets a high F1 score if both precision and recall are high. It balances them out. However, if you want even more control over the precision-recall balance, you can adjust the classifier's decision threshold.
The decision threshold. So the classifier outputs a score, and we decide where to draw the line between a positive and negative prediction. Raising that threshold increases precision, but lowers recall, and vice versa. How do we choose the optimal threshold?
We can use the precision recall curve function in Scikit-Learn to plot precision and recall for all possible thresholds. This visualizes the trade-off. We can then choose a threshold that meets our specific needs for the application. For instance, we might aim for 90% precision, then find the corresponding recall at that point. If that recall is too low, we might need a better model.
And there's another curve, the ROC curve. How does that fit in with all of this?
The receiver operating characteristic, or ROC curve, is another common tool, very similar to the PR curve. It plots the true positive rate, which is recall, against the false positive rate. The false positive rate is the ratio of negative instances incorrectly classified as positive. A perfect classifier would have a curve that shoots directly to the top left corner. We also use the area under the curve, or AUC, as a single metric. An AUC of 1 is perfect, 0.5 is random. As a rule of thumb, use the PR curve when the positive class is rare or when false positives are more important than false negatives. Otherwise, the ROC curve is generally preferred.
So if our 5 detector seems good on accuracy, but less so on precision and recall, especially compared to a more advanced model like a random forest classifier, it means we have room for improvement. What happens when we need to classify more than 2 classes, say all 10 digits from 0 to 9?
That's multiclass classification, sometimes called multinomial classification. Some algorithms like logistic regression or random forest classifier can handle multiple classes natively. Others, like our SGD classifier or an SVC, are binary classifiers by nature.
Yeah.
For those, Scikit-Learn automatically uses strategies like one versus rest, or OVR, which trains one binary classifier for each class, so a 0 detector, a 1 detector, and so on. Or 1 versus 1, OVO, which trains a binary classifier for every pair of classes. For MNIST, that would be 45 classifiers. The winning class is then chosen by either the highest score from a single classifier or by majority vote from the paired classifiers.
OVR or OVO, depending on the algorithm's strengths. It seems like a lot of work under the hood. Now, when we train a multi-class classifier, say our SGD classifier on the full MNIST dataset, what kind of performance do we typically see, and how do we diagnose where it's making mistakes?
Initially, an SGD classifier might get around 85% accuracy. To really understand the errors, we go back to the confusion matrix. But for 10 classes, it's a 10 by 10 matrix. A simple table of numbers would be hard to read, so we visualize it with a colored diagram. Normalizing the matrix by row, for example, shows us the percentage of instances from each actual class that were misclassified into other classes. This can reveal patterns like how our 5 detector often misclassified 5s as 8s.
Yeah.
Misclassifying 5s as 8s makes intuitive sense visually. So using error analysis with a normalized confusion matrix helps us understand the specific weaknesses of our model. What steps can we take to address these kinds of systematic errors?
There are several. We could try gathering more training data for the confusing digits, like 5s that look like 8s, or we could engineer new features that specifically help distinguish them, perhaps by counting closed loops in a digit. Pre-processing images to ensure they're well-centered and not rotated can also reduce common errors. A powerful technique for this is data augmentation, where we artificially create shifted or rotated copies of existing training images to make the model more robust to such variations.
Data augmentation sounds very useful. Beyond single-class or multi-class problems, the chapter also touches on more complex classification types, like multilabel and multi-output classification. Can you briefly explain these and give examples?
Certainly. Multilabel classification is when an instance can belong to multiple classes simultaneously. For example, a face recognition system might detect multiple people in one picture, so it assigns a true label for each person recognized. Multi-output classification is a generalization where each label can be multi-class, meaning it can have more than 2 possible values. A classic example is image denoising. Input a noisy image, output a clean image. Here, each pixel is a label, and its value can range from 0 to 255. It blurs the line between classification and regression, showing the versatility of these techniques.
That definitely shows the breadth of classification tasks machine learning can handle, from simple digit recognition to complex image processing. The core principles of evaluation and error analysis remain vital. Understanding precision, recall, confusion matrices, and the specific needs of binary, multi-class, multi-label, and multi-output problems are clearly essential for any data scientist.
Indeed, Thomas. These performance measures and analytical tools are what allow us to move beyond superficial accuracy and build truly robust and effective machine learning systems for diverse real-world applications.
If you found this discussion helpful, please consider sharing this episode with a friend or colleague.
Okay. Your friends and colleagues. So, when to end this now? Okay. It's time to do some. Fine. You can see what you can see there. So much is good. You can go here and you can make it quiz. Okay, I can make it quiz. Okay, quiz, press quiz button. New quiz. Selecting questions, number of questions. Quiz 15. So I select 15 questions. 10th of June. Okay. Quiz. Take time slot. It's good. We'll see. But no definition like D&D mod is there. Okay, fine. The quiz is in there. Almost done.
What is the MNIST dataset often called in the machine learning community?
The hello world of machine learning.
Why is it important to set ASO from equal to false when fetching MNIST?
NumPy I use to the data from those data in this sample. Speed up to the data NumPy. To get data.
Why is it beneficial to shuffle the training set in classification?
To ensure first correlation false after done, right order sensitivity.
Which class is used for binary classification using stochastic gradient descent?
SPG or SGD classifier. This is stochastic gradient effect has to be classified.
What is a major limitation of using accuracy as a performance measure?
Another limitation cannot have the what touch my confusion matrix in row 8 and column 0 represent. Number 0 column 0 is 8.
What does a confusion matrix entry in row 8, column 0 represent?
Row 8 and column 0. Column 0. Number of faces in the number of zeros plus
How is precision defined?
this is a precision. T plus false negative. False negative. T plus false negative. This is precision for recall. T false negative.
What is the relationship between precision and recall?
Instead of only using P and CR. What does the
F1 score
F1
represent?
Maybe under the ROC curves, the alternating mean of harmonic mean of precision and recall. What does the
ROC curve plot?
Positive rate against fast positive rate. Accuracy against threshold. Precision against recall. This is PR curve, not ROC curve. Positive rate against fast positive rate.
When is it better to use a precision recall curve instead of an ROC curve?
And positive rate is fast positive. When the positive class is red, you use a precision recall and you care more about fast positive.
What is the 1 versus 1 strategy?
Single model for all classes. Any logical or non-data class. One for each class is out. Each pair of classes. Training classifiers. Training a binary classifier. Very binary for each pair of classes. This is long as long. We are one is rest. Oh, okay, fine. Which function is useful for normalizing a confusion
Which
matrix?
function is useful for normalizing a confusion matrix by row?
By row. Confusion matrix display, from prediction, normalization.
What is multilabel classification?
Predicting multiple categories for single classification problem. Predicting multiple levels for single instance. Using multiple models to predict one outcome, classifying data into binary categories. Predicting multiple categories for a single classification problem. Predicting a single instance.
What is data augmentation?
Increasing number of return benefits. artificial intelligence system. Okay. Some mistake was so 87% are correct. You indirectly are last to one. This one. With multiple considers for each pair of species. Okay. And you can make any quiz also if you want to access more, you can do. Okay. Suppose you want to make 20 pages, you just select the 20, select the pages. If you want the specific pages, if it's chapter, you can select the chapter. Here, suppose I want to again make a quiz of question number 3, I can just make it. Okay. Generate quiz. And the quiz is generated. 20 questions are generating from this. Randomization is a feedback. It takes time, but it's very beneficial if you want to estimate your understanding, how much you understand from the subject, from the not from maybe from subject, not from maybe from your content, whatever content you're consuming, reading, anything. Okay, you can make any type of questions that you want to.
What is the standard directory Scikit-Learn uses for caching downloaded datasets?
Scikit-Learn data, Scikit-Learn, yes. Standard library for caching downloading. Learn data, oh, I get learn data.
Why is the MNIST dataset often called the hello world of machine learning? When loading the MNIST dataset with fetch OpenML, why should you set as from equal to false?
As the data is number.
In the MNIST dataset, how many features does each image have?
74, very not 74.
Why is it important to shuffle the training set before cross-validation? What is the primary characteristic of a binary classifier?
Only two classes, 0 and 1.
Why is accuracy often not a good performance measure for skewed datasets?
Because it's hard to calculate, whether high accuracy can see what's between the both frequencies. Okay.
What does a confusion matrix cell in row 8th, column 0th represent?
8, not the 0. Times it always will be.
How is the F1 score calculated? What is the consequence of raising the decision threshold in a classifier?
Raising a decision threshold in classifier. Decision decreases, recall increases. Decision increases. What decisions are raising that decision? Yeah. Decision increases and recall decreases.
What does a ROC curve plot? What is the ROC AUC score for a perfect classifier? What is the primary advantage of the 1 versus 1 strategy for multiclass classification? What does a normalized confusion matrix show? How can you make errors in a confusion matrix stand out more?
How can you make a lesson of like a single more? By only asserting calculation.
What is a multi-label classification system?
System will output multiple one-check for each instance.
What is data augmentation in the context of image classification? In multi-output classification, what does the system remove from images?
Noise.
What kind of metric is the F1 score weighted by support?
Use more weight to label with more instances. Okay, time is up.
When should you prefer the PR curve over the ROC curve?
False negative more than false positive. PR curve over when the positive class is frequent, when the positive class is rare, okay, then we use PR curve. Yeah. True positive now. When we care about false negative more than false positive. This is a change. Okay. Fine. Okay. 95%. This was incorrect. False negative more than false positive. Okay, that's for today. Now I'm going to practice Unity. Okay. Starting my Unity lesson now. Okay, after a break, time is all over. I will take 5 minutes break, then I will continue it. Okay. Yeah, starting it.
By default, Unity detects mouse position as a vector 3. Now that your script can detect mouse clicks, it's time to figure out where the mouse is clicking. In this step, you'll log the mouse position when clicked. By default, Unity detects mouse position as a vector 3, x, y, and z coordinate, but it does so in screen space, a coordinate system based on pixels where 0, 0 starts.
नहीं इसी में काम चलता है ना एक बार निकालते हैं नहीं तो हाँ उसी से चल रहा तेरा वो कहाँ है मिनी मिनी तो है हाँ वो कहाँ है निकल लेता हूँ
Starts at the lower left corner of the screen. This is different from Unity's world space, where 0, 0 is usually in the center of the scene. You'll learn how to log the screen space position now, and convert it to world space in the following step. 1.
Sending the script now. Mouse की पोजीशन डालना है, ठीक है, इसे ऊपर पे। Okay, fine. It's working.
One times. One. You've logged the mouse position in screen space, but your player game object moves in world space, so you need to convert those coordinates. In this step, you'll use Unity's camera.main.screen-to-world-point function to translate the mouse's position from screen space to a point in the game world. Convert mouse position to world space. This is one of the most
Right? You have to use. You have to convert it to workspace.
important transformations in Unity when dealing with player input. 1. Replace the old mouse position line with a world space version. Inside the F block, wrap your mouse.current.position.value into the following new function. Explanation. Camera.main. Accesses your scene's main camera game object. Screen to world point takes screen coordinates from the mouse and converts them to world coordinates that match your scene layout. 2. Save and enter play mode. Press Ctrl+ macOS CMD+ to save, then return to Unity and enter play mode. Click in the game view and check the console window. When you click the center of the screen, you'll now see values centered closer to 0, 0, which match your scene layout. Note, the result is still a vector 3, and you might notice the Z position might be at an unexpected value. That's okay in 2D, since your game takes place in the XY plane, Z doesn't affect gameplay here. You've now successfully converted input from screen space to world space, which means your player game object can begin responding to mouse position in a meaningful way. Mouse position in a meaningful way. Now that you know the position of the mouse in world space, you can rotate the player to face that position. You'll do that by calculating the direction vector between the player game object's position and the mouse position, then setting the player game object's transform up to that direction. 8. Rotate the player game object to face the mouse. 8. Rotate the player game object to face the mouse. In Unity, transform up controls which way a game object is facing in 2D. It's the local y-axis direction. When you set transform up equal to direction, you're telling Unity to rotate the game object so that its upward axis points toward that direction vector. 1.
Okay. Mouse position minus transform the position. You can do this.
One times. Explanation. This line subtracts two positions, the mouse's position minus the player game object's position. The result is a 2D direction vector, a 2D line pointing from the player game object to the mouse. 2. Set the player game object's facing direction. Add the following line of code underneath the previous one. Explanation. This tells Unity to rotate the player so that its up direction now points along the direction vector. This is an easy way to rotate a game object without using angles or complex math. 3. Save and enter play mode. Press Ctrl+, macOS CMD+ to save, then return to Unity and enter play mode. Click in the game view. The player game object will now visually rotate to point toward the mouse. Now that your player game object rotates to face the mouse, it's time to make it move. In this step, you'll apply force in the direction of the mouse click using Unity's physics system. You've now used vector subtraction and transform opt to align the player's rotation with a direction, a fast and effective way to handle orientation in 2D games. Apply thrust in mouse direction. Apply thrust in mouse direction. Rather than hard coding this.
It's not safe. Now it's working properly. Okay. Okay. Do it. Nowadays, now I think it's now applied thrust. Okay, I have to apply thrust now.
Now that your player game object rotates to face the mouse, it's time to make it move. In this step, you'll apply force in the direction of the mouse click using Unity's physics system. Click in the game view. The player game object will now visually rotate to point toward the mouse. You've now used vector subtraction and transform up to align the player's rotation with a direction, a fast and effective way to handle orientation in 2D games. Apply thrust in mouse direction. Now that your player game object rotates to face the mouse, it's time to make it move. In this step, you'll apply force in the direction of the mouse click using Unity's physics system. Rather than hard-coding the strength, you'll create a public variable so you can adjust the thrust directly in the inspector window later. A good coding habit for tuning gameplay. 1. Add variables at the top of your script. After the first opening curly brace, in your player controller class, add the following lines of code.
Okay, I'm going to edit the public. Here. Now what I can do? I'll start it.
Script. After the first opening curly brace, in your player controller class, add the following lines of code. 2. Get the rigid body 2D component. Inside your start method, add the following line of code to assign the rigid body 2D component.
This here, like I can just write it here in player controller. After here, yeah. Save it, okay? No, not save this one. No.
To the variable. Apply thrust inside the if statement block. After the line that sets transform equal to direction, add the following line of code. Explanation. Direction is the vector pointing toward the mouse. Multiplying by thrust
Okay, it's working. Start now. I save it. Okay, get component and then pick for direction. Just force. Just force is gonna save it. And now you can see when I play, these scripts are compiling now.
Thrust force controls how strongly the force is applied. Normalize the direction variable. 4. Save and enter play mode. Press CTRL plus, MacOS, CMD plus to save, then return to Unity and enter play mode. Click around the screen. The player game object should rotate and move toward the mouse when clicked. Note: you might notice the player game object becomes hard to control and goes too fast. Don't worry, you'll fix that in a future step.
Okay, I'm going to mark it now. This step is complete. Now normalize the direction variable. Okay.
Step. Right now, your player game object speed depends on how far you click from the ship. That's because longer direction vectors apply more force. In this step, you'll fix that by normalizing the direction vector, a technique that keeps the direction the same but limits its length to 1. Click around the screen. The player game object should rotate and move toward the mouse when clicked. Note: you might notice the player game object becomes hard to control and goes too fast. Don't worry, you'll fix that in a future step. 10. Normalize the direction variable. Note: you might notice the player game object becomes hard to control and goes too fast. Don't worry, you'll fix that in a future step. This means your player game object will always move at a consistent speed, no matter where you click. 1. Update the direction line to normalize the vector. Find the following line of code in your if block.
Okay, I'm going to find it. Vector 2 direction mouse position minus star for position. Sound the subtraction calculation in parentheses normalize the value. Okay, I'm going to normalize it. Let's save it. Explanation.
Parenthesis. Normalized is a vector property that resizes the vector to a length of 1, but keeps its direction. This ensures that all clicks apply the same amount of thrust, regardless of distance. 2. Save and enter play mode to test. Press CTRL plus, MacOS, CMD plus to save, then return to Unity and enter play mode. Click near the ship, then far away. Your player game object will now move at the same speed no matter where you click. 3. Adjust thrust if it feels too weak. Select the player game object in the hierarchy window. In the inspector window, look for the thrust force value on your player controller script component. Try increasing or decreasing the value until the controls feel intuitive. Important: changes you make during play mode will not be saved. You can experiment in play mode, then set the value you want after exiting play mode. Handle collisions. Now that your player game object moves around the world, it needs to respond to collisions.
I think we didn't save it. I know it's working. Okay, it's working. It's working. Handle collision, okay.
World, it needs to respond to collisions. In this step, you'll add a method called onCollisionEnter2D, one of Unity's built-in event methods that gets triggered automatically when a collision happens. Inside that method, you'll use destroy GameObject to remove the player game object from the scene when it hits another game object with a collider, either an obstacle or an outer wall, simulating a game over effect.
Yeah.
Add the onCollisionEnter2D method inside your player controller script before the final closing curly brace, outside of start or update. Add the following lines of code.
Okay. So inside this player controller, what I will do, outside start and start order at the following code. Here I can hit.
Happy okay? Huh? तुम्ही सकाळी बोल
खाली
उद्या एक्झाम
हाँ
Following lines of code. Tip: if autocomplete in your code editor is working, try entering on call and selecting on collision enter D from the suggestion list. This ensures you get the spelling and function formatting correct. If your autocomplete isn't working, you can just copy and paste the code above. Explanation: Unity calls this method automatically when a 2D collider hits another 2D collider, but only if one of them has a rigid body component. 2. Save and enter play mode. Press Ctrl+, macOS, CMD+ to save. Then go back to Unity and enter play mode. Click around to move the player game object. When you hit a wall or obstacle, the player game object will be instantly destroyed. B. Clean up your code. Before you move on, it's a good habit to clean up your script. In this step, you'll remove old debug.
oh it's gone away it's working perfectly okay
When you come back to your project later or share your work with others. 1. Remove any debug, log, calls. Find and delete any debug calls. Now that you know everything is working as expected, they're not needed anymore and will clutter the console. 2. Add helpful comments throughout your script. Use 2 forward slashes to add short notes above important lines of code. The following examples are good to include. 3.
okay I'll do it okay okay nice in that direction fine so remove this also it's okay you can have remove it from start it's okay okay fine
3. 14. Optional, more things to try. Try these optional activities to challenge yourself, build your skills, and improve your project. Each challenge is tagged as easy, medium, or expert difficulty so that you know what to expect. You can complete one, all, or none of them. It's totally up to you. If you're not interested in doing these challenges, mark this step as complete and proceed to the next tutorial. Medium, clamp the player game object's max speed. If you hold the mouse for a while, your ship can accelerate.
Okay.
एग्जाम कैसा रहा?
अच्छा.
हाँ?
Okay, starting it. Sorry for disturbing. So I was declaring a variable, public declare the max speed spread variable of f1.
Accelerate endlessly. You can clamp the maximum speed to prevent it from becoming uncontrollable.
Okay.
Run times. In your player-controller.cs, add the following new variable. Then, after add force, in update, add the following. With this code,
Okay, let me add it. What is update? Here's update. Okay. And what is add force? Add force is like after add force. Okay, this add force add this. Okay. After calling this function add force, I have to call this function again. Okay, I have to add this. I can copy and paste here, but thing is that I have to write by myself into my coding step. I'm going to do rather than next. This is correct. This is correct. But instead of velocity, you can write linear velocity. Linear velocity like this. This way. Okay.
the ship can still accelerate, but it won't go faster than your defined top speed, making movement feel tighter and more intentional. Expert. Add a visual booster flame. Add a little visual flare when the ship is accelerating, just like a jet engine firing. You've created a controllable player ship that rotates toward the mouse, applies thrust when clicked, and responds to collisions. In the next tutorial, you'll build a scoring system that tracks how long the player survives and displays that score on screen in real time. Complete this tutorial. 15. Next steps. You've created a controllable player ship that rotates
Okay, fine. Let me do this. Okay. Export. Add a visual booster system. Add a visual use this like this. You can write right click the plane, create a new triangle, sprite in it. I wrote it to Y. Yeah. Maybe it's still right. Oh, fine. This is perfect. Okay. Then give 0.5 minus 0.5. 0.4 0.5. Okay, this is perfect. You give the color 0.4, 3 is 4, 3. And give it color red. Okay, now it's perfect. Now set the script language. You can see the same thing the way that was going here. Again, variable booster or not assign. The assign it. The variable booster is not assigned yet. We can give the game object and assign this booster for it. Okay, now say now this step is complete. Scoring system. It checks how long the rows have displayed score in the stream real time. This is a very good course. A clear instruction on B1. Significant. Now play it, okay? Now the error is removed. It's unfavorable. And save. Yes. Again. Okay. Oh, now it's perfectly working. A little thing is that you can do. Also, this person. So now it will perfectly work. Compiling the script, it will work. We will move to another. Now time is up. Now it's time to do the next lesson. Okay, add a scoring system. Okay, this is I'm going to do. And after this, you can see the content. All right. Wow. Now it's working perfectly. So till 8 the score level. This is what I'm going to do. Not this. Add a scoring system. This tutorial I will do. Then after this, restart the game with a bang. Optional bonus features. Build and publish to web. This thing I will do. Quiz. Then I will do. Planning a game. Then audio, visual effects, user interfaces, animation, Keras and materials, lightning. Iterate on your game. Prepare for certification and publish it. That's the thing I have to complete. Step by step, it will require a lot of time, but I will do. Okay, I try to complete this by today. Okay. Starting from this only. Okay, starting from there. Starting timer again.
Add a scoring system. In many games, scoring helps provide feedback and motivation to players. In this tutorial,
Okay, before starting, I will take some time, take some break of it. Okay, starting this now.
You'll add a basic scoring system to your game that tracks how long the player survives and displays their score on the screen using Unity's UI toolkit system. 1. Overview. In many games, scoring helps provide feedback and motivation to players. In this tutorial, you'll add a basic scoring system to your game that tracks how long the player survives and displays their score on the screen using Unity's UI toolkit system. 2. Track elapsed time. To begin calculating a score, you first need to measure how long the player has been alive. Unity provides a helpful built-in value called time deltatime, which returns the time in seconds since the last frame. By adding this value to a running total each frame, we can track how long the player has survived, regardless of frame rate. In this step, you'll implement this timer inside your player controller script. 1. Declare a variable to store elapsed time. Open your player controller script. Near the top of the class, after your other variable declarations, add the following line of code. Note: writing private is not required. Unity automatically treats variables as private if you don't specify them as private or public. Still, it's a good habit to include private explicitly. This makes your code easier to understand by clearly showing which variables are private and which are public. 2. Increment elapsed time using time deltatime. Inside the update method, add the following line of code at the top. Explanation is a shorthand for add to this variable. Elapsed time plus equal to time deltatime is the same as writing elapsed time equal to elapsed time plus time deltatime. Time deltatime is the time in seconds since the last frame. If you add that small number every frame, it adds up over time. The result is a running total of how much time has passed since the game started. This works no matter what the frame rate is. 3. Log the result in the console window. Below the line you just added, add the following line of code. 4. Test and observe the console window. Save the script, return to Unity, and enter play mode to test. Watch the console window to see the timer increase over time. Let the player game object collide with an obstacle and notice that the log stops. This script is attached to the player game object, so when it gets destroyed, the timer stops because the script is no longer in the scene. Your game now tracks how long the player survives using time deltatime. 3.
Oh, you can see that elapsed time here till the time he survived. That's very cool. That's very, very cool.
3. Add a score multiplier. Now that you're tracking how long the player has survived, it's time to turn that into a score. It wouldn't be very interesting if the score just went up by 1 every second. In this step, you'll create 2 new variables, one to hold the final score and one to define a score multiplier. Then, you'll display that score using debug.log. 1. Declare the score and multiplier variables. In the player controller script, add the following lines of code near your other variables. Note, you might want the score multiplier to be public if you want to adjust it in the inspector window later. 2. Calculate the score and update. Just below where you update elapsed time, add the following line of code. 3. Log the score to the console window. Replace the existing debug.log line with the following. Following line of code. Explanation. This debug.log line will display the score instead of the elapsed time. 4. Test and observe the console. Save the script, return to Unity, and enter play mode to test. Watch the console window to see the score increase over time. Because both values are floats, your result will include decimal points. For example, score 17.32647. Don't worry, you'll round that value to an integer in the next step. 4. Round the score to an int. Right now, the score displays as a long decimal number, which can be hard to read and doesn't feel very game-like. Most games use whole numbers for score displays. In this step, you'll use mathf.floor-to-int, a Unity function that rounds a decimal number down to the nearest whole number. You'll also learn what an int is and why you'd use it instead of a float when displaying clean numbers. 1. Round the score using mathf.floor-to-int. Replace the line where you calculate the score with the following line of code. Explanation. An int is a whole number, like 0, 1, 25. It doesn't store decimal places. Mathf.floor-to-int takes a decimal, float, and returns the largest whole number less than or equal to that value. For example, math.floor-to-int 3.7 degrees Fahrenheit gives 3. This ensures the score only increases after full seconds have passed, which is useful if, for example, you want the player to earn 1 point per second of survival. Without flooring, a score like 3.7 would round up to 4, giving credit before the full second has actually passed. 2. Test and observe the console window. Save the script, return to Unity, and enter play mode to test. Watch the console window to see the score increase over time. The console window should display clean whole numbers like score 47 instead of score 47.39214. 5. Set up a UI document.
Okay, that's very good. That's very good. You can see here. The score is the integer, the floor integer.
Document. Now that the score is being calculated correctly, it's time to display it on the screen. In Unity, you can create user interfaces using the UI toolkit, which uses assets called UI documents written in UXML, a markup language similar to HTML. This step walks you through creating a UI document and connecting it to your scene so you can begin building a heads-up display, HUD, for your score. Create a UI document game object in the scene. Right-click in the hierarchy window and select UI Toolkit, GUI UI Document. Rename the
Now it's okay.
The new game object Game UI. 2. Create a new UI document asset. In the project window, right-click the Assets folder, select Create Folder, and name the new folder UI. Right-click the UI folder and select Create UI Toolkit GAU document. Name this new asset UI Layout.
Okay, I think it's under this one.
Link the asset to the scene's UI document. Select the Game UI game object in the hierarchy window. Select the source asset picker and select the UI layout asset. Explanation. A UI document game object in the scene is what
Let me. I have to frame this thing. Okay, fine. This is selected now.
what actually displays the interface during gameplay. A UXML asset, like the UI layout asset you just created, defines the structure and layout of the UI. You won't actually see any UI elements on the screen yet. You've just created the UI container that will hold your score display. 6.
Okay, I'm marking this now. Take the score level.
6. Add the score label. With the UI container set up in your scene, the next step is to design the actual interface that'll display your score. You'll do this using the UI Builder window, a drag-and-drop editor for creating UI layouts visually. In this step, you'll add a label, give it a clear name, and set some placeholder text. 1. Open the UI layout asset in UI Builder. In the project window, double-click the UI layout asset you created earlier. This opens the UI Builder window, which contains a live viewport window, similar to the scene view, a library window, similar to the project window, a hierarchy window, and an inspector window, just like the Unity editor. 2. Add a label to the UI. From the library window, usually on the left, drag a label element into the hierarchy window. You'll now
let me go. From the library window. Yeah, the library window. Okay, let's see. Okay, yeah, I have to search.
See a text label appear in the viewport window that says Label by default. B. Rename the label to Score Label. In the hierarchy window of the UI Builder window, select the new label element. In the inspector window on the right, rename the label element by setting its name at the very top of the inspector panel to score label. Spelling is important here. You'll use this
Score level, fine.
this name in your script to reference the label later. In the attributes section, in the text box, change the placeholder text to score 0. Save and preview your changes. Press CTR.
Okay, we are going to call this code 0. Okay, fine. Save it.
CTRL plus,
Now I guess score 0.
CMD plus, to save the UI layout asset. You can
Score
now
0
close
out.
and minimize the UI builder window. Back in the Unity editor, you will see the score, 0 text appear in the upper left corner of the screen. Though it may be hard to see against a dark background, you'll fix that next. 7.
Okay.
Style the label. By default, UI elements added in UI Builder are small, plain, and usually tucked in the upper left corner. In this step, you'll center the label horizontally and give it some visual breathing room using inline styles. Direct style settings applied to individual UI elements. 1. Reopen the UI layout in UI Builder if closed. In the project window, double-click the UI layout asset to reopen it in the UI Builder window. Tip: if the viewport window looks zoomed or misaligned, select Fit Viewport at the top of the window to recenter it. 2. Select the score label in the UI hierarchy panel. In the hierarchy window, select the score label element you created earlier. 3. Apply basic layout styling. In the inspector window on the right side, expand the inline style section. Under position, set the top offset to around 20px pixels.
Okay, I expanded inline styles, okay. Under position. Display, okay. That's it. Line self.
The score down a bit so it's not overlapping the top border wall. Under Align Self, select Center to center the label horizontally. 4. Adjust the font and text color in the Text section of the Inlined Styles section. Try the following changes. Set font size to something like 20. Select a color that contrasts well with your background. Optionally, add font style like bold if you want the score to stand out. Press CTRL plus, macOS, CMD plus, to save the UI layout asset and return to the Unity editor.
Okay, fine. Now again, service. The hiding is relative 1,001. Very centric. It's okay. Oh, black color is okay. Black color is very good. Huh. Ask again. Oh, fine. The reference for you just now. Okay, I will do some after some time because I want to do some.
Meet Agentforce 360, Learning Objectives. After completing this unit, you'll be able to explain what Salesforce does, summarize how Agentforce 360 can help you become an agentic enterprise, describe how Salesforce brings autonomous AI agents, unified data from any source, and leading CRM apps together on one integrated platform. What's Salesforce Agentforce 360? Let's start with the basics. What does Salesforce do? Salesforce provides the tools that help businesses manage customers, data, and AI agents in one trusted system, enabling humans and agents to work together. Since 1999, our mission has been to help companies connect with customers in new ways with our leading customer relationship management, CRM, solutions. Now, we're revolutionizing how businesses operate by integrating artificial intelligence, AI, throughout the entire organization, helping businesses become agentic enterprises. Agentic enterprises are defined by humans and agents working together to drive customer success, all from one trusted platform that boosts performance and streamlines processes for better outcomes. With Salesforce, any organization of any size in any industry can become an agentic enterprise to enhance customer experiences, simplify operations, and influence growth. Companies are eager to employ this technology to transform their businesses. However, more than half of AI projects fail to reach completion due to high costs, slow return on investment, ROI, or concerns about trust and data security. Salesforce addresses these challenges to ensure that your AI initiatives not only launch but also deliver tangible results. In fact, an independent report from industry analyst Valoir found that Agentforce helps organizations deliver autonomous AI agents an average of 16 times faster, with 75% higher accuracy than do-it-yourself approaches. That's where Agentforce 360 comes in. It's our entire suite of products and services that brings together your apps, data, and AI agents in one unified platform. This powerful combination allows humans and agents to work together seamlessly. Joining the precision of technology with the empathy of human interaction leads to faster problem resolution, more personalized customer experiences, better business processes, and a more cohesive and effective team. Agentforce 360 brings together three powerful, deeply unified layers, designed to keep every customer at the center and connect every experience with data and AI. Customer 360 App Layer provides the trusted foundation for core business apps, sales, service, marketing, commerce. Data 360 Data Layer offers a complete, trusted, real-time view of every customer, product, and interaction. Agentforce 360 Platform, Agentic Layer, brings AI agents into every workflow, augmenting every employee and customer. In short, Salesforce is the first AI CRM, helping you become an agentic enterprise, where humans and agents drive customer success together. How is Agentforce 360 different? Agentforce 360 stands out as the only integrated platform that brings together humans, data, and AI agents on one deeply unified platform. All built on a foundation of trust, context, and collaboration, the platform ensures that agentic systems can successfully and safely move from experiment to operation. Agentforce 360 is the system of intelligent action that makes the agentic enterprise real. The following describes how it makes a difference for your business. Grow customer relationships. Agentforce 360 helps you better understand and serve your customers by giving every employee and AI agent full context of your business and customers. With Agentforce intelligence embedded in every app, AI agents autonomously reason and act proactively on your behalf. Built on a foundation of trust and governance, Agentforce can reference real-time and historical customer data, like past purchase history and performance, to create highly personalized content and responses, delivering stronger relationships at scale. This marks the shift from simply managing relationships to intelligently acting on them. Boost employee productivity. Agentforce 360 enhances your employees' capabilities, ensuring every function is elevated. Agentforce partners directly with employees inside your Customer 360 and in conversational interfaces like Slack, autonomously reasoning, and collaborating to handle routine tasks. For back-office operations, Agentforce safely automates complex actions by inheriting the capabilities of trusted workflows. Built on trust and governance, this intelligence empowers every employee to achieve more. Improve business margins. By unifying all your data and embedding AI with trust and context across every business process, Agentforce 360 helps you eliminate friction and elevate performance, ensuring profitability scales safely and consistently. With Agentforce 360, businesses are able to simplify and automate processes, make better data-driven decisions, improve customer satisfaction with deep personalization, and ultimately increase profitability. Salesforce isn't just the world's first CRM. It's a deeply unified, holistic, and open platform that helps businesses thrive in the age of AI. It's the only enterprise AI platform that connects your apps and data to your AI agents with no training of models required. Salesforce is foundationally integrated to drive action across your data and applications. By uniting your data on one platform and using AI throughout CRM apps for every department, Salesforce ensures that your customer relationships, employee performance, and business outcomes are optimized for success. Ready to dive deeper? Continue on to explore how Salesforce can transform your business.
So, doing it by myself now. The points I achieved, nice. Okay, it's time to take a break. Okay. And after break, I will do a course of Salesforce. You can see here, this is linear learning. And you will follow me on LinkedIn. If you haven't followed, please follow me. Okay. And I'm going for this. First all cell operation. Okay, this was there, and this was there. Okay. This was drawing structure machine learning project. Structure machine learning project. Promise more neural networks. Metaphors that develop from back and front script. I will do it, okay? Starting from this.
Course, and this is a great course and one of the easiest certifications to get. So this particular course covers a lot of theory, but you do not worry, we are going to cover all that and more. We are going to have some real life examples and I'll show you the power of AI, so you won't feel bored. And also this course is very engaging and a lot of practical illustrations will be covered in this particular course. So let's go ahead and get a quick overview of what the exam is.
Okay, fine. I will continue it this time. Okay, starting with
Is all about, and also how many questions do come. So how many questions particular course. Hello guys, welcome. This is Deepika from mytutorialrack.com and I welcome you all to this new course on Salesforce AI Associate Exam Preparation course. And this is a great course and one of the easiest certifications to get. So this particular course covers a lot of theory, but you do not worry. We are going to cover all that and more. We are going to have some real life examples and I'll show you the power of AI. So you won't feel bored. And also this course is very engaging and a lot of practical illustrations will be covered in this particular course. So let's go ahead and get a quick overview of what the exam is all about and also how many questions do come. So how many questions are there in the exam? There are about 40 questions in the exam and the passing percentage is about 65%. So you have to have minimum of 65% in order to pass this exam. There is no particular prerequisite. You do not need any certification before this particular exam, but the recommendation is basically to have the Salesforce certified associate certificate in order to do it, but it's not a prerequisite. And in other places, you can either take this exam online or you can go to one of their centers and give this exam. And the last and not the least is the fees is about $75 to take this exam. So this is about the overview of the exam. Now let's talk about some of the topics that are covered in this exam. So there are 4 categories of the topics. So one is the fundamentals of AI and the exam percentage is about 17%. And then the second one we have is what are the different capabilities of AI in CRM, that is 8% of the exam. So this is total of about 25%. Now the 2 main topics in this exam are the ethical considerations of AI, means how ethically we have to use AI because the power of AI is huge. Through AI you can do a lot of things, but you have to be ethical with all of that. And the other topic is the data for AI, how important the data is to feed the information to the AI so that it can predict better results, it can generate better results. So these 2 topics are the main meat, I would say, for the exam. So we would be focusing on these 2 topics more because that covers about approximately more than 70% of the exam. So we have to be acting smart here. So we will focus more on these 70% of the exam, whereas we will cover some theory from both the other topics as well. So don't worry, I'm going to cover each and everything, and you will definitely going to pass this exam by just taking this particular course. We will also have a lot of question answers along the way, so you'll keep it your knowledge check, and also we'll be adding a practice test with a bunch of questions. So stay tuned for that. I'm going to see you in the next video. We will get started as soon as possible. Thank you and have a wonderful rest of the day. Bye-bye. Take care. Hello guys, welcome. This is Deepika from mytutorialrack.com and I welcome you.
How should I refresh it? Oh, no. Not even though it's all.
कंप्यूटर क्या है सर? एक इलेक्ट्रॉनिक डिवाइस है दैट एक्सेप्ट्स डेटा, किसी डेटा को जैसे इनपुट लेगा, प्रोसेस इट अकॉर्डिंग टू इंस्ट्रक्शन, जो भी हमारी इंस्ट्रक्शन है, जैसा भी हमने वहां प्रोसेस करने के लिए बोला है, उसको प्रोसेस करेगा एंड देन प्रोड्यूस आउटपुट, उसको आउटपुट प्रोड्यूस करने वाला है। फंडामेंटली तो यही है, मैं उसको इंटरनेट से कनेक्ट कर रहा हूँ या मैं उससे एक्चुअली क्या काम कर रहा हूँ अलग बात है। हम डेटा इनपुट देंगे, वो डेटा को प्रोसेस करेगा, बेस्ड ऑन दैट आउटपुट आएगा। जैसे मान लीजिए यहाँ पे कीबोर्ड से कुछ इनपुट हम देने की कोशिश कर रहे हैं, सीपीयू उसको प्रोसेस कर रहा है, जो भी हमने एडिट किया फाइनल रिपोर्ट हमने प्रिंट आउट निकाल ली। दैट इज द बेसिक आइडिया। तो यही बात देखिए आगे मैं लिख रहा हूँ। कंप्यूटर क्या फॉलो करता है सर? 3 स्टेप की प्रोसेस है, इनपुट लेगा, प्रोसेस करेगा, आउटपुट करेगा, है ना। अब कंप्यूटर किन 2 चीजों से मिलकर बना है? अगेन कभी मुझे लगता है बहुत फंडामेंटल बात है, बट बेसिक्स एकदम क्लियर होने चाहिए एंड नोबडी नोस किसको क्या कंफ्यूजन वो भी क्लियर हो जाए तो बेटर है। इससे पहले कि हम कॉम्प्लेक्स टॉपिक पढ़ें तो 2 चीजें हैं सर, एक है हार्डवेयर, एक है सॉफ्टवेयर। व्हाट इज हार्डवेयर? जैसा आप देख रहे हैं द फिजिकल मशीनरी, जो भी चीज जिसको आप टच कर सकते हैं, है ना। तो जैसे मैं बोलूं बॉडी और सोल वाली तो ये शरीर और आत्मा है ना। तो अगर ह्यूमन है, इंसान है, हम बोल सकते हैं शरीर क्या है? शरीर हार्डवेयर है और आत्मा क्या है? आत्मा सॉफ्टवेयर है। तो वही लॉजिक यहाँ पर है, जो भी हमारी चीजें हैं, चाहे वो कीबोर्ड है, माउस है, सीपीयू है, प्रिंटर है, जिस चीज को आप टच कर सकते हैं सर दैट इज हार्डवेयर। अभी आगे अगले चैप्टर में इसमें डिटेल में भी हम बात करेंगे। और सॉफ्टवेयर क्या है? जो हमारी इंस्ट्रक्शंस है, जो हमारा कोड है, जो सीपीयू के अंदर एग्जीक्यूट हो रहा है, दैट इज इंस्ट्रक्शन पार्ट। इसको भी आगे ताकि फर्दर हम डिवाइड करने वाले हैं, है ना। तो थोड़ा सा डिटेल में पहले समझते हैं हार्डवेयर क्या होता है। तो जैसे मैंने बोला फिजिकल टेंजिबल कंपोनेंट्स ऑफ अ कंप्यूटर। टेंजिबल मतलब जिसके होने ना रहने से फर्क पड़े और जिसको फिजिकली टच कर सके, है ना। एक डीपीएस में टॉपिक पढ़ते हैं टेंजिबल एंटिटी, वाला आइडिया है। इनपुट डिवाइसेस हो सकते हैं, जैसे आप अलग-अलग तरह के सभी कुछ हार्डवेयर है, स्कैनर है, कीबोर्ड है, माउस है, प्रिंटर है, स्पीकर्स है, मॉनिटर है, ये सब के सब हमारे हार्डवेयर डिवाइसेस है। तो इसकी आप चाहो तो फर्दर कैटेगराइजेशन कर सकते हो। कुछ हो सकते हैं इनपुट डिवाइस, एक हो सकता है प्रोसेसिंग जो हमारा सीपीयू है, ये जो पूरी की पूरी कैबिनेट है, वैसे तो इसको हम सेंट्रल प्रोसेसिंग यूनिट बोलते हैं, बट यहाँ पर आप यहाँ इस वाली इमेज में नजर नहीं आ रहा, वरना एक और छोटा सा जो एक्चुअल प्रोसेसर है, प्रोसेसर भी यहाँ पर होता है। आउटपुट डिवाइस, जैसे मैंने ऑलरेडी आपको बोला स्पीकर वगैरह सब आउटपुट डिवाइस है। उसके बाद ये जो हमारी मेमोरी आपको नजर आ रही है सेकेंडरी मेमोरी, ये भी एक तरह का हार्डवेयर है। तो सारी की सारी चीजें हार्डवेयर के अंदर आती हैं, आगे जाके समझेंगे इसका फर्दर कैटेगराइजेशन हम कर सकते हैं। बात कर लेते हैं सॉफ्टवेयर की। हाँ, इसमें थोड़ा सा डिटेल में चीजों को समझना जानना जरूरी है। अब सॉफ्टवेयर क्या है? तो अगर मैं इसको बहुत बेसिक से आपको समझाऊं तो एक होता है सीक्वेंस ऑफ इंस्ट्रक्शन इज नोन एज अ प्रोग्राम। आपने भी हो सकता है कभी ना कभी कोई प्रोग्राम लिखा हो, बिल्कुल सिंपल भाषा में बोलूं 2 नंबर को ऐड करने का, तो a + b 2 नंबर को ऐड करते हैं, रिजल्ट आएगा। एक बहुत साधारण सा प्रोग्राम हो सकता है, ठीक बात है। तो ये सबसे सिंपल एक कंप्यूटर प्रोग्राम है जिसके बारे में मान लीजिए हम कल्पना कर सकते हैं, इसके बारे में सोच सकते हैं। अब एक प्रोग्राम जो है वो सॉफ्टवेयर का बन जाता है, तो बात सॉफ्टवेयर इंजीनियरिंग बोलते हैं। प्रोग्राम या ऐसा लिखूं मैं, अ सॉफ्टवेयर इज एक्चुअली अ प्रोग्राम प्लस डॉक्यूमेंटेशन प्लस यूजर मैनुअल, है ना। तो जब उसके बाद प्रॉपर डॉक्यूमेंटेशन, क्योंकि वो सॉफ्टवेयर का कमर्शियल एंटिटी है, बाजार में बिकने वाला है वो, है ना। उसको लाइसेंस मिलेगा, जब हम कोई भी सामान खरीद के लाते हैं, अगर ठीक ठाक प्रोडक्ट उसके साथ एक यूजर मैनुअल आता है, बुकलेट आती है, जैसे आप पढ़ते नहीं है, बट बुकलेट तो आती है ना। उसी तरह सॉफ्टवेयर जब आप इंस्टॉल करते हैं, टर्म्स एंड कंडीशंस आता है, जिसको आप एक्सेप्ट करते जाते हैं, बस इंस्टॉल कर दो किसी तरह। जब ये सारी चीजें किसी प्रोग्राम के साथ हम लगा देते हैं, तब कहीं वो जाके सॉफ्टवेयर बनता है। यहाँ पर अगर बहुत सिंपल शब्दों में समझे, अगेन अभी हम डिटेल में नहीं जा रहे, तो 3 कैटेगरी हो सकती है। पहली कैटेगरी है सिस्टम सॉफ्टवेयर, मानो ऑपरेटिंग सिस्टम। देखो कंप्यूटर का जो हार्डवेयर है ना, क्या उस हार्डवेयर के साथ हम या एप्लीकेशन प्रोग्राम या कोई भी डायरेक्ट डील करता है? नहीं। हार्डवेयर के ऊपर डायरेक्ट इंस्टॉल्ड ऑपरेटिंग सिस्टम। ऑपरेटिंग सिस्टम मानो सिस्टम का का गुंडा है। तो हार्डवेयर के ऊपर सिर्फ ऑपरेटिंग सिस्टम का कंट्रोल ऐसे बोलते हैं, मैनेजर बोल सकते हैं, सिस्टम सॉफ्टवेयर बोल सकते हैं, जैसे विंडोज हो गया, मैक हो गया, लाइनक्स हो गया, एंड्रॉइड हो गया, ये सब हमारे ऑपरेटिंग। दूसरी कैटेगरी है हमारे एप्लीकेशन सॉफ्टवेयर जो होते हैं। एप्लीकेशन सॉफ्टवेयर में जो आमतौर पर मैं जैसे पावर पॉइंट प्रेजेंटेशन यूज कर रहा हूँ इस वीडियो को बनाने के लिए, है ना, ओबीएस स्टूडियो यूज कर रहा हूँ स्क्रीन रिकॉर्डिंग के लिए, ये सब हमारे एप्लीकेशन सॉफ्टवेयर। आप कोई गेमिंग खेलते होंगे, कोई गेम है, वीएलसी मीडिया प्लेयर है, जितने भी डे टू डे ज़ूम है, जितने भी डे टू डे एप्लीकेशन हम यूज करते हैं वो सबके सब किसमें आते हैं सर? दे कम इन द कैटेगरी ऑफ एप्लीकेशन प्रोग्राम। एक और कैटेगरी बीच की मध्य मार्ग से बोलता माना जा सकता है प्रोग्रामिंग सॉफ्टवेयर, जो आमतौर पर हम इंस्टॉल करते हैं, शायद उतना इस्तेमाल नहीं करते। टर्बो, सी प्लस प्लस, आईडीज होते हैं, प्रोग्रामिंग लैंग्वेज, जहां भी आप प्रोग्रामिंग करते हैं। अब उसको क्या बोलेंगे? क्या वो ऑपरेटिंग सिस्टम कोड कर रहा है, डायरेक्ट हार्डवेयर को हैंडल कर रहा है? नहीं, ऐसा तो नहीं कर रहा। लेकिन क्या वो एक सिंपल प्रोग्राम है या सिंपल एप्लीकेशन है? ऐसा भी नहीं है। तो दोनों के बीच का रास्ता है। तो आपको याद रखना है 3 तरह के हमारे सॉफ्टवेयर हो सकते हैं। कौन-कौन से होंगे सर? सिस्टम सॉफ्टवेयर मानो ऑपरेटिंग एप्लीकेशन सॉफ्टवेयर यूज करते हैं, चाहे वो एडोब पीडीएफ रीडर है या हमारे वर्ड है या फिर गेमिंग है। और तीसरा हमारा बीच की कैटेगरी इस चैप्टर में हम एक ये छोटा सा पॉइंट और है जिसपे बैक टू बैक जो हमारे टीचिंग वाले एग्जाम में खूब सारे क्वेश्चन पूछे जाते हैं। क्या है? कैरेक्टरिस्टिक्स क्या है? देखिए, जब भी हम किसी चीज को बनाते हैं उसका कुछ स्टैंडर्ड होना चाहिए ना। एक गाड़ी अच्छी होगी अगर वो अच्छा माइलेज देगी, या अगर वो अच्छी सेफ्टी रेटिंग्स उसके पास होंगे, उसके कुछ फीचर्स होंगे। ये कोर्स आपको अच्छा लगेगा अगर वीडियो बहुत सिंपल लैंग्वेज में पढ़ाई गई हो, समझाई गई हो, आप रिलेट कर पाए उनके साथ। इन वीडियोस को देख के जो प्रीवियस ईयर क्वेश्चन आ रहे हैं एग्जाम में, जिसके लिए हम तैयारी कर रहे हैं, वो सॉल्व कर पाए, तब तो लगेगा ना। ठीक उसी तरह कंप्यूटर के भी कुछ कैरेक्टरिस्टिक्स है ना, कुछ वो फीचर जो हम एक्सपेक्ट करते हैं कि अच्छा कंप्यूटर जो उसको सेटिस्फाई करेगा, और इनके ऊपर क्वेश्चन है। इंपॉर्टेंट चीज़ तो देखिएगा, सबसे पहली चीज़ क्या है? स्पीड। तो कंप्यूटर किसी नॉर्मल फिजिकल डिवाइस की तरह स्लो चलता है कि इसकी स्पीड बहुत ज्यादा है। सर कंप्यूटर की स्पीड मिलियंस ऑफ इंस्ट्रक्शंस पर सेकंड, इनक्रेडिबली फास्ट कंपेयर टू ह्यूमन। सर बोलता हूं कम लिखा हुआ है, आप चाहे तो अभी देख सकते हैं। अगर आप लैपटॉप का इस्तेमाल कर रहे हैं, आपके पास होगा, आपने भी देखा तो होगा एक लैपटॉप। आमतौर पे जो लैपटॉप आपको मिलेंगे सर वो 1.3, 2.3, 4 गीगाहर्ट्ज के मिलते हैं। 4 गीगाहर्ट्ज का मतलब समझते हैं? गीगा इज 2 रेज़ टू पावर, आई एम सॉरी, इट इज 10 रेज़ टू पावर 9। 4 गीगा और 9 मान मोटा-मोटा अगर आसान भाषा में बोलूं 400 करोड़, एंड हर्ट्ज इज द यूनिट ऑफ फ्रीक्वेंसी। आपका जो लैपटॉप है अगर वो 4 गीगाहर्ट्ज का प्रोसेसर उसके पास है, तो सर वो 1 सेकंड में 400 करोड़ इंस्ट्रक्शन एग्जीक्यूट कर सकता है, या एटलीस्ट 400 करोड़ बार साइकिल क्लॉक करता है। तो कैन यू इमेजिन द स्पीड? क्या इस स्पीड पे कोई भी फिजिकल डिवाइस आप इमेजिन कर सकते हैं? सर नहीं कर सकते, है ना। सो दैट इज एन आइडिया, वेरी इंपॉर्टेंट। तो कंप्यूटर की खास बात क्या है? उसकी स्पीड बहुत शानदार है। एक्यूरेसी 100% करेक्ट रिजल्ट, 100% थोड़ी सी अतिशोक्ति हो गई, मेटाफर हो गया, बट स्टिल एरर हैपन ड्यू टू रॉन्ग इनपुट्स। समझाता हूं इस बात को। देखिए, जो फिजिकल नेचर के डिवाइस होते हैं ना, लैपटॉप या हमारा जो कंप्यूटर है वो इलेक्ट्रॉनिक डिवाइस है ना। जैसे मान लीजिए फिजिकल कंपास है, हम फिजिकल कंपास देख के पता लगाते हैं नॉर्थ डायरेक्शन कहां पे है। बट मान लीजिए अगर कहीं से बिजली का तार जा रहा है, उसका एक मैग्नेटिक फील्ड है, क्या हो सकता है आपकी कंपास की रीडिंग गड़बड़ कर दे? सर कर सकता है ना। रेडियो है, एक फिजिकल डिवाइस है, एनालॉग डिवाइस है, बट अगेन उसकी भी रेडिएशन कहीं कैसे आ रही है, सिग्नल ठीक से आ रहा है कि नहीं कर सकता है, बिकॉज एक इलेक्ट्रॉनिक डिवाइस है। तो एक्यूरेसी और प्रिसिशन बहुत हाई होगा, किसी भी तरह के नॉइज से, डिस्टर्बेंस से डिस्टर्ब नहीं होगा, अपनी परफेक्ट कैलकुलेशन करेगा, प्रिसाइज वैल्यू आपको निकाल के देगा। तो एक्यूरेसी का मतलब सिर्फ रिजल्ट निकालना नहीं, बार-बार सेम रिजल्ट जनरेट करने की कैपेसिटी भी है, तो एक्यूरेट होता है, बड़ा इंपॉर्टेंट पॉइंट है। अगला पॉइंट आप देखेंगे डिलीजेंस, इंपॉर्टेंट पॉइंट है, प्रीवियस क्वेश्चन में कई बार ये टर्म पूछी जाती है। थकता नहीं है, टायर्ड नहीं होता। हाँ, अब मान लीजिए आप बहुत सारा एक दिन में सारा कोर्स कंप्लीट नहीं करेंगे, अभी थोड़ा-थोड़ा पढ़ेंगे, फिर कुछ क्वेश्चन सॉल्व करेंगे, मे भी कोई टेस्ट अटेम्प्ट करेंगे, फिर थक जाएंगे कि आज के लिए हो गया, थोड़ा रेस्ट करते हैं, थोड़ा ब्रेक लेते हैं। कंप्यूटर के साथ ऐसा है कैसे? कंप्यूटर के साथ ऐसा नहीं, कंप्यूटर कभी टायर्ड नहीं होता, है ना। तो बड़ी इंपॉर्टेंट बात है, इसको बोलते हैं डिलीजेंस। स्पेलिंग ध्यान रखिएगा, नेवर गो टायर्ड। आप 24 घंटे काम करा सकते हो। मेरा लैपटॉप ही है, मेरे को आदत है, मैं कभी शट डाउन नहीं करता आज तक। शायद कुछ होता है ना, कुछ गड़बड़ हो गया तो रीस्टार्ट कर दिया। मेरे ख्याल से जब से मैं लेके हूं शायद ही कभी मैंने इसे टच किया, है ना। तो कोई जरूरत नहीं है, तो थकता नहीं है, लगातार इंसान थक जाएगा, मशीन नहीं थकेगी, वो एडवांटेज है कंप्यूटर का। वर्सिटैलिटी बहुत इंपॉर्टेंट पॉइंट है। क्या कंप्यूटर किसी डेडिकेटेड काम के लिए बना है? जैसे मैं एग्जांपल बताता हूं, बहुत सारे इलेक्ट्रॉनिक डिवाइस है। अब मान लीजिए लेट मी से ये एक रिमोट है ना। ये जो लाइट है मैं ऑन ऑफ करके दिखाता हूं, आपको समझा ऑफ हो गई। तो ये लाइट का एक रिमोट है मेरे पास, ठीक बात है। आप मुझे बताइए कि जरूरत पड़ने पे इससे मैं टेंपरेचर नाप सकता हूं, या इसमें कोई और काम कर सकते हैं, 2 नंबर को सम करने का प्रोग्राम लिखा सकता हूं? नहीं। तो जितने भी फिजिकल इलेक्ट्रॉनिक डिवाइसेस भी हैं, डेडिकेटेड डिवाइस जो हैं, एम्बेडेड सिस्टम जो हैं, उनका अपना एक काम है जो तय है ना। लेकिन कंप्यूटर जिसे हम बोलते हैं वो वर्सेटाइल है। वर्सेटाइल का मतलब वो जो कर सकता है तो कर ही सकता है, आप सॉफ्टवेयर के थ्रू तो कुछ कर ही सकते हैं। आपको मतलब नहीं मेरे को कुछ अलग करना है, तो क्या आप प्रोग्राम लिख के भी उस काम को कर सकते हैं? क्या सर कर सकते हैं। तो जो भी चीज पॉसिबल है कंप्यूटर वो कर सकता है, तो वर्सेटैलिटी है ना। मानो सब कुछ करने की क्षमता रखना, ये कर सकता है। देन हाई स्टोरेज कैपेसिटी, वेरी इंपॉर्टेंट पॉइंट। वैसे आगे हमें मेमोरी यूनिट्स पे बहुत डिटेल में बात करनी है, बट ये बड़ा इंपॉर्टेंट आइडिया है सर। इस बात का मतलब क्या है? स्टोरेज कैपेसिटी इन टर्म्स ऑफ मेगाबाइट एंड गीगाबाइट। अगर हम उनको फिजिकल रिकॉर्ड्स में बुक्स को बना के रखें, कितना स्पेस ऑक्यूपाई करेगा? सो पूरा का पूरा दुनिया में जितना डेटा है वो सब कुछ हमारे कंप्यूटर्स में, हम उनको सर्वर कह रहे होते हैं, बट है तो बड़े किस्म के कंप्यूटर ही, उनमें स्टोर हो रहा होता है ना। तो ये कुछ 4-5 ऐसे एडवांटेज है, शायद दैट इज द रीजन बिकॉज़ ऑफ व्हिच सारी चीजें हार गई हैं कंप्यूटर से, और आजकल हम अपना ज्यादातर समय कंप्यूटर्स के साथ ही बिता रहे होते हैं, है ना। तो आई थिंक बेसिक अंडरस्टैंडिंग आपको क्लियर हुई होगी कंप्यूटर क्या है। वैसे मैं वही बोल रहा हूं, फनी बात है, बताने की जरूरत नहीं है, फंडामेंटल क्लियर है, बट फिर भी कुछ पॉइंट्स मैंने क्लैरिटी आपको दी है, आपको समझेगा। अब जब आप आगे क्वेश्चन सॉल्व करेंगे, आपको लगेगा हाँ यार इसी तरह के क्वेश्चन आ रहे हैं, मेरी अंडरस्टैंडिंग है। कंप्यूटर क्या है, हार्डवेयर क्या होता है, सॉफ्टवेयर क्या होता है, और कंप्यूटर की बेसिक 5 कैरेक्टरिस्टिक्स। यस, ओके, थैंक यू।
हेलो एवरीवन, मैं अभिषेक आप सभी का नॉलेज गेट पे स्वागत करता हूं। अब हम लोग आगे फर्दर प्रोसीड करेंगे। विच ऑफ द फॉलोइंग रिप्रेजेंट द स्पीड कैरेक्टरिस्टिक ऑफ द फॉलोइंग। इसके बारे ये कोई लास्ट टाइम हम लोग ने डिस्कस किया था एक्यूरेसी के बारे में, अब हम लोग डिस्कस करेंगे स्पीड के बारे में। तो सबसे पहले हम लोग ऑप्शंस को पढ़ते हैं। जो कि है फर्स्ट ऑप्शन हमारा, कैलकुलेशन एंड जनरेशन ऑफ सैलरी स्लिप ऑफ थाउजेंड्स ऑफ एम्प्लॉयज। यहाँ पे मैंने लास्ट क्वेश्चन में भी बताया था, सेम ऑप्शन है। ये बल्क डेटा हैंडलिंग की बात करेगा, किसकी बात करेगा, ये किसकी बात कर रहा है हमारा, यहाँ पे बल्क डेटा हैंडलिंग की बात कर रहा है, ठीक है। जो कि हमारा ऑप्शन बी है, वो हमारा किसकी बात कर रहा है, ये हमारा किसकी बात कर रहा है, एक्यूरेसी की। ये जो हमारा बी वाला है ये हमारा किसकी बात कर रहा है, एक्यूरेसी की। अब अप टू हाउ मेनी 10 डेसिमल प्लेसेस तक वो क्या कर रहा है, डिवीजन आंसर वो प्रोवाइड कर रहा है आप सभी को। तो ये कितना एक्यूरेट है, बी वाला ऑप्शन बताएगा। अब हम लोग थर्ड पे बात करेंगे, जो कि हमने बताया भी था, परफॉर्मिंग लॉन्ग कॉम्प्लेक्स कैलकुलेशन विद सेम स्पीड एंड एक्यूरेसी। बेसिकली ये स्पीड के साथ साथ कंसिस्टेंसी की भी बात कर रहा है, स्पीड प्लस कंसिस्टेंसी, ठीक है, स्पीड के साथ साथ एक कंसिस्टेंसी की बात कर रहा है, तो इसको हम लोग कंसीडर कर सकते हैं। चलिए अभी इसको पॉज लेते हैं, अभी हम लोग नेक्स्ट ऑप्शन भी देखेंगे जो कि सेम ऑप्शन है लास्ट क्वेश्चन वाला ही, तो हमारा करेक्ट आंसर ही हमारा सी होगा। लास्ट ऑप्शन को भी हम लोग डिस्कस कर लेते हैं, परफॉर्मिंग डॉक्यूमेंट एंड देन प्लेइंग म्यूजिक। बेसिकली इस पर मल्टीटास्किंग की बात हो रही है। किसकी बात हो रही है यहाँ पे? मल्टीटास्किंग की यहाँ पे बात हो रही है, ठीक है, यहाँ पे मल्टीटास्किंग की बात हो रही है। सो मेरे हिसाब से आंसर सी है। लेट चेक करते हैं हम लोग आंसर क्या हो सकता है। सी को मैंने टच किया एंड दिस इज द करेक्ट वन, ठीक है। आप सभी को समझ में आया? इफ एनी डाउट तो आप कमेंट कर सकते हैं, मैं उसका भी जवाब बाद में दूंगा, ठीक है। थैंक यू।
Okay. Yeah, submit it in your the server is taking a lot of time to open. Microcontroller. Controller a single chip is called microcontroller. Okay, microcontroller now. Okay. Okay.
I just give a character. People in the last one. Okay. Yeah, yeah.
The various devices speed and circuits. Buffer registers. It's very simple. Buffer registers. So value is not running with the right there just speed. This is the buffer registers.
To overcome differences in data transfer speed between devices, buffer registers are used. These registers temporarily store data when the receiving device is not ready, allowing the sender to continue without waiting. This helps synchronize data flow between devices operating at different speeds. Multiple buses increase data throughput but do not address speed mismatches. Speed-enhancing circuitries boost processing speed but do not manage data timing. Therefore, only buffer registers are specifically designed for this purpose. विभिन्न उपकरणों में डेटा ट्रांसफर गति के अंतर को दूर करने के लिए बफर रजिस्टर का उपयोग किया जाता है।
ये रजिस्टर तब डेटा को अस्थायी रूप से संग्रहित करते हैं जब ग्राहक उपकरण तैयार नहीं होता है, जिससे भेजने वाला उपकरण इंतजार किए बिना जारी रख सकता है। इससे विभिन्न गति पर काम करने वाले उपकरणों के बीच डेटा प्रवाह को संशोधित किया जा सकता है। मल्टीपल प्रोसेसिंग डेटा थ्रूपुट बढ़ाती हैं, लेकिन गति अंतर को नहीं दूर करती हैं। गतिवर्धक परिपथ प्रोसेसिंग गति बढ़ाते हैं, लेकिन डेटा समय को प्रबंधित नहीं करते हैं। इसलिए केवल बफर रजिस्टर किस उद्देश्य के लिए विशेष रूप से डिजाइन किए गए हैं।
Plus 3. Standard के BPS 1.8 and BPS is really challenging. You can do well. Hmm. 1.3 at MPS. It's 150 kbps. So this always 150 kbps. DD is 1.3 kbps. So that option not yes. Okay. Okay. I will do after some time. I'll do some specific time. Okay. Feeling very sleepy now. Good night. See you tomorrow. Bye.